Welcome to SQL Server 2022 Administration Inside Out. My name is Eric Johnson, and I'm here to help give you the knowledge and tools you need to correctly and effectively manage SQL Server in your environment. By the end of this course, I hope you'll have a newfound appreciation for SQL Server and a better idea of how to manage it. Over the years, I've worked with SQL Server in many different capacities. As a developer, I've written applications that utilize SQL Server databases. As a database architect, I have designed databases that SQL Server hosts, and I've also supported third-party applications that use SQL Server as a backend. In addition, I've spent my fair share of time working as an actual database administrator, and I'm here to teach you what I can about administering SQL Server. Let's talk about the game plan. We start by introducing SQL Server, its tools, its components, how to install it, and we talk about SQL Server instances, database tools, and we look at database server components, including common configuration options for the database engine, and we'll take our first look at security and high availability. Next, we look at provisioning SQL Server and Azure SQL databases. We'll give you everything you need to know about setting up and configuring your SQL servers, plus the basics of working with setting up Azure databases. Securing SQL Server is absolutely critical, so we'll look at implementing and managing SQL Server user security and permissions, and how to secure the server itself, and we'll take a peek at data encryption and data masking. Next, we cover designing, tuning, and optimizing SQL Server. We'll look at database design, performance tuning, including indexes, statistics, and look a little bit at isolation levels and execution plans. We then move on to managing data recovery and implementing SQL Server high availability. You'll learn to develop, deploy, and manage data recovery strategies to ensure high availability of your servers, as well as how to recover when disaster strikes. Finally, we cover managing, monitoring, and automating SQL Server. You'll learn to manage your databases day to day and monitor activity to keep your servers performing in peak condition. We'll also look at ways to automate SQL administration, including through the use of PowerShell. Now, I know that's a lot of ground to cover, but remember, just go at your own pace and work along with me. I'm excited to get started, but before we do, I want to say thank you for choosing this Inside Out series and for choosing to learn from me. I hope you gain the knowledge you're looking for, on which you can form a foundation to build over the years. With that, let's dive in. Let's take a look at SQL Server 2022 tools and components. You learn how to install SQL Server instances and use development tools. We then look at database server components, including common configuration options for the database engine, and our first look at security and high availability. Welcome to our lesson on installing and using SQL Server administration and development tools. This lesson will give you information you need in order to install SQL Server and provide an overview of the various tools that come with a product. This lesson will help you to understand the SQL Server Installation Center and find all the tools installed with SQL Server. We'll also take an in-depth look at a few specific tools, namely the performance and reliability tools, in addition to the SQL Server Management Studio and the SQL Server Data Tools. Let's get started. So anytime that you're going to install a new version or instance of SQL Server or change features or anything that involves adding features, function, anything like that to a SQL Server installation, you're going to use the Installation Center. Now, if you've used previous versions of SQL, this will look very familiar to you. So here, you can see that I've downloaded the SQL Server 2022 installer. Now, this is the Developer Edition installer, which is a free version you can get for doing development. It's not licensed, so you can use this freely as you're developing and doing R&D type work for SQL Server. It's just very tiny. You'll see it's only about 4 meg, and that's because this is just sort of a shell. So let's double click this, and it's going to fire up a little window after a second here and gives you 3 options. Option number 1, basic. If I just click this, it'll essentially throw on a SQL Server instance with a SQL Server database and the default configuration, which is just a stripped down version if all you need is a SQL Server to host databases. I can also click custom. If I pick this one, it'll actually download the source files, launch the setup, and give me all the options that I need in order to install SQL Server, and I get to do pretty much anything I want. Lastly, you can just click Download Media. That just pulls the actual media down from the internet, puts it on your machine, and then you can install them later on. So for this, we're just going to go ahead and click Custom. It's going to ask me to download the media to a specific location, and if I click Install, you'll see here that it'll actually run through this part relatively quickly because I already have the files installed on my laptop. So it should not download them now and just go ahead and start the installer. There we go. You can see that it says download successful, and that took just a few seconds. And then it fires up the SQL Server Installation Center. Now, at this point, this should look familiar if you've used previous versions of SQL. And if you've used 2017 or later, what we just went through should also look the same. This particular installation center has been around forever. A couple pages, and I'll just sort of walk through what each of these mean. And in another lesson, we will go over installing SQL Server, and we will use this tool. So we'll come back to that later on. So this first page here, Planning, is just that. It's links to a lot of resources that can help you plan a SQL Server. Hardware and software requirements, security documentation, release notes, migration managers and migration assistants, you name it. This is all information that can help you if you're in the planning stage of setting up a SQL Server instance. The installation page is where you'll go to set up a new instance or modify an existing instance of SQL Server. So you can see here at the top, you can install a new standalone instance or add features. You can add reporting services, install the management tools, the data tools, so on and so forth, set up cluster stuff. All that's done right here on the installation page. And we will visit this in a lesson on installing SQL Server. Maintenance. This basically lets you do repairs or upgrades to existing editions. So literally just what it says. It's maintenance to your existing instances. Tools. This provides you a couple links. One's the system configuration checker, which will check your machine to see if there's anything that would prevent you from installing SQL. Do you have the right kind of hardware to run everything you need? You can also run this discovery report, which essentially shows you a report of all SQL Server projects and products that are installed. So you'll tell you what versions of SQL, what tools, etc. And there's also an assessment and planning tool, the map tool, which can help you migrate SQL Server from a different platform or a different SQL Server. Last couple things you'll find in the installation center here. Resources. This is sort of similar to planning. It's links off to other things that might help you set up SQL Server. You have the books online, which is basically the SQL Server documentation. You have the tech center, the developer center, license agreements, on and on and on. So if you need anything about how SQL works, or if you need to license your server, or if you need to register your SQL Server, those links can be found here under Resources. Finally, the Advanced tab. So this lets you do some stuff that would be a little more outside the box, so to speak. So Advanced Cluster Prep, so you can do stuff to help you prepare to install a SQL Server failover cluster. You can also install based on a config file. So you're able to take all the options you want in your install, put them in an INI file, and then you can run and install a SQL Server with the same settings over and over and over. That also lets you install silent installs of SQL. So everything that you can do for that is in here. You can also do image prep, which again lets you manage an image so that you can deploy SQL Server in multiple environments. Last but not least, you have this Options tab down here. And really all this Options tab does is let you point to where your installation media is. So if I wanted to use the installation media that I have locally, I can do that here. Otherwise, you can click the ellipses and go out and browse and find your installation media. So that's all the Options tab lets you do. Nothing too big. So that's the SQL Server Installation Center. There's not a lot to it as far as understanding where everything is, but it's a very powerful tool, and you will come back and you will revisit this tool over and over as you install SQL Server and modify your SQL Server configurations. So after you've set up and installed a SQL Server instance on your machine, you might be asking yourself, how do I manage this? How do I configure it? And where are the tools I can use to interact with it? Well, once you install the database server, that's really all you get is the database server and a few tools for configuring it. You don't have any of the other Microsoft tools available. So I'll show you in the Start menu here. If you open this up and you scroll down to Microsoft SQL Server 2022, you'll see under this folder, I have a configuration manager, an error usage and reporting manager, and basically an import-export tool and access to my installation center again. That's it. If you want the Microsoft tools, which I do have installed as well, here, Microsoft SQL Server Tools 19 is the version, you have to install these separately. So you'll see once I do that, I get Management Studio, Profiler, the Tuning Advisor, and a Deployment Wizard. Now these tools are installed through another installer that you'll download from Microsoft. And that installer here that I have is called SSMS, which stands for SQL Server Management Studio Setup. There are multiple versions of this. They sort of broke it away from SQL. So it used to be you installed your SQL, you got your Management Studio. Now you just have to grab the latest and greatest version of Management Studio, which as of the time of this recording is version number 19. That'll work with SQL Server 2022. So once you have that installed, you can launch the Management Studio. And again, that's just found back here under Microsoft SQL Server Tools 19. So I'll fire that up. This is the primary tool that you use to administer SQL Server. And throughout all the lessons, we will be coming back to this tool over and over again, because not only is it a GUI that allows you to manage the tool, it's also where you'll write queries. So if I go through anything too quickly here, there are other lessons that explain this tool in more detail. And as I said, we'll be using them quite a bit. So you'll see it fires up. I can just click Connect to get into my server. Here is my SQL Server, my SQL Inside Out instance. It has one database, worldwide importers, and if you need to run a query, I can right-click, select New Query. This window pops up, and now I can write all the SQL I want. The other tools that we'll install with this, the Profiler, which we'll look at in detail, allows you to track workloads and tune queries, see where things are slow, see where things might need to be improved. Now, the other set of tools that, depending on how long you've used SQL, you might have been familiar with a tool called Business Intelligence Development Studio, or BIDS for short. That was a tool that allowed you to write projects such as reporting services or integration services that interact with SQL Server in some way. That concept of Business Intelligence Development Studio is gone because essentially that was just a shell for Visual Studio. So now all those tools are available in Visual Studio. So I'm going to launch Visual Studio 2022, and you'll see this comes up to a pretty generic, hey, what do you want to do? What kind of project do you want to open? And I'll just open my Hello World solution because I need to get into the tool itself. So I'll even open this up, show you the code. It's a real simple Hello World app. There's a function called say hello, and it returns the string Hello World. But that's not important. What I want to show you is how you get access to the SQL Server tools from here. So you'll notice if I go to File and select New and say Project, this will come up and it'll ask me to look for templates, and I already have it filtered to SQL Server. The only one I have right now is the SQL Server Database project. That's here because when I installed Visual Studio, I installed the SQL Server data tools. So that's the first piece, is as you install Visual Studio, there's an option to install the data tools. So you'll do that, and it gets you access to the database projects. If you want any of the other ones, reporting services, analysis services, or integration services, those are now managed as extensions inside Visual Studio. So I'm just going to close this new project window, and I'm going to go up to the Extensions menu and hit Manage Extensions. That brings up the Extension Manager, but what we can do here is click on the Visual Studio Marketplace, and this takes me out to the internet and lets me see all these other plugins that are available and extensions that are available for Visual Studio. So if I search, for example, analysis, takes a second, and you'll see there is the Microsoft Analysis Services project for 2022. So I can download and install that plugin. I can do that with reporting services, and I can do that with integration services. Now, integration services took a minute to catch up to Visual Studio 2022. So it wasn't released until fairly recently, and you can see that in as of the time of this recording, this is still a preview extension. So if you look at this and it says preview, it essentially means it's the beta version of that particular extension. You can still download it. It should still work, but eventually there'll be a full-fledged release for that. So any of these that you need, if you go ahead and click download, that'll go ahead and download the installer to your whatever your local download repository is. And when that's done, all you have to do is open up your downloads and fire up this little executable, and that'll install the extension into your Visual Studio. Now it'll have you close Visual Studio, it'll do the install, and when you relaunch, you'll have access to those projects. So pick your language, easy enough. I'm gonna hit OK. And this basically just tells you what we're installing. You go ahead and click Next. It'll ask you which versions of Visual Studio you want to install this on. Sometimes they're backward compatible with other versions, or sometimes they're compatible with maybe you have Community and Professional of the same Visual Studio Edition. So you just pick the ones you want. In this case, I just want my 2022 Community Edition. And then you hit Install, and it'll yell at you and ask you to close all of these different things before you start your setup. Now, these are typically things related to Visual Studio and different service pieces. So we're going to go ahead and click OK here to ignore that for a second. And I'll close out Visual Studio back here. So I just have to close out my extension window, close Visual Studio, and now it should allow me to continue. And you'll see we go through a step where it loads the package. This just takes a couple of minutes, and that will load the integration services project into your Visual Studio environment. So because this was one of the first SQL Server projects I put on in my Visual Studio, it had to install a lot of components. And in addition to the SQL Server project, you probably saw a couple other things flash there. There were pieces and parts that are required in order to run these SQL Server projects. So because of that, you have to go ahead and restart your computer. So you click Restart, the computer will reboot, and after that's done, next time you go into Visual Studio, you'll be able to now create SQL Server integration services projects. So if you need integration services, or if you need analysis services or reporting services, the process will be the same. You'll add those extensions in Visual Studio, and you'll be up and running and good to go. So at that point, you'll be able to work with database projects, integration, reporting, analysis, and then your tools are already installed. So just as a recap, the SQL Server tools are going to be installed here under your Program menu, under Microsoft SQL Server Tools. Your Visual Studio extensions will be installed inside whichever version of Visual Studio you're using. And your real basic configuration tools are installed here in the Microsoft SQL Server 2022 folder. So that should give you enough information to find just about any tool that's installed as part of the SQL Server package. And then we'll be using these tools in other lessons to get things done. So hopefully, if you have any questions at any point and you need to know where things are, you can refer back to this lesson. So the first tool I want to take a look at in this lesson is the SQL Server Profiler. The SQL Server Profiler is a tool that, again, is installed with the SQL Server Microsoft Management Tools, and it allows you to profile queries on your system to see how they're performing. It's a fairly simplistic looking tool. As you can see, I have it open here. But what we'll do is we'll hit the New button, and this will pop up and ask me to set up a trace template. So what is it that I'm trying to analyze? So for server type here, I'll click this drop down, and you'll see I have all kinds of options of the different kinds of SQL Server I want to analyze. I'm going to go ahead and say Microsoft SQL Server 2019 because that's the latest available in this particular release of the tool set, and that's fine. And then I could pick a template, or I could make a new template name, and we'll just call this Inside Out Trace. And the important part of this is, what do you do in this event selection? So what is it that I'm trying to profile? Now there's two ways to do this. I can select these different things individually, or on that general tab, I can say, base my template on a new template type. So that's what I'm going to do, because this will give us some standard things that we can look at. So we'll go ahead and pick T-SQL as our template. And then if you go back to event selection, you should see down here, things have now kind of expanded. And as I scroll, you'll see certain things are checked. Audit login and audit logout are both checked. And if I go down further, you'll see existing connections, and then stored procedures starting, and T-SQL batch starting are all checked. So those are the events that I will capture. Now, going across to the right, these are all the columns, and that's the kind of data that will be captured if that event occurs. So when a T-SQL batch starts, I'll capture the text data, the SPID in SQL Server, and the start time. And you'll see as I go to the right, there's other things I could also capture: the application name, the client process ID, the database ID, database name. So we'll go ahead and capture the database name as well. So I'll just check that. And you'll see for some of these, you can track duration. Now you can't on a SQL batch starting because it's just started, has no idea how long that batch has run. But I could capture duration on a batch complete. So I'm going to do that. I'm going to check SQL Server batch complete. And you'll notice when I do that, it checks pretty much every box across for all the columns. So it's going to capture all those columns. And you can par that down and capture fewer if you so choose. I'm just going to go ahead and leave that alone. You'll see here you can also show all columns and all events. So this will hide the events that aren't checked if I uncheck show all events, and this will hide the columns that I don't have selected if I uncheck show all columns. But in this case, because of that SQL batch, we have them all selected. So I'll just clear show all events, and you can kind of see at a high level, here are the things that we're going to audit when we run this profile. So I'll just hit save. So now to actually do a trace and capture some data, I'll go ahead and click this button here, which is New Trace. This pops up and asks me which SQL Server I want to analyze. So in this case, it's going to be my database engine on my SQL Inside Out instance. I'll click Connect, and then this pops up, and this asks me what template I want to use, and this is going to look very familiar to when we looked at creating a template. You can pick one of these templates down here. I'll just select Standard, and if you don't like the things that Standard captures or you want to see it, you can click Event Selection tab. This should look just like the tab that we looked at when we created a template on our own. You can see what's being captured, and you can see what columns are being captured across to the right here. So this is pretty good. I'm going to use the standard template. It'll audit my logins and logouts. It'll show me my completion of stored procedures and my completion and batch starting of T-SQL events. So that's perfect. So I'm going to go ahead and just click Run. Now you'll notice when this fires up, it spits out a little bit of information because it was configured to show my existing connections. Let's make this a bit bigger so we can see it. And you'll see here, here's the different applications that are talking to my SQL Server that I'm connected to. Not surprisingly, I have a couple management server connections, and then I actually have my SQL Server agent running. So that's all fairly expected. Now, if we flip back over to Management Studio, we can generate some traffic. I have the SQL Server Inside Out instance I've installed here, and I'm running the Worldwide Importers database, which is one of the sample databases you can download from Microsoft and install on your machine. And if you look under tables, there's just a whole bunch of tables here. So we're going to just select some data from one of those. So I'll do select star from, and sales orders is fairly large. I'll drop that on here and I'll hit execute. So that runs. You can see that didn't take very long, a second, maybe just a little bit more, and it's 73,000 rows of data. What we care about, my trace that was running in the background. So if we flip back over, so you can see that a lot more information got dumped into this profiler, and some of this is kind of small. You can adjust that if you want to make your text a little bigger. All you have to do is come up to Tools, Options, and then right here at the top, there's a display option. So I'm going to go ahead and click Choose Font. I'll select, say, size 10, hit OK twice. Things get a little bit bigger, a little easier to read. Now, when we looked at this before, we saw everything up till about here with my existing connections. Then I went and ran some queries. Now, you'll notice we only ran one select statement. But if I expand this, you can see a ton of queries that got run. And why is that? It's because SQL Server Management Studio is just a GUI front end to a SQL backend. And so it actually runs queries in order to do everything that it does. So when I expanded my Worldwide Importers database, it set a using statement for that. It then selected all the table names when I expanded the table folder. So all that was done as a query. So you can see all those queries that ran. But if I scroll down to the bottom, you should eventually see right here the query we actually ran. And here's our select star from sales.orders. Now you're seeing this twice because, keep in mind, we were tracing for batch starting and batch completed. So this is when my SQL Server query began, and this is when it ended. And you'll see that when it ended, this line, I have lots more detail because I now know some things about the query. I know how much CPU it used, I know how many reads it took, how many writes, in this case none, and the duration. So we saw in the tool, it ran a little over a second, but here you can see it actually ran for 943 milliseconds. So you're able to really dig in on some pieces and parts and figure out what's running on your system. And one of the things I didn't do, so you'll see here, is we're getting all this select data out of different tables. Now, some of this is going to be right from my Worldwide Importers database because I had to get, say, the list of tables. But other stuff like server properties like this was all selecting stuff about the SQL Server itself, which would not have come out of my Worldwide Importers database. So I want to go back to the trace properties here, which is the little hand pointing at a piece of paper button in the top. It says properties. It's like the fourth or fifth button over here if you need to get there. So I'll click that, and it just brings back up the selection that we looked at before. And I want to change a couple little things here. And what I want to do is set up a filter so that I'm only seeing events from my database. So I'm going to show all columns real quick, and I'm going to scroll across till I find database name. And you'll see that's available for my T-SQL batch and my stored procedure and all my existing connections. So we're going to go ahead and select that in all those cases. So now database name will be one of the columns that we show in our trace. Now because I have that, I can click column filter, and now I can go find database name, and I can put a filter in. So like or not like. So being not an exact match, and you can use percentage signs for wildcards. So I'll just do percentage and put in world percentage because my database is called Worldwide Importers. So we'll click OK, and we'll click Run. And now I'm getting this new trace, and what I'm going to do is I'm actually just going to hit stop and start, because when you stop and start, it will actually clear any previous connection. So you'll see now I don't see anything about my SQL Server agent. All I see is one Management Studio connection, because that's the only thing that's actually running against that database. So I'll flip back over to our Management Studio, and I will execute this select one more time. There we go. And when I go back to Profiler, now you'll see all that other garbage that we saw before is filtered out, and all I see is the query that I cared about, which was this one with our select star from orders. So you're able to sort of narrow it down, and that's how you can really hone in on something that you want to try to performance tune. Now the next tool I want to show you is called the Database Tuning Advisor, and that helps you put indexes on tables that maybe didn't have them, or things that are needed that are affecting your performance. So to do that, I want to create a situation in which I need an index. So we'll go back over here, and I'm just going to say select star, and I'm going to do a little trick here, into orders copy from sales.orders, and hit execute. And what that's going to do is going to select all the data in sales orders, and it's going to put it into a table called orders copy. So if I right-click my tables here and hit refresh, you'll see down here, I now have a DBO orders.copy table. So it's not sales anymore, because now it's owned by a different schema, which is outside the scope of this lesson. But what I want to show you is I do have another table here with the same data. So I'll just drag that table onto our query window and put a select star from in front of it. And to run just this one query, I'm going to highlight this one line. And now when I run, it'll only run that line. All right, so I ran that. You can see the data down here came in. And here, I'll just zoom this in so you can see what I'm doing. So essentially, I'm going to run both of these queries a couple times just to sort of generate a workload. Now, we want to make sure that our profile is still running. And you can see here that's still churning along and capturing everything we're doing. So we'll just go here and execute this a couple of times over and over. And essentially, it's just selecting data from both those tables one after the other. That's all I'm doing. So this is creating a little bit of workload in my profiler. So once that's done, I'm going to go ahead and hit stop. And now I have this trace. And you can see I have varied times. You'll see right here that for selecting from sales order copy, it takes less than a second. But For selecting from my other table, it's taking, this is the dual query, sorry, I put together. So when I select for both tables at the same time, it's taking 16, 17 seconds. Part of that is because I'm selecting from two tables, but also part of that is that this table doesn't have any indexes, so it's going to be a little slower. So we're going to run this through the Database Tuning Advisor and see what it suggests. So to do that, I'm going to save this trace, and I can just save it as a trace file. And I'll just save it into my inside out folder I have on my desktop here and just call it sample workload and save. So now we'll launch the Database Tuning Advisor. So if you have your tools installed, that again will be in your Start menu way down here under Microsoft SQL Server 19 and Database Engine Tuning Advisor. So we'll fire this up. And again, we'll connect to the same instance because we want to examine the instance of SQL we were just running this against. And this pops up, and the whole point of this is I can tell it which databases I want it to look at and give it some sort of workload so that it can try to tune my database. So you'll see up top, I can select a workload from either a file, a table, a cache, or a query store. One of the options in Profiler, we didn't look at it, was to capture that data to a table. So I could have done that there. And the other option is you could have it look at your query store, which is a piece of SQL Server that we haven't configured, but we'll look at it here in just a second. So we're going to go ahead and open up our file. So we'll click the little binoculars there. We'll go to our inside out folder and we'll grab our workload. Okay. And it asks you which database you want to analyze this workload for. If I pick master, it's not going to do anything really because this was all captured off Worldwide Importers. So we'll click Worldwide Importers there. And then down here, what tables do I want to tune? So in this case, I also want to tune Worldwide Importers. So the data that from the workload I want to use is from the Worldwide Importers, and the data that I want to tune against is also Worldwide Importers. So once we have that selected, we will just go ahead and check out the tuning options. And you'll see here you can do a bunch of advanced stuff. You can limit the tuning time to a particular day or time. You can limit it to whether I want indexes, whether I want partitions to be looked at. There's all kinds of crazy options that we're not going to go into. But as you get familiar with this tool, this is where you can really narrow down the kind of advice this tool will give you. So I'm just going to go ahead and click Start Analysis here. And what this is going to do, and it shouldn't take very long, is we'll look at that workload that we captured, those select statements we captured, run it through its system, and figure out if there's anything that I can do to my database to make it run more efficiently given this same workload. So typically, what you want to do is provide a workload that is indicative of the kind of workload you would see on that particular database. All right, so now it is complete, and you'll see down here, it looked at that workload, and it decided that it could make a 49% improvement by adding a new index. So you'll see on my orders copy table, it recommends creating an index with this information. So it's a clustered index, and this is sort of a name it gave it, but what we care about here is it's a clustered index, and its definition is on order ID. So it's essentially saying if you had a clustered index on order ID, your queries would perform better, which makes sense because I copied this table from another table, and when I did that, it lost all its indexes. So while my original table does have a clustered index, you'll see it doesn't recommend anything for the original orders table. This one does not. So it says you want to put this index on to make things better. Now, you can take these recommendations with a grain of salt, but it gives you a starting point to use. So once you select all the recommendations that you like, you can go up to Actions and you can hit Apply Recommendations. And what this will do will allow me to apply them now, schedule it for a later time, or whatever you want to do. I'm going to apply now. I'll hit OK. And you'll see this is going out to my database, and it generated the SQL and it applied those indexes. So I'll close this out. And now, if you flip back to Management Studio, and look at orders copy under the indexes folder here, you'll see there was nothing here because the little plus sign would be there. Let me just right click and hit refresh. I now have that index that's suggested. So that's what you can use the database tuning engine to do. So essentially by capturing workloads using the profile tool and then running those through the database tuning engine advisor, you can get suggestions for improvements to your database. Now the one last place that the tuning advisor can look for queries to tune is your query store. So we'll talk about that briefly, and we'll look at how you can set that up. So I will right-click my database and pull up properties. And this will bring up the properties window for my database, and the one we care about here is query store. This allows me to turn on or off the Microsoft query store engine. So I can drop this down where it says operation mode. I can drop this down to read write, which essentially says turn this on for all my queries read or write. How often do I flush it? The default's every 50 minutes. And how often do I collect? Every 15 minutes. And then there's some other things you can set here to set plans per query and max size, and there's a bunch of stuff. It's a little more advanced than we're going to look at, but I'm going to go ahead and turn this on. So I'll hit OK. And then if I refresh at my server level, right-click and hit refresh, you will see a new folder pop up called Query Store. So it sort of closed everything when you refresh. But this new folder is where you can see your query store data. This is turned on or off per database, which is why this is under my worldwide importers database. And if you expand this, you'll see I have a whole bunch of different folders, which are different types of queries. So if I double click overall resource consumption, you'll see this gives me some reports of duration and execution count for different queries that have run against this database. So this is basically tracking real time as queries are running against your database, and it's pulling this information together, and you can go individually dig through all this, or you can go to your tuning advisor after you've let that run for a while. And if I go back to this general tab, you'll see this is all grayed out because this has already been sort of set up and run. So I can hit start a new session, and then from there, I could say use the query store from my worldwide importers database. And I can say, again, to tune my worldwide importers database. And if I clicked through this and hit run, it would look at all the workload that had been captured on my query store and provide me some recommendations. So I'm not going to go through that process, but I just wanted to show you that that's another way you can capture workloads against your SQL Server and then use those workloads to feed into the tuning advisor to get some recommendations about your database. So again, these tools aren't perfect, and by no means am I suggesting that they're the only ways you can do index design and database design. For sure, you have to look at your system and make the choices that are right for you, but if you're having a performance issue or if you just need a good starting place, these tools can certainly help you out and get you to where your database is performing more the way you want it and just really help you knock out some very common performance issues. So SQL Server Management Studio is by far and away the tool you'll use the most, which is why we wanted to talk about it here. So I will either refer to it as Management Studio or sometimes SSMS for short, but it's all the same thing. It's the Management Studio. So see here, I have it opened up. And there's a few panes and a few properties you care about. And you can rearrange this however you like and drag these things all over the place and put them where you want them, but I kind of have them in their default. So for me, Object Explorer is over here on the left. If you work with Visual Studio, your Solution Explorer and stuff is often on the right. Some people prefer it over there, sort of your preference. But Object Explorer is sort of what shows you all the different objects and pieces and parts of whatever you've connected to. So here I'm connected to my local SQL Inside Out instance, which has a database. And then if you want to configure replication or security or anything else, there's folders for all of that. Within here, I can connect to any number of things, database engines, analysis services, whatever. I can even connect to Azure Storage or an Azure SSIS integration runtime engine. I can also connect to an Azure database engine. So I'll show you that real quick. I'll just hit database and I'll drop this down and you'll see I have a SQL Server Inside Out database set up on Azure. So I'll just hit connect and it'll go out, connect to my Azure engine, and over here you'll see it pops up and there I have an Inside Out 2022 database. Whether I need to connect to SQL or integration services or reporting services, I can do some of that stuff right here in Management Studio. The other thing you'll often do in Management Studio is you'll use it to write queries. So if I pick a database here, I can either right-click and select New Query, or I can just hit New Query in the toolbar, and I will get a query window. Now this pops up, and it allows me to run Transact SQL against a particular database. So you can also use the folders here to help you see what's in a database and help you design your queries. So this whole window is just sort of plain text, and I can type into it, and it has some IntelliSense like Visual Studio. But I can use these other things over here as helpers. So I'll expand worldwide importers, and I'll expand tables, and you can see a list of all the tables in the database. So then if I want to select something, for example, I can do a select star from, and I could grab a table over here like sales.order, drag and drop it, and it automatically puts the name of the table right into my query. So from there, I can hit execute, and I get my results. Additionally, I can drop further little pieces of data about something. So if I want to do an insert statement, for example, I could insert into, and in this case, we can do sales, so the same table. So you'll see the IntelliSense. This is another way I can do it. I can start typing sales. I can mouse down to sales, hit tab, and then I can type orders, mouse down to orders, hit tab, and I can fill my IntelliSense in that way. But when you do an insert statement, you have to tell it what columns you want to insert into. So a handy little tip if you're using Management Studio, I can expand this orders table on the left side, and you can see I have all the columns right here. Now I could sit here and one by one drag these columns over and make an insert statement, okay? But I don't want to do that. So what I'm going to do, type an open paren, and I'm going to drag the entire columns folder over, drop it. And you'll see that automatically, sort of magically, dropped in a comma-separated list of every column in that table. So now I could put my close paren here and move on to the data that I want to insert. But if there's certain columns I don't want to insert, say order ID, I can take those out and kind of tweak my list. So that's how you can sort of use Management Studio to help build queries. Now, it's not just your query and your management engine. It also sort of gives you access to everything else in your environment. So you have some jumping off points here. So you'll see on here under Tools, I can launch my SQL Server Profiler right from Management Studio. I can launch my Database Engine Tuning Advisor. I can get to some of my Azure stuff, so I can schedule SSIS packages to migrate data, things of that nature. I can also do, right here, instead of just queries, you'll see kind of across the top, there's all these different sorts of queries. And you can see those here as well by going to File. And then you can do a query with your current connection, a database engine query, or any of these analysis services queries. So that's also the kind of stuff that I can fire up in SQL Server Management Studio. Now, a couple other just quick things, and again, we revisit this a lot in some other lessons. We'll be using this quite a bit. So again, if I go through something quickly, trust me, we'll be coming back to it later on. You have a couple different ways that you can start to set things like context and things for your SQL queries. So you'll see up here, there's this drop down. Now this was set automatically when I selected my worldwide importers database and said new query. But what if I was just in my SQL Server like this and I said new query? You'll see it comes up with master because master is my default. So I can either drop this down, which will change the context for my query, or I can do a using statement. So if I attempt, and I'll just copy this from here, this sales order query. I just want to show you how this context works. To run this statement, select all from sales.order and hit execute. It's going to error out because I'm not in the right database. Okay, so a couple things you can do. One, again, you can drop this down and change your context to worldwide importers, which will then allow this query to run. Or two, let's say this was still in master, you can start to use using statements. So if you're new to Transact SQL or you're just kind of getting into this, using statements tell your code what database to run the code against. So I can say use, and then I can start typing the name of my database, and you'll see autofill helps me out there. Use worldwide importers. And now this will change the context to worldwide importers, and then all the code following that using statement will run against worldwide importers. This is actually a really good practice. So as you're starting to write SQL queries, you want your using statements to be correct because you don't want to have to rely on who's ever running this query to go properly pick context in a GUI or something like that. Especially if you have a script that runs against multiple databases, you might use worldwide importers for a few things, and then you might switch to a different database. Now, you can also fully qualify these queries, which, again, a little out of the scope of this, but a select statement can be pointed to a very specific database before tables. But the using statements lets you change context. So now, if I hit execute, well, actually, let's do this in two phases. One, I'm going to just delete that for a second so we can get back to this state where you'll see it didn't run because it doesn't know my database. And so I'm not going to change this dropdown like we did last time. Instead, I'll put that using statement back. And now when I run, this should change the context, then this should run. It will also update this little dropdown up here because that's the current context. So I'll click execute and you can see my query ran, and by the time it finished, my context had changed from master to worldwide importers. Okay. So that was a brief overview of SQL Server Management Studio. And by no means was that exhaustive, but again, we use this throughout these lessons. So this kind of gives you that foundation for where is Management Studio and what does it look like. So as we start progressing through some other lessons, you'll know what I'm doing and where I'm going and what I'm doing with these tools. So that's Management Studio, and you're going to spend a lot of time using it as you start working with SQL Server. Welcome to the lesson on introducing database server components. This lesson provides an overview of the major components of a SQL Server instance. The concepts covered here will help you set up and maintain your SQL servers. This lesson covers configuring server memory, setting up file storage, and how to configure the server's network settings. This lesson will also provide an overview of setting up SQL Server security. Let's get started. So as you might imagine, SQL Server, since it works with data, uses a lot of memory on your system. And it's important to know how to configure that so that you can make sure that A, SQL Server gets the resources it needs to function, but also B, prevent SQL Server from stepping on other things that might be running on your machine. So we're going to have a brief look at how to configure the memory SQL uses and kind of a talk about what that all entails. So in Management Studio here, if you right-click on a particular instance, select Properties, you're going to get the Server Properties dialog, and there are a lot of pages to this dialog. We're going to focus on some of these in some other lessons, but right now, what I want to show you is the memory page. So the memory page, very simplistic on its surface. There are 4 different options. First one here is the minimum server memory, which by default is set to 0. The second option, maximum server memory, by default set to this ungodly large number. This is essentially the max of an integer. So it's essentially all the memory you could possibly have on your machine. And when SQL Server starts up, it will grab some chunk of your physical memory between, in this case, 0 and 2 billion. And in general, that's okay because usually, and this is not always the case, SQL Server is running on its own machine in an environment where you've given it resources and you're like, SQL Server, do what you need to do to make yourself happy. But sometimes you also have, say, a web server on the same machine or some other sort of application on the same machine that also require memory. So this is what allows you to tweak how much SQL gets. So for example, and this is in megabytes, if I wanted to limit this to say 4 gig, I'll just type in 4096 megabytes, which would mean SQL can't use any more than 4 gig of memory. That's pretty small for a SQL server, but again, there's several reasons you might limit it. If you have 32 gigs of memory, you're also running a web server, you might give SQL 16 and the web server 16. If the web server doesn't need that much, maybe you could say SQL, you can use up to 20. Now, in general, it's pretty good about not stomping on your OS needs. So you typically only have to tweak this if there's another thing running besides SQL Server. Another instance where this is very important, and this is a little more of an advanced concept, but if you get into failover clusters where I have 2 instances of SQL running, and a true failover cluster, I might have 1 SQL instance and it fails over to a second machine, and fine, so it can still use all the memory. But what if I have 2 instances running? So often what you'll do is you'll set up physical hardware 1 running a SQL instance and a physical piece of hardware number 2 running another instance. And they're both configured to sort of fail over to each other. And a lot of times corporations will do that because it's hard for them to swallow the cost of, I have this whole other server sitting here whose whole purpose in life is to be there in case this server fails. So what they'll do is they'll actually make use of both those servers, and they can each run a SQL server. And if one fails, what you end up with is 2 instances of SQL on the same physical server. And that's great, except let's assume you have, say, 32 gigs of memory on each physical node, and each SQL server is allowed to use 30 gigs of memory. Well, if I'm already running a SQL Server instance and it's chewing up 30 gigs, and I go to fail over, my second instance is not going to be able to grab very much memory. It's going to get limited to whatever's left, which is a very small portion. So what I might do in that situation is set it up to where there's extra memory in both, and I can say, now let's just say you have 64 meg, then I can tell each SQL Server instance to use, say, 25. So now the max server memory is set to 25. If I have a failover and that second instance, which also wants 25, swings over, it comes on, it grabs 25, but now because I have 64 and they both use 25, I've only used 50. Okay, so that's what you kind of have to start thinking about when you're configuring these memory setups on the instance. And again, this is the instance of SQL. I can have 10 instances on my same machine. So that's another case where I might have to tweak some memory so that not all 10 of these try to grab all the memory in the world. So to do that, again, minimum, maximum. So if you really want this SQL Server to use 10 gig because you know it's going to need it, you can start its minimum at 10 and then max it out at some other level. Now the other thing you'll see on this same page, there's a couple other memory options, and these revolve around index creation and around minimum memory per query. So index creation by default is 0, which you'll see here says that means dynamic memory. It means when I'm creating indexes, SQL has to do some calculations in order to create these indexes and build them up. And it uses memory in order to do that. By default, it's dynamic. It'll grab some memory, it'll do the index creation, and it'll give it back when it's all done. But I can also limit it. So it will cause your index creation to take longer, but you can limit how much memory you give to index creation. And that again is if you're trying to squeeze performance out of this machine, you can limit index creation to leave memory free for your SQL Server. Last but not least, your minimum memory per query. And this is in kilobytes, and you'll see this is how much memory is given every time you start up a query. Now, queries will take more because they require more complex operations, they're returning more information, whatever the case may be, but this is the minimum. So again, if you have a workload that often needs more, you can go ahead and give it more here so that each query will get a larger chunk to begin with and not have to try to grab more as the queries run. Now this is common throughout the SQL Server properties dialog box, but I'll show you here. Down at the bottom, you'll see I have configured values and I have running values. So I've made a change or two, and actually let's make 2. Let's make the minimum 1,000 megs and the maximum 16,000 megs of memory. Okay. I can see what's running on my server versus what's configured. So right now, this is what I've selected, and if I click running values, you'll see it shows me that I'm actually running with a minimum of 16. So when this server came up, because it was set to 0, it was sort of dynamic. It gave itself 16 minimum, and still the max is the giant number. And then my index creation and my memory per query are the defaults, 0 and 1024. These are grayed out because this is the value your server is actually running right now. Configured value is what you've configured. And at the moment, I haven't hit OK. So really, this isn't even configured. It's just sort of in flight. So I'm going to go ahead and click OK here. And there it went away. And then I'll bring the properties dialog back up, go back to the memory tab, and you'll see there's my configured 1016. I left these alone, and I'll go back to running, and that is actually the value that is running now on the server. So that took effect. You'll use this some settings, and in some situations, your configured value will be different from your running value, and that is typically for a setting or a configuration that needs a SQL Server service restart. So if I change something and my config value isn't matching my running value, I probably need to restart the service in order for that to take effect. So I just wanted to show you that here. And as I said, that will come up in other places. Like here's your connections There you go, configured versus running. So you'll see that in other places as you play with SQL Server settings. So again, just wanted to have a very brief talk on configuring memory. Typically, after you install a SQL Server, it's one of the first things you want to consider. You get your server set up, and then you want to go in and tweak the instance, and setting up its memory usage is fairly important. And again, just remember, you're going to tweak this based on other things that are running. And in a lot of cases, it's, like I said, it's okay to give SQL all the memory, but it needs to really be the only thing on that machine to avoid resource contention with other processes. So every SQL Server database you create on an instance is really just a collection of files that exist on a drive somewhere. And the different files serve some different purposes, but essentially that's all it is. And so we want to take a look at what these files are and understand how SQL Server uses them in order to create databases. So I'm just going to flip over to this Worldwide Importers database, which again is a sample database you can download from Microsoft. I'll right-click it and I'll hit Properties. And when this comes up, I will click the Files page. Okay. Now here, there are a lot of different file types. Not a lot, there's 4 on this particular database. And what we have is, for primary data, we have a file type that's called rows data. For user data, we have another one that's rows data. Then we see this in-memo file, which is file stream data. And finally, we see a log file. Okay. Now, couple different things. Every database will have a data file, which is something called rows data here, and we'll have a log file. Whether or not you have different file groups or additional row data is optional. And file stream data is required if you have file stream data. Essentially, the way this works out, the rows data is where the physical data that is in your table is stored. The log file is where information about transactions are stored. And this is important because a lot of times people see a log file and they think, oh, it's like a Windows log, right? So I don't need that. It's just a log file. It's just information. Can I delete that? Can I save space on my drive by getting rid of this log file? The answer, in SQL Server's case, is absolutely not. So I'll briefly talk about what a log file is for. It's essentially in-flight transactional data. So anytime I write data to my database, log data is written that says, here's the data I wrote to my database. It's not actually in your rows data yet. So when I go to query and say, hey, give me all the information from this table, it returns me the portion from the rows data, which is your hardened data. And there might be data in the log still that it also has to gather up. Eventually, and it's called checkpointing, the data in the log is pushed into the database. Now, when that happens depends on the recovery model you're using, which is something that is reviewed in the backup sections of these lessons. But essentially, the important thing to remember is when the data is checkpointed, it's pushed down into the rows data. Now, we can have multiple file groups, as you see here. There's a primary file group, which again, every database will have. And then there's user data. I'm able to set up different file groups that can contain data. And partly why I would do that is to separate data across maybe multiple drives, for example. So you'll see over here, if I just expand this up, each of these files has a path to where they are. In my case, they both happen to be in the install directory, C program files, all the way down. And there's a Worldwide Importers MDF. MDF is your data files. NDF are additional data files. So M is like your master data file. It's your primary. NDFs are additional data files. And then LDFs are log files. And in this case, we've set up multiple file groups. Now, I'll show you that here on the File Groups tab. The reason you do that is because you can put different things on different file groups. So say my primary file group consists of one file. It is not the default, and it is not read-only. Because it is the primary, it has to be read-write. Additional ones can be read-only, but in this case, my user data for this database is not read-only, but it is the default. So if I create new tables, they're going to end up in this user data file group. And again, I can have these split across different drives. There's a couple different reasons why I would do this. You can also create a file group and only put indexes on it. So I can split across multiple drives to allow better performance. In this case, they're on the same drive, so performance kind of out the window. But it's really here to kind of show you how you can configure these things. Now, what goes on which file group, that's a matter of your database design. So I'm just going to close this properties window for a moment and expand our database and expand our tables. And here you'll see all the tables in the system. So if I right-click on sales order and hit properties, this is going to bring up the table properties for this particular table. And you'll see it gives the user, the database, the name, everything where it exists. It tells me the schema, right? And it has some table options and whether or not it's replicated. But if I look at the storage page here, you'll see that the compression type is none, tables partition false. What's important here is the text file group. It's in user data. So this table exists in user data. So as I create new tables, I can put them in this user data file group just as this one is, or I can put them in the primary group or any other file group I have. So that's important if you have, say, non-dynamic drives. So if all of a sudden your primary drive is beginning to fill up, and we're talking now physical, not necessarily a physical hard drive, but a volume. Say your D drive, which could be anything. It could be RAID, it could be whatever. But if that's starting to fill up, there's no reason that I have to migrate this database. I can actually create a new file group, and then that file group's file can be on another volume. And now as I grow this database, I'm growing into this new volume, okay? Same thing with log files. If you decide your log files are starting to get big, I can actually put those on new volumes, and I can move things around semi-dynamically within a database, which is sort of unique. Even though it's a collection of files, those files, you can get to a point where you stop using one. You just say nothing else is going to grow in here, so that file is going to stay the same size, and we can move to a new file group. And the database can continue to exist without having to migrate the whole thing. Now, from an administration standpoint, as you set up these files and these file groups, there is an option that you probably saw when we looked at these files a second ago, but I haven't talked about it yet. And that's this column right here, autogrow/max size. So this is sort of a hot button topic in the world of database administration as to whether you should let your files auto grow or not. What this will do, so these two files are primarily where we have data. They both are set to auto grow. And if you click this little ellipses here, you can get the options for auto grow. But these guys, and we'll look at those options in a second, these guys are set to grow by 64 meg chunks, and the max size is unlimited. So that means if I keep shoving data into these tables, in these file groups, the files are going to grow when they need to. So at the moment, my primary one is only about 1 gig, and my secondary one is 2 gigs. But if I start shoving data in and it gets close to this 2 gig ceiling, it's going to pop another 64 meg on top of that. And it'll keep doing that every time I start to fill it up. And it will not stop because this is unlimited. The only thing that will stop the auto grow of this data file is reaching the capacity of your hard drive, which you might imagine is a bad thing. So if this is running on a server and I suddenly fill the hard drive, SQL Server can't talk to its database. I could be creating problems if there's anything else on that drive. In my case, I'm sharing this with Windows, so now I've just filled my primary partition, my Windows partition. The computer will be very unhappy with that. So, in general, when you start to do SQL Server administration, you want to come up with a growth strategy that you implement. So there's nothing wrong with implementing a little bit of autogrow, and you can do things to sort of monitor it and know when it happens. But a couple things you have to keep in mind is one is that max size, and two is how much do you grow it by. So you can imagine if I were to set my autogrow to something like 1 meg, and we'll look at the options here so I can kind of talk through that. So I'll click this little ellipses, and you can see I can enable or disable autogrow, and I can do it in %, in megabytes, and I can do a max. So If I were to say grow in meg increments, it takes resources to grow a data file. So as my data file gets full, if I say add another meg, it adds another meg. Well, if this is a busy database, I'm probably going to fill that meg up pretty quickly, and then it's going to add another meg, and then it's going to add another meg. And all that stuff, all that extension of your database takes time and resources, which slows down your server. So A, you want to grow things in logical chunks. This is why they also offer you a percentage growth. So that's a little better, right? If I have a 2 gig database and I hit the end of it, I'll slap another 200 meg on. Then if I hit the end of that, I'll slap another 202 meg on, because it'll kind of round up, kind of like interest, right? The bigger your database gets, the more it's going to grow each time. But there again, is that the proper chunk? 50% seems large, right? So now I have 2 gigs, I go to 3, and then when I fill that up, I go to 4.5. And then you run into this problem of what percentage should I grow by? What size should I grow by? And then what's your limit? So now I'm growing by 10%, but if I get to 100 meg, do I stop? If I get to 20 gig, do I stop? And so in general, I stay away personally from AutoGrow. And I try to figure out how much data I need to take up on my hard drive, and I allocate it. So if you were going to come in here and say, well, stop growing this database when you get to 20 gig, then one school of thought is, well, why not just give the database 20 gig and then monitor its usage? And if you need to, you can grow it or get more disks or whatever you have to do in the future. AutoGrow in general kind of sets you up for some pretty bad issues down the road, because you'll run out of space. If you have 2 databases on the same system that are both growing, now they're competing to see who can grow fastest. But that's what AutoGrow does. So understanding what it is and how to configure it is step one. And again, I recommend not utilizing AutoGrow. But in your environment, as long as you know what it is and you're keeping an eye on it, those are the options for setting it up. Another place where AutoGrow can get you is your log file. So you'll see this log file, again, in this case, is set to 64 meg chunk. And it's only 100. It'll grow in 64 meg chunks. But it's limited. You can see that it's a little cut off, so I'll open up the settings. It's limited for whatever reason to, that's about 2 terabyte worth of data. I mean, they put a limit on it, but it's huge. The log file, again, I mentioned that it's important to the functioning of your database, so much so that if your log file ever fills, your database will stop working. So they've enabled AutoGrow in here to grow in 64 meg chunks and to grow forever. We'll talk about the different recovery options that are available in SQL Server later on, but if you're using a full recovery mode, your log file can't have the data in it removed, and that's what happens when it's checkpointed, right? The data's truncated out of the log. That can't happen until you've backed it up. So some people get themselves into a situation where this is their default config. They've enabled AutoGrow, and they have this little database, and they never set it up to back up the log. Maybe they're doing database backups, but they never back up the log, and therefore this log will continue to grow and grow and grow and grow and grow until it either hits the max, hits the end of your hard drive. Those are the two options. So again, we'll talk more about the repercussions and how log files grow and what they're really used for when we talk recovery models. But suffice it to say, they can grow fast. So you want to make sure you're managing the log growth as well. Okay. Now, you'll notice there's a couple other kind of specialty file group types here. So I have a file stream data file. And if I click add, you'll see here, I now have access to this little dropdown because I'm adding a new file. And if I drop that down, you'll see I have rows data, log, and file stream data. So you can, in this case, I'm adding another file stream data. You'll notice when I do that, it wants to know what file group that exists in, while I only have one file stream group, so that automatically fills in. If I were to say I'm adding more rows data, I can then choose, is this row data? Is it primary or is it user data? Or do I want a new file group? And if you add log data, you'll notice logs don't have file groups. So when it comes to logs, yes, I can have more than one file, but they all sort of exist as part of the database log. So there is no file group for that. However, file groups aside, I can still put different log files on different folders. And there's also some tuning advisories around how many log files do you want based on the number of processors. And there's a bunch of different stuff out there that you'll look at when you start doing database configuration and tuning and get into all that stuff. But the point of this lesson was to sort of understand where these files are and what makes up a database. So I don't want to create that log file, so I'm just going to go ahead and hit cancel there, and I'll leave my database in the state that it was in prior to us taking a look at this. So again, just to recap, every database on your SQL Server is just made up of files on a hard drive somewhere. And in order to set those databases up, it's important to understand not only where the files are, but how they can be split into file groups and how to manage the growth of those files as the life of your SQL Server sort of pushes towards more data, and that SQL Server has been around for a longer period of time, and also understanding how to manage that growth in the event of lots of SQL Server transactions and therefore growing logs. So hopefully this gave you enough to sort of understand where these are, and there are some other lessons where we'll talk about performance tuning and backup, and we'll revisit a little bit of this concept at that point. So SQL Server as a data and storage engine is more often than not accessed by other applications and programs and clients on different machines across local area networks, wide area networks, even the internet. And so because of that, you have to understand how to configure it to exist on that network and what your options are for connecting to SQL Server. So that's what we're going to take a look at in this lesson. Now, in general, in the case of this instance I have set up here, this is on my laptop. This instance is running on my laptop, and I'm talking to it from my laptop. So at the moment, there's no network communication going on, but I'm still communicating with the SQL Server. And there's two parts you need to configure in order to talk to a SQL Server. One is, how does that server listen for clients? And two, how does the client access said server? So there is a tool that was installed when you installed SQL Server, and it'll be in your SQL Server 2022 program group. And it is called the SQL Server 2022 Configuration Manager. And I will launch this tool now, and this allows you to configure various aspects of server and client connectivity. So you'll see here, if I start at the top, I have access to my SQL Server services. So these are all the services that run as part of a SQL Server install. And I have several because I'm running different SQL servers for different purposes. But you'll see here, here's our SQL Server for this series, SQL Inside Out. That's the instance. It's running, up and running. That's great. Its SQL Server agent is also up and running. So that's how I know my services are running. But how are they listening from my clients? And that is essentially what all the rest of this tool will show you. So if I click on my SQL Server network configuration, there's 32-bit here. And then you'll see there's SQL Server network configuration without 32-bit. So because I'm not running any 32-bit services, I don't see anything here. But when I click on SQL Server network configuration 64-bit, I see all my different instances, right? And the one we care about is the SQL Inside Out instance. So I'm going to expand this and then click on the Inside Out, just so you can kind of see the two-pane experience here. And now on the right, you'll see these three different options. These three different options are shared memory, named pipes, and TCP/IP. These are the three different ways that my clients can talk to my SQL Server. Shared memory and named pipes are across the same machine. So in this case, my SQL Server service is listening using just shared memory, which means I can't connect to it from another client because it's not listening on the network, which would be TCP/IP. Named pipes, again, is on this machine, and then TCP/IP is what allows me to talk across the network. So if we want to configure, let's just look at named pipes. If I double click this and bring it up, you'll see I just get a very simple property of, is it enabled, yes or no? And what is the name of the pipe? So I'm not going to go into the details of named pipes, but essentially this is like giving it an address. So how does it talk to the SQL Server? So I can just come in here if I want named pipes to be available, and I can say yes. And now my SQL Server, when I restart the service, you'll see it pops up and tells me this. When I restart the service, will also now be listening on named pipes. So I said okay, and now you'll see both of those are enabled. Shared memory, if I double click, you'll see is even less to configure. It's yes or no. Do I listen on shared memory? Which is the default for a new SQL Server. So I'll leave that alone. And last but not least, what if I want this to be able to run and be accessible on my network at large? Typically, like I said, most SQL servers, you will, in fact, need to do this. This one is a little more complicated. First of all, do I enable it, yes or no? So we'll say yes. There's a keep alive for, and any of these you click, by the way, it kind of gives you a little information down here as to what that means. And in this case, it's how often it verifies that the idle connection is still intact. And I believe this is in seconds. So it's 30,000 seconds. Last but not least, listen all. You'll see this is set to yes. But if I come down and drop this down, I could say no. And what that's going to say, I could have multiple IP addresses. So sometimes your server's multi-homed. It's in different networks. Sometimes you have multiple NICs and you're trying to drive production traffic through one versus the other. And so by default, SQL will listen on all those cards, meaning I can hit the server by IP address A or IP address B, and they'll both respond. But if I only want to respond on, say, A, I can say listen all no, and then I'm able to configure on the next tab, I'll show you, different IP addresses that are listening and different ones that aren't. So you wouldn't be able to talk to the server on certain IPs. I'll actually just leave this set to yes, because it doesn't really change how the next tab looks. The next tab for TCP/IP is the IP addresses tab. And you'll see if I scroll this down, there are lots and lots and lots of different things in here. Essentially, all this is, it's the same configuration, just repeating over and over for each IP. So you'll see here, I have IP1 that it detects on my machine. This is an IPv6 address here. And then here I can say whether it's active or not and whether it's enabled or not. And you'll see this is enabled no. This is where listen all comes in. So if this says listen all, then they're all enabled. And there's listening on all of these, right? If I change this to listen on all no, now I have to come back here and say yes to anyone that I want to actually enable. So you'll see that for this. Here's for an AutoNet address that's associated with my machine. Here's my address on the actual network, and so on and so forth. There's all these different addresses, and you'll see these depending on your configuration or the number of network cards, or if you're connected to a VPN, anything like that. But if I keep scrolling down to the bottom, you'll see here I have an IP all. And down here, there are two choices, and it's the same choice you had for each IP. You had dynamic and you had port. So dynamic port, if it's blank, then you'll not use dynamic ports. To use them, you'll set it to 0. And that sort of allows your SQL services to use different ports. And the way you find them is through the browser service, which I'll talk about here in a second. So by leaving this at 0, I'm using dynamic ports. I could also specify a port down here. Now, 1433 happens to be the default protocol for a SQL Server instance, but that's the default instance, and you only get one of those, right? And I actually have instances. I have no default instance. So if you attempt to access my machine by its name, there will be no SQL Server there. That would be the default instance, and it typically listens on port 1433. But I'm using dynamic ports, and that's fine for the way I've set them up. But maybe you have to use a very specific port. So I could come in here, and for my inside-out instance, I can put this on a set port. It'll never change. I can open up firewalls, the whole 9 yards. Okay, and I'll talk about the browser here in just a second. So this is where you go in for TCP/IP and say, what port am I running on, and am I enabled or am I not? Okay, so I'm going to leave this default. Dynamic ports are fine. Enabled to yes, and listen all yes. Essentially makes it available on the network. And I'll hit OK. It'll also tell me I need to restart the service in order for it to take effect. Fine. But now you'll see TCP/IP is also enabled. So if I were to restart my inside-out instance, I'm now up and running, and I'll accept shared memory, named pipes, and TCP/IP connections. Now I'm listening on the network. And that's sort of the server side. That's the listening side. Now, on the other side, you have the client. And again, we have an option for 32-bit, and we have the non-32-bit option down here. And I'll expand this guy here and click Client Protocols. And so now you'll see on my machine now, so forget the SQL Server instance piece of it. This is now my physical PC. What protocols do I want to allow my PC to use to talk to my SQL servers? And in this case, I can give them a preference. So I can say, try a shared memory connection first. If that doesn't work, try a TCP/IP connection. And if that doesn't work, try named pipes. When I double click any of these to edit, essentially with named pipes, I can set the default pipe and I can enable or disable it. Okay. With TCP/IP, I can, again, set my port, enable or disable, and there's some keep alives. And with shared memory, kind of like on the server side, it's just yes or no. So this is what my clients will listen on. Now, the default port for TCP/IP is 1433. It'll attempt to find a SQL server there, and it can find it on other ports via the browser service. So the way that works, we're going to step away from the client config just for a second. We'll come right back. If you look at the SQL services running on the machine, you'll notice that I have a SQL browser service. All these other instances I have running all have their own name. So I have my inside out server and I have my inside out agent. But you'll notice that I only have one SQL browser. What this SQL browser does is it runs, and mine is actually currently stopped, and it runs, and when a client attempts to connect to a SQL server, it says, hey, I'm attempting to connect to, in this case, I think my laptop is Eric J. Work. So here, I'll show you in my management studio. That's the name of my laptop, Eric J. Work / the instance. And on Eric J. Work, if the SQL browser were running, the SQL browser service sits there and runs. And when someone says, I need to connect to SQL Server inside out, Mr. Browser Service, the browser service is smart enough to look at my configuration locally and say, oh, you're looking for the inside out SQL Server. Cool. That's on this port. And it provides that port to the client, and then the client makes the connection. So when you're running multiple instances and you're using dynamic ports, you have to set that up in order to talk to these servers because you might not know what port they're on. And also, do you really want to have to tell the client what port everything's on? No. You want to send them, here's your SQL Server and instance. The browser service takes care of the nitty-gritty parts and figuring out where it actually is. So that's how the browser service works. Now, I can, if I want, go a step further. If I don't want to run the browser or if I just want to do some different things, there's this alias tab under here. And you'll see I don't have any. But what I'm able to do with this is I'm able to establish aliases that my client knows about that no other client knows about. You'd have to configure this on every client. But it gives me a way to refer to a specific server using a specific connection method. So what I'm going to do is I'll right-click alias and I'll say new. And up pops this dialog box, and it wants to know, what do you want to call this alias? So I'll call it production SQL. Okay? And then it wants to know, what protocol am I listening on, named pipes or TCP/IP? You'll notice I can't configure shared memory because there's no configuration there. It's just shared memory. So I'm going to say that this connects on named pipes. It defaults to the pipe SQL query, which is fine. And then it wants to know, well, what server is this actually pointing to? So in that case, it's this server, right? So I'm going to hit this connect button just because I want to cheat and copy the name out of here. So the server's full name is Eric J. Work, again, the name of the machine, / SQL Inside Out, the name of the SQL instance. Okay, that's the fully qualified name to talk to this server. And when I come back to my client configuration, I'll paste that in and I'll hit apply. And then what you'll see, I now have a alias called production SQL that points to Eric J. Work, protocols named pipes, and you'll see over here the full parameter to it is that named pipe connection, which connects to that instance. This parameter here should look an awful lot like this parameter here. This is the pipe. okay? So now my client in its little brain has this alias. So if I come back to my management studio and I connect to a database engine and I type production SQL and hit connect, it should find that alias on my client side and it should then connect to that database. So now that I've configured this alias, I can access this server by calling it production SQL. And that allows me to, potentially, I guess, not future-proof, but sort of change-proof my client. So my client knows it needs to talk to production SQL Server, but if that happens to change because, I don't know, the IT department had to move it or for whatever reason, I can come and change this, and I don't care that the actual physical name of the server changed or was moved. I don't use aliases a ton, but it's definitely an option and something you can set up in here. The other thing it does let you do, so if I were to use this as TCP/IP, you'll notice I can select which port that I want to connect on. So rather than using the browser service, I can set up an alias so it knows how to talk to the server on a given port. Okay. So this is, again, where you'll come anytime you need to set up your network settings for SQL Server. So just as a recap, remember there are two sides. There's the server side, which is here, which you specify which protocols your SQL Server is listening on. And then removed from that is your client, which is down here, which sets up your client and which protocols it will attempt to connect to the server on. In my case, my client and my server happen to reside on the same machine. In a typical environment, you'll do the server configuration on the networked server where the SQL Server instance lives, and you'll do this client configuration down on your individual machines or your laptops or your other application servers that are going to talk to that SQL Server. So you'll notice when you first set up a SQL Server, as it was when we came in here, shared memory was the only thing that's on. And that is sort of a kind of a fail-safe mechanism that Microsoft put in. When you install a new SQL Server, it's not up and running and listening on the network. SQL servers can be attack vectors. People can use them to then, if they can hack into a SQL Server, they can get access to your network at large. And so you don't want every developer who's throwing a SQL Server on their laptop to do local development work to have that machine be on the network as a whole. A lot of times people are fairly lazy, especially with local instances, and their admin account, which has admin access to their machine, is often not locked down. So if someone can hack my local SQL instance and get access to my local machine as an admin, well, what if I have admin rights over something else on the network? So you can see how that could quickly become a security vulnerability. So by default, your SQL servers aren't listening on the network. So it's often a little tripping point, especially when you first start working with SQL, is you'll set up an entire instance and you'll say, okay, the SQL's up and running, and no one can connect to it. And this is typically why. There's also a configuration in the SQL Server to allow remote access. We'll look at that in a different lesson. But this is where you'll go to A, remember, configure where your SQL Server listens, and B, to configure your client for how it talks to the SQL Server instances that you need to interface with. So anytime you set up a new SQL Server instance, you need to consider how you're going to set up the security for that instance. Now, there's an entire lesson on logins and database permissions and server permissions, but we're going to look at the high-level configuration of a SQL Server instance and how you configure its security. So I'm going to right-click on my SQL Server Inside Out instance here and go back to Properties. So I'm just going to go ahead and click the security page. Now, this is broken up into a couple different sections. I'm going to go through each one of them here. At the very top, you have to select an authentication mode. This sets up how people can authenticate against your SQL Server. There are two authentication modes available. One is Windows authentication mode, which essentially means you have to be logged in to Windows with an account that SQL Server understands, which means it could be a local account, local on that machine, or it could be a domain account in a larger Windows domain. Okay, and then all the username and password management is handled by Windows. So whether that's the domain or locally, all that password management is handled by Windows. The other option for authentication is SQL Server. With SQL Server, you actually create logins, usernames and passwords, and they're stored inside your SQL Server instance in a special system database called master. That means that all usernames and passwords are managed locally by this SQL Server instance. So if I have SQL servers in a Windows domain and I have, I don't know, 30 SQL servers, and I have users out there that all need access to these servers, if I set up SQL authentication, I have to give them a username on every one of my SQL servers. If I set up Windows authentication, their username and passwords managed by Windows, I just have to give them permission to talk to my SQL server, but I would still log on with my Windows login. I wouldn't have to log into the SQL with an individual login where I might have 30 different passwords, for example. Now, as far as setting up the option for your server, you'll see here, your two choices are Windows authentication mode or SQL Server and Windows authentication mode. So essentially, you can read that as you will always have Windows authentication mode. It's whether or not you also want to enable SQL Server logins. Sometimes you do this if you have clients that aren't participating in the Windows domain, like Linux boxes or something like that, or you have devices that have to talk to the SQL Server and these devices can't really speak to the Windows domain. So then you have both. You have Windows and you have SQL Server authentication. That's how my local instance here is configured. So I have logins that are both Windows and I can create my own SQL logins inside this database. Now, the next section down here is log on auditing. So with this, I can choose how I want to log login attempts to my server. So I can say none, which is this guy here. The default, which I have on, is failed logins only. You can also log successful logins only, or both. So I can log every possible logon attempt to my server. So I'm going to go ahead and click both, and then we'll show you how that works. We'll come back and look at this here in just a second. So I'm going to say both failed and successful logins, and we're going to look at a little logon auditing. Now, because I set this up to be SQL or Windows authentication, I can create my own users. So there's a whole lesson on server security and logins, but we're just going to do this real briefly as part of this demonstration. So I'm going to come to my logins folder, right-click, and create a new login. And then here, I'm going to say it's a SQL login, and I will just name this Inside Out. Okay? Now, you'll see down here, I have to specify the password for this account. So I'm going to be lazy and call it password, which never do. Never use a password as password. But you'll also see all this other stuff I can check down here. Enforce password policy, enforce password expiration, user must change password at next login. Password policy means you have to meet whatever policy you've set insofar as reusing passwords, password length, stuff like that. Enforce expiration means every 30 days or whatever, the thing expires. And change at next login means this is a temporary password, and the next time the user logs in, they'll have to change their password. So I provide Inside Out as the login. I say, hey, the password's password. And the first time you log in, it goes, cool, change that. We're never using that again. So you can start to see why, again, SQL authentication is kind of a lot of work, because now every one of my SQL servers, I have to decide, am I enforcing policy expiration? Does it expire at the same time as my other SQL servers? So Windows authentication in general, a lot easier to manage in a Windows environment. So because this is a test, I'm just going to clear all these, right? I don't want to enforce any password policy. And I'm going to go ahead and give this login access to a database. So to do that, we'll go to user mapping, and I'll say he has access to worldwide importers, and in there he can read and write data. And again, there's a whole other lesson on database security and login security, so don't worry about this too much right now. And I'll just click OK. So now I have this new user, and if I attempt to connect, let's just say, actually here, let's do this. I'll do a new query. So in this new query, this is logged in with the same connection that I'm connected to my SQL Server with over here, which happens to be my local Windows account, which is an admin. But I want to use this new one we created. So up here in the toolbar, I can hit Change Connection, and it'll pop up, and now I can change the connection type. So what I'm going to do is connect to the same server, but I'm going to use SQL authentication. And the login we created is called Inside Out, like that. And we made the password. And I'll just click Remember Password. Then I don't have to retype it, and I'll hit Connect. Now my query is running, as you can see here, as the inside out user. So it has reader rights in this database. So if I change the context to the worldwide importers, I can select star from sales.order. No problem. Order lines is also fine. I'll hit execute. Boom, there it went. But remember, what we were showing here is we're auditing logins. So I want to see when I had successful and failed logins. This one was successful. I logged in, no problem. Let's change the connection again and mess up the password and hit connect. It should tell me the login failed because that's the wrong password. That is indeed correct. So hit OK, and let's fix my password. And maybe it was inside outs connect. No, something's wrong there. Login failed for inside out. Something's not right. Cool. Let's try one more time. Inside out with the correct password. Connect. Nope, must not be the correct password. Let's retype it. Password. And we're in. So because we had logon auditing turned on, all that information should be stored in my SQL log. So we're going to look at that. And it's over here under your SQL Server. You have a folder called Management. And under that is SQL Server Logs. When you click in here, you'll see you have various logs and archives. They're all dated. So archive 1 is from earlier prior to 11:46 a.m. Anything after that is in this log. So typically these are recreated anytime you restart your service. So the top one called current is the current log. So if I double click this, because I'm auditing logins, you'll see here my source has the word login in the column. I can filter that, so I'll just filter that out to where source equals logon, L-O-G-O-N. Okay, and I'll apply the filter and hit OK. Now I'm only looking at logon audits. So you'll see here I had a logon failed, reason, and this actually tells me password did not match. Then I had one here called could not find a logon matching the name provided. So that information is not provided to the user in their error message. It just says, sorry, we couldn't log you on. But here you'll see, it tells me they typed the wrong password. Here they typed the wrong login. So if I have these things being audited, then I can see if someone's trying to attack me and possibly why. If I keep seeing the same login attempt over and over and over from a login where they keep trying different passwords, maybe they're trying to hack that account. Or maybe I constantly see them trying usernames that don't exist. So that can give me some information on what might be happening in my environment. Now you'll notice, even though we had the setting, we'll take a look at that one more time here, set to both failed and successful logins, I didn't see my successful logins in that log. That's because anytime you make a change to any of these things, you have to restart the service in order for these changes to take effect. That applies to the authentication mode and the logon auditing. Okay, so I'll cancel this and I'll just right click on my server here and I'll select restart. And this actually will go, say yes, if it says, are you sure? This actually goes into Windows and restarts the service. You'll see it's also telling me that's going to stop my SQL agent. So I'll say, yeah, that's fine. And now you'll see this dialog. It'll say attempting to stop it. Then it should stop the agent service, and then it should restart the service. And there it's now starting it. The one thing when you restart the service, if you are running a SQL Server agent, you'll notice it's stopped now as well. Oh, there it came back. So they both came back. They both restarted. So now if we change this connection on this query, and in fact, log in successfully, so we'll type password. Okay, remember it. Connect. There I connected. And now when I go refresh and look at my server log here, you'll see I also got all these logon succeeded. Now it wasn't just my inside out login. Okay, you'll notice there's a ton of logins that succeeded. And that's because when you start up a service, a lot of connections got like this reestablished, which was my Windows connection. Here's my login with my inside out. This other query reestablished the Object Explorer reestablished a connection. And so lots of logon succeeds get logged. And for that reason, I don't necessarily recommend that you log success logins. What it's more useful for is, let's say a user's having difficulty connecting to your server. You can turn it on, and then from the server side, I can say, no, I'm seeing you authenticate, I'm seeing you connect, and it can help you troubleshoot. Like, okay, you've connected, you've logged on, why can't your client see my server? So it's a good troubleshooting step, but leaving the log on success audit on is a lot for your logs. Typically, when I'm configuring my security, I leave this to failed logons only. I don't set it to none because I do want to know if someone's attempting to log onto my server that shouldn't be. And that's always one of those fun ones. If you have this set to none and then the boss calls and says, hey, can you tell me who tried to log in? And you go, oh, I accidentally turned that off. So typically keep this on. It's a good thing to have. Now, that's pretty much the way SQL Server can authenticate and the way you can audit that said authentication. There's some other stuff in here as far as enabling SQL Server proxy accounts and enabling some C2 audit tracing and cross-database ownership chaining and some other security options that are available. They're not as important. We're not going to talk about them right now, but there are some other lessons that some of this will come into play. So we'll come back and we'll talk about that in a later lesson. So that's the high-level security configuration. We will talk in another lesson about how to configure SQL Server logins and all their permissions at the server level, and also database users and all their permissions. This was more, how do I configure the type of security for my SQL Server, and how do I configure auditing in case I have to check out a possible attack vector or just need to audit my logins for any sort of like audit purposes or security audit purposes. That's comes up quite a bit. So hopefully this gives you enough information to figure out how you want to establish your SQL Server security. As a database administrator, you need to understand how to provision both SQL Server and Azure Server databases. Here I'll show you both. First, you'll see how to set up and configure your SQL servers. Then you'll get the basics of working with and setting up Azure databases. Welcome to Provisioning SQL Server Databases. In this lesson, we cover everything you need to know to provision a SQL Server. From installation to server configuration and database creation, this lesson provides information you need to go from a new system to running SQL Server instances. This lesson covers installation of a new SQL Server instance, making post-installation server configuration changes, and installing and configuring database features and creating databases. Let's get started. So let's look at how you can add additional instances of SQL Server. Now, we had a lesson you can reference that was about how to get the SQL Server Configuration Center, which is sort of the install hub. So if you're installing your first instance, you will have to go do that. You'll have to download the files from Microsoft, fire up that installation center, and install your first instance. However, if you already have instances, you can get right to that configuration center, provided you still have the source code on your machine, to add other ones. So what we're going to look at will apply whether this is your first instance or your 50th instance. But we're going to look at it from the standpoint of a machine that already has an instance. So I'm going to get to the installation center, not from source files, but from my already installed tools. So to do that, I'm just going to look at my SQL Server 2022 program folder. And underneath there is the SQL Server Installation Center. So I'm going to launch that, and that brings up the Installation Center. Now, this is the same thing you would have gotten had you fired it up from the source code. So it'll look exactly the same whether this is your first instance or your 100th. To install an instance, you go to the Installation tab, and then at the very top will be New SQL Server Standalone Instance or Add Features. So whether you're modifying an existing instance or installing a brand new one, you will go to this top link. I'll click that. So this pops up asking you for a folder. Because I already have the SQL Server installation media on my machine, I don't need to download it again. I have it at C, SQL 2022, and then the edition underneath that, developer_ENU. So this is the English Developer Edition of SQL Server. I'll hit OK. And now it'll actually fire it up and it starts the installation process. This next piece that comes up is the actual SQL Server setup. First thing it's going to do is come up and tell you if there's any reason why you can't install SQL Server. Now, one common reason why you can't install is because something's pending a reboot, which is the case for this particular install. And you'll see the status has failed, and if you click on it, it'll tell you you must restart your computer in order to continue with this install. That's usually because something was changed in your SQL Server setup, and you need to then restart in order to process this install. So we're going to do that, sort of. So after we reboot, we can go back into the SQL Server Installation Center and go ahead and click New Standalone Installation. This time, it should pop up, clear all the checks, and move on. And you'll see that went very fast, but it flew by and it didn't give me any warnings. The next thing it does is it looks for product updates. Are the source files I have on my machine up to date? In other words, do I have the latest and greatest install for this version of SQL? And if not, this will go ahead and pull down any updates you might need prior to installing. I'm good to go. There are no updates, so I can go ahead and click Next. Now it's going to check for specific things that might need to happen. Again, product updates is complete. Does it need to download the setup files? Does it need to extract them? What does it need to do? All of this should be done for my instance, so it should just take a second here to scan and make sure that we can continue forward with our installation. So that's done, and then it looks at the install rules. So this again is something that could prevent you from continuing with your install. Okay, so these are things that if they failed, you must correct them before you can install. And you'll see the only thing I got was a warning on my Windows firewall. That's fairly typical. And if I click on it, you'll see that the firewall is enabled, and all it's telling you is to make sure the appropriate ports are open so that SQL Server could be communicated with from a client on the network. So that's just a warning, and it's actually fine. You don't have to worry about that because we can configure the firewall later on. And mine happens to be configured correctly, so we're no problem there. So I'll click Next. Now this is where you choose the kind of installation. Are you trying to make a new instance, or are you adding features? In our case, we're going to provision a new SQL Server, so we're going to leave the default of Perform a New Installation selected. Here it wants to know which edition. This is because sometimes you'll have different editions that are available to be installed from the same source files. In my case, I can install an Evaluation Edition, the Developer, or the Express. I'm going to install the Developer Edition, which is a free edition of SQL Server that you can download and put on your machine for development. You're not supposed to run any production code on it or anything else. I'm using that for these lessons. In general, if this was a real environment, you would probably select either a pay-as-you-go through Azure or enter in your product key, because you might have a key for an enterprise edition or whatever it is. So you'll enter that down here at the bottom. In this case, I'm going to pick this Developer, which is the free edition. Click Next. This is the license agreement. So essentially, this is all the stuff that you absolutely will read every single word of and agree to. So I'm going to do that, and then I'll click Next. Whether or not you want to add the Azure extension. So as SQL Server has grown over the years, the Azure extension is a lot of the SQL Server in the cloud stuff. There's Windows Azure. Azure's Microsoft's platform for cloud services. And we'll talk about that in a different lesson. But for now, you can install this Azure extension, which helps you authenticate against your Azure in the cloud services. I'm not going to do that for this particular instance, so I'm just going to clear that. Then I won't have to specify any of the Azure connection information below. Next, you'll pick your features. So at bare minimum, you're installing a database instance. So we probably need the database engine services. So I'll select that. Then most everything else is fairly optional. Do I want to use replication? Do I want to have full text searching? Do I want analysis services? Do I want integration services, scale out masters and scale out workers, or any of this other stuff? In this case, I want to leave this just as is. Shared features are features that when installed are shared across all of your instances. So I only have to install the data quality client once for every instance on my machine. I don't have to do it each time I add an instance. In this case, I just want to install a database engine service. You'll see up here, it even asks you if you're looking for reporting services, download that from the web. So depending on which versions of SQL you've worked with in the past, a lot of times you would install reporting services as part of your instance. Now it's a standalone installer, and so they kind of just point that out up here for you, that if you want reporting services, go to the web. It's no longer a choice. And this is fine. We'll set this up. And in fact, I'll use replication on this particular instance as well. Down here, I can say where everything goes. So you can see my directories for shared features. It's grayed out because I've already installed instances and therefore shared features on this machine. So it knows where those go. But what's the root for this SQL Server? By default, it's your program file SQL Server. This is where the install files will go. And we can actually tweak the data files here later on. So I'll leave this alone. It can install to the default location. So this is now your instance configuration. So if I don't have one already, I can install this as my default instance. That is the instance that will run on port 1433 and be accessible by my machine name alone. More and more, people have moved to named instances, which way back in the day when you installed SQL, the named instance was kind of this new thing that allowed me to have more than one instance on the same machine. Generally, at least my practice is, I always install as a named instance and I just don't even deal with the default instance anymore. That way, each of my instances has a name, has a purpose, and I can set it up that way. You can still have the default instance if you'd like, but you can only have one. So you'll see when I select that, I can't name anything. I'm kind of done because it's just the default. We're going to set up a new named instance. So I'll click that, and then what is said name? And so we'll call this inside out 2. And then the instance ID. So you'll see here, as soon as I click out of inside out 2, the instance ID fills in. You can actually have this name and this instance be different by changing the instance ID, but by default, it tries to set them to the same thing. So I'm not going to do that. I'll just have the name and the ID be the same. I have no reason to change that. It shows me my SQL Server directory. So now, because of the C program files Microsoft SQL Server that we selected earlier, this is now the directory this is going to get installed in. MSSQL 16 inside out 2. MSSQL 16, by the way, 16 is the version number for SQL Server 2022. So when you see 16, that's what that means. Down here, it actually shows you a complete list of all the instances that you already have on your machine, what version of SQL those are running, and what features, as far as do I have the engine, do I have replication, whatever. And it also then shows you the addition. So I have Developer Evaluation Express and another developer in an older version of SQL on here. And actually, so since my other one was called SQL Inside Out, I'm going to actually just name this one to SQL Inside Out 2 to match. And we'll have the instance ID also match that name. So we'll click Next. This next tab here is going to give me some server configuration options that I can set up, the rest of which I can do once we've installed the instance. In this case, it wants to know about the various agent accounts. So you'll see I have the SQL agent, which is the service that runs jobs. I can change the account and password here. I can change its startup type. The database engine itself, which is what we are installing. We're installing a database engine. So it's set to automatic, and it will log on with the SQL Inside Out account. It'll have its own little service account. And then there's the browser. I can enable or disable the SQL browser. I can set server collation here if I want. I'm going to leave it as default SQL Latin 1 General. This is if you have different case sensitivities, different language packs, things like that, where you need to understand different kinds of characters or whatever. I'm leaving it alone. And you can also grant perform volume maintenance tasks to database service engine. So what this basically means is I'm allowing SQL Server, the account, which is this service here, the database engine service, to do various volume maintenance tasks inside Windows. So I'm not going to do that for this particular instance. Next, I can do some database engine configuration. So this is because I'm installing a database engine. Now I can set a few things up. Some of these will be familiar if you've looked at some of these settings on a SQL Server already. For example, authentication mode. You can set that as a server property thing, or you can set here whether I want Windows or mixed. If you pick mixed, you have to put in a password. Down here, you'll see that there's a box that says specify your SQL administrators. Which Windows accounts are going to have SQL Server administrative rights? So they give you this handy dandy add current user button, or you can click add and go browse for users. I'm going to click add current user, which will add me, the person doing the setup, as an admin. I could also add other people if I felt like it or if I had to here. I have several tabs across the top. So for data directories, this is where I can configure what's my data root, where is my system database directory, and you'll notice my system database directory is sort of forced into this MSSQL 16 inside out to MSSQL data, but it's forced there based on this root. So you'll see if I change SQL servers, I'm just adding some S's here, that changes the first part of the path for my system database root, but it doesn't change the end. So the end is kind of hard-coded based on the instance name, and it's going in this MSSQL data folder. The first part is the root, so it's always going to be this. You'll then see the root is also used down here for your database, your log, and your backup directory. However, it's still editable. So I don't have to use the root. I can take that off, or I can completely change this. So I'm just going to put my root back to the standard SQL Server folder. You'll notice that changed everything that was using it below me. But in a lot of cases, your user database directory might be your whole D drive. So I've seen setups where you say D SQL data, and that's where all your SQL data lives. And then you say E log data, and that's where all your log data lives. So these folders can be changed independently of your data root directory. Your data root directory really just controls where your system databases are going to go. I can come over here and configure TempDB. TempDB is a system database that stores things, as the name suggests, temporarily. It helps you do things like temp tables, putting things in and out of memory. It's very integral to the operation of SQL Server. And you'll see here, I can configure lots of things about it. There's other lessons where we'll talk about the system databases and the importance of TempDB. But here, you can set up some things prior to finishing your install. So you don't have to come back in and do this later. Number of files, how big are each, what's the auto-grow limits. So all that stuff can be set up here. You can give it different data directories, so I can actually add or remove more than one log file. So you'll see here, I can say this goes to the data directory. That's fine. Here's my log directory down here. So where does my TempDB data live? Where's my log file live? And you'll notice number of files, it recommends 8. So essentially, your first one's going to be called TempDB MDF, as is the case with all databases. And your subsequent ones will be called TempDB MSSQL _ and a number, TempDB 1, 2, 3, all the way up. And a general recommendation is it often recommends having a file in TempDB per processor on your machine. So mine's recommending 8, with an initial size of 8 and an auto growth of 64 and an auto growth limit of 512. This is all just sort of the TempDB configuration. You can go back in after install and modify your TempDB as well, but this sort of lets you do a little bit of TempDB setup now because it's a fairly common thing to do after setup. So you can sort of get a head start on having to deal with this later. You can get this all done here. Last 3 tabs on the database, you have max degree of parallelism, so you can set this up. They detected 8 logical cores, so it suggests 8 for the max degree of parallelism. That's basically the maxed processors that can be employed to run a single statement. So as I'm running a SQL statement, if I have my max degree of parallelism at 4, that SQL statement can only be striped across 4 processors. In this case, it's allowing it to stripe a single statement in parallel across 8. Next, memory. This is setting the min and max server memory. Again, it's a very common thing that you go set up after install, so it gives you the ability to set that up here as part of your install. And finally, file streaming. Do I want to enable file stream access for Transact SQL? So if I want to enable file stream to be going in and out of Windows shares to where I can literally stream file data down to the hard drive and then return that file data as though it's part of a SQL database, that's how file stream works, a little outside the scope of an install. But if I need file streaming, or I have to have databases that have file stream access, you have to enable that here as part of setup. So that's where you would do that on your database engine configuration. So once everything's the way you like it, you go ahead and click Next. And last thing you'll get here is basically a summary. So it'll break down every one of these little pages, the prereqs, the config, the instance config, and it'll show you all the selections you made. So you can look at this and you can decide, yes, this was good or bad. It also, you'll notice here, creates an INI file. So if I go out after this setup and look at this file will have all the configuration options that I installed here. So if I want to do this exact same install again, I can take this INI file, ship it off to somebody else, and say, run your setup, use this config file. And all these same options will be selected. I can also wrap that into a silent install where basically I fire up the install of SQL Server on your machine. It looks at this file and you get these exact same settings. So it's a good way if you want to do multiple installs and you don't want to have to go through the wizard every time to sort of save yourself some time and effort, or possibly do silent installs for like remote deployments on a network. So that's it for prepping. Next thing we do is we click install. And as you might guess, this is going to go do the install with all the options that we configured. So we'll let this run. And as soon as it's done, we'll check back in and take a look at the new instance. So there you have it. It's actually, it's fairly quick if you're only adding a database engine because it's all the shared features are already there. So it doesn't take too long and the install completes. And now, as you can see, succeed, succeed. If I would have had a failure or any issues, it would be in this details box. And it does also point me down here to the file that contains the summary of this install. So everything that you selected, everything that's happened will all be in that file. So I'll go ahead and click close. I can now shut down my SQL Server Installation Center here. And now when I go back into Management Studio, I can connect to this new instance. So I'll just hit Connect, Database Engine, and we called it SQL Server Inside Out 2. It won't have the same SQL authentication as my other one, so I'll change that to Windows authentication. And I'll just go ahead and hit Connect, and if everything has gone the way we expected, there we go. We have connected to our Inside Out 2 instance. And you'll notice it does not have any databases because it's brand new. And you'll also notice its SQL Server agent is offline, unlike the SQL Server agent for our primary instance, because by default in the setup, and we didn't change it, we told the SQL Server agent to start in an off state. So it's basically disabled and you have to start it manually. Again, not all SQL Server deployments are going to use the agent, so they don't start an extra service if you don't need it. So there you go. That is how you can provision a SQL Server instance. And again, it's the same whether it's the first instance or the 50th. You just might have a slightly longer install because you're putting on all the shared components. But as you need to deploy these instances, you can come back to the configuration center, manually run through the install as we saw, or you could take that configuration INI file and use it in a later install. So during the installation of your SQL Server instance, you were given several options for configuration. You were able to set the memory, you were able to set up some tempdb stuff, and a few other minor things. But there's a whole host of other options that you'll have to look at, and just want to take a little time and walk through what those options are, because after install, you'll often want to go through, do some configuration, and get your SQL Server instance into the kind of state you need it to be in. So most of the configuration you're going to do post-install is done on the instance itself. So here in Management Studio, I'm going to right-click on my instance and select Properties. Now, a couple of these tabs are covered in other lessons, so I'm going to go through them all, but there's a few that I'm going to point you elsewhere because we're not going to go into detail here. So when you first come into the server properties, there's a bunch of pages. The general page here kind of gives you a little bit of read-only information. What's your instance? What version? What operating system version? All that good stuff. How many processors are in your machine? How much memory is in your machine? What collation did I use? Am I clustered or not? So this is just sort of an informational page. Nothing you can really do here, but you can definitely get some information about your server if you need it. Now, let's start with the memory page. This was configured in the install, and we went over this in detail in another lesson, so I'm not going to retouch on this, but this is where you can set up your memory options for your instance. Processors. Now, you have more and more these days, you have multiple processors in machines. This didn't used to be a thing, but for example, I have 8 logical processors in my laptop. So servers certainly will. And then this allows you to do some configuration with those processors. So you'll notice at the top, there's an Enable Processor section, and it says automatically set processor affinity for all processors or automatically set I/O affinity for all processors. So I am able to expand this little all. There's a very tiny little check mark, but I can expand that out. I see Newman node 0. I can expand that out, and then I see all my processors. So because this says automatically set, if I check processor affinity for one of these, I can't do anything. And if I set IO affinity, I can't do anything because they're automatically set for all processors. So I can't mess with my affinity or my IO affinity. However, if I uncheck one of these or both of these, you'll now notice that I have access to IO affinity, processor affinity, and I can turn that on or off at processor levels. And you'll see I start to get this weird look because I'm turning one on to IO affinity, I'm turning one on to processor affinity, and so I get this icon here that sort of means one or more of your boxes are checked. Okay, this allows me to set them up for either one. Now, one thing I do also want to point out, because this applies to every one of these pages. So in all these pages, if you don't know what something is, so if you don't know what these memory settings are, or if you don't know what this processor affinity or IO affinity mask is, at the very top there's this help button. And if you click that help button, it'll pop you out to the Microsoft documentation library. And in this case, you'll see it's very specifically the server properties processor page. So then I can scroll down. It says specifically this assigns processors to specific threads to eliminate processor reloads and reduce thread migration across processors. And then if you need more information, you can go over here and click this, and that takes you into further detail. IO affinity binds the SQL Server disk IOs to a specific subset of CPUs, and then for more, you can click on this. So this gets into some fairly advanced server configuration stuff. But I just wanted you to see, and then on the left here, you'll see for every server property page, there's a little help file. So if you ever need more information on what these things are, you can come over here and you can see exactly what they are. And if they're complicated, like affinity, it'll take you to other documentation about how to set these things up and what they do and how you can tweak them, okay? So I'm gonna leave them to automatic. So basically it lets SQL Server sort of make its own choices on how it wants to set affinity for my IO and for my processor. So I'll leave those alone. The other thing down here is your max number of worker threads. 0 means dynamic, and actually you can see that in the documentation I still have up here. 0 allows it to dynamically manage the threads. In our case, that's fine, but you can also crank this up or down to limit the number of worker threads that SQL Server is able to then spawn to do various things. Moving on to the security pane, this again, you had access to some of this in setup, what kind of authentication mode you wanted to use. This also has logon auditing and some server proxy stuff that is covered in different lessons, so we're not going to talk about that anymore here. The connections page. So this allows me to actually set up some stuff about my server connections. So I can limit my number of concurrent connections to the server. So if I need to, for performance purposes or some other reason, I can come in here and say I'm only allowed, say, 10 connections for the whole server. So once we have 10 connections, no one else will be able to log on. They'll be told no. 0 means unlimited, and I'm going to leave that alone. You can also use a query governor. And so you can turn on query governor, and then there's this arbitrary value. Again, if you go look in the help file, it kind of tells you about this. But what this arbitrary value happens to be here is time. So what that means is I'm going to prevent long-running queries if I check this. So if I get up to 300 seconds, which if you do the math is about 5 minutes, then I will stop that query. So you can use that query governor to prevent long-running queries. It's a neat feature, but I implore you to really do your homework before you turn this on. If you really don't think you'll have queries that run over 5 minutes, cool, turn this on, it'll help you. But a lot of times you'll turn this on and people start getting kicked out and you don't let your queries finish. Typically on a OLTP transaction-based system, you might be okay with this, but if you're on a reporting system, for sure you're gonna have some stuff that can take a while. So be real careful if you turn on the query governor. Now down here you have all these default connection options. So these are the options that will be applied to the connection from the client as it comes into the server. And again, these are the default options. You can always change these within Transact SQL scripts or within your connection. So things like implicit transactions. So am I going to implicitly start and stop transactions? ANSI nulls. So ANSI nulls, do I have to refer to nulls as things that equal null or that I have to say this is null. No count. So by default, when you run a SQL query, it spits out the count at the end and it says you read 75,000 rows or you inserted 1,500 rows or whatever. A lot of times in scripts, you'll put set no count on so that as you're doing stuff, it's not just firing these counts back at you because you don't care depending on the client. So you can have that be the default option. Right now, the default option is no count is, this is confusing, but no count is off. And no count off means you'll get counts. By turning no count on, you don't get counts. So these are just all the defaults. How you handle ANSI nulls, how you handle concatenating nulls, all that stuff. And again, these are all changeable per connection, but these are the defaults if the connection doesn't otherwise specify. Down here, very important checkbox, remote server connections. Allow remote connections to this server. If I take that checkbox off, no connections can be made to the server from another machine on the network. So essentially, I stop listening on the network. So you have to have this on in order for connections to be made to the server that aren't made from this server. You also have a remote query timeout. So in this case, it's set to about 10 minutes, meaning that any query running on a remote machine for more than 10 minutes will start to time out. Okay? 0 means no timeout. You can also require distributed transactions for server-to-server communication. Again, kind of an advanced topic, and transactions aren't something we're covering in this lesson. But essentially, if I turn this on, then when I talk, say, server-to-server, as I set that up, I have to have transactions in those communications. And those are called distributed transactions, and there's a whole distributed transaction coordinator that's involved in this, but this sets whether or not they're required. So again, beyond the scope of this lesson, but if you need to require distributed transactions, this is where you set that up for your server. Database settings is our next tab. You'll see here, this is a lot of defaults. So this is a lot of what's your default index fill factor, which is set to 0, which is essentially 0 means dynamic. It means managed by SQL. But index fill factor, and we'll cover this in another lesson, is how full each page of an index is before it starts a new page and does some index building stuff. And we'll talk about that in a different lesson. Backup and restore. You'll see the top here, and it's grayed out because I don't have tape, but you'll see how long does SQL Server wait for a new tape. So if you have tape backup systems still, you can configure SQL to work with them, and here's some of the options for that. Backup media retention days. If you say 0, it means forever. Do I by default want to compress my backups? Do I want to do backup checksums? Those are all options here. What's my recovery interval as databases come online? Again, 0, it's managed automatically. And down here, this was something you specified in setup, the default locations for different folders. So by default, if I create a new database, you're going to want to put the data file where? And it's in the install path MSSQL 16 / the data folder. Where do you put the log folders? By default, this one, same place. And again, I could have set these up in setup. I can change them here so future databases that I create will default to these locations. Where's my default for a backup? It's the backup subfolder. And again, these are just defaults. So I can leave these like this, and when I go to create a database, I can still put the data files and log files elsewhere. And when I create backups, I can still put them elsewhere. This is just the default. Especially if you have more than one person managing servers, it's nice to have the defaults correct. That way they don't have to go ask somebody, oh, I'm creating a new database, where should I put the stuff? It's like, well, we have the default set, so you can utilize those. So that's what this is all about. And again, you got this in setup, so this is where you change it if you want to change it, or if you didn't know during your setup. The advanced page, this basically these are the advanced settings. And you'll notice rather than a pretty GUI, they're just sort of tossed in to almost like a properties window, like a Visual Studio's properties window. And this allows you to turn on certain things, like do you want to turn on file streaming? And we saw it in setup whether you turned it on or off. And you can do that here. Do I want to enable constrained databases? Do I want to boost my SQL Server priority? So a lot of these you'll also see, in addition to being able to click help, as I click some of these, it gives me a little blurb down at the bottom. So for SQL Server Priority Boost, you'll see not recommended. So that's pretty good. And it controls whether the SQL Server should run at a higher scheduling priority. So essentially the thread or the process running SQL, do I want to boost that to a higher priority? And literally it tells Windows to boost it to a higher priority so that other threads running on the machine would sometimes get the back burner to SQL Server. Okay, and for each one of these, again, a lot of these are kind of super advanced, and unless you really have a reason to change some of these, you shouldn't be, but it gives you a little blurb as to what each one of these do. Okay, so if you come in, if you're having an issue, say with text replication, you can set sizes here. What's your 2-digit year cutoff? So everyone remembers the Y2K problem, and that was where when you specified year, they specified it in 2 digits. And so the concern was in 1999, when the clocks changed over to 2000, it suddenly thinks it's 1900 because it didn't understand 4-digit years. So that situation still exists in computers. We just handle it slightly differently. But SQL Server, if I give it a 2-digit year, what is the 2-digit year cutoff? And in this case, the default is 2049. What that means is if I specify January 1st, 48, it assumes that you mean 2048. If I specify January 1st, 50, because the 2-digit year cutoff is 2049, it actually assumes that now is 1950, okay? So there's still quote unquote Y2K or 2-date issues in computing, and this is one of those that could potentially be an issue later. Under the covers, though, SQL stores everything in a 4-digit year mostly. So this is just sort of when you're typing in and specifying things in code. Anyway, there's also some lightweight pooling and some parallelism. And here's that max degree of parallelism that you were able to set in the setup. So I can tweak it here. So these are just, again, some advanced settings, and they're just sort of like tossed into this properties dialog box. But this is where you can go to change some of those. Last but not least, we have this permission tab. Now, this will be revisited in another lesson as well, but this is essentially all the different permissions that the server has that you can assign to logins. So you can give people permission to do these things. And this is covered in our discussion of SQL Server security. So I'd say go check that out if you have further questions on what this is, but I'll just very quickly show you one. For example, here is your connect to SQL permission. So I can go in, and so this is the login I'm trying to edit, right? So I can take a look at, say, this inside out login, and down here on the connect to server, it does have that, right? It's granted, connect server is granted. Who granted it? SA, which is the system admin. So SA, the system admin, says that inside out can do this, but I could also deny it by checking that. And now you'll see I got a little box over here indicating I'm changing something. So essentially what I'm doing here is saying, no, you know what? I'm going to deny inside out the ability to connect to SQL. So the login still exists, but they won't be able to connect. And this applies for all the different permissions. And this is covered in the SQL Server security lesson in good details. We'll talk about what grant is. We'll talk about what grant with grant is, and we'll talk about deny, and we'll go through all these server settings in that security lesson. So if you need more detail on that, you can come back here. So that's pretty much all the stuff that you'll need to configure post-installation. The other thing, and there you can refer to the lesson on SQL Server network configuration. After an install, you'll often also go in and configure the protocols that the server can listen on. So that's all set up and is covered in the SQL Server network configuration lesson. So you can check that out there. That's pretty much it. So remember, all these properties and all these settings are under the server in the properties dialog. And you can get to that by right-clicking on your instance and going to properties. Bring up that entire dialog. And typically after an install, I mean, most organizations, you'll sort of have fleshed out a list of here's how we configure servers, and here's how we configure security, and here's how we like everything. So typically, you kind of have your standards that you'll go apply to these. If you don't have those, it's a good practice to start creating them as you configure these servers. And you saw that about, I don't know, it's a fairly low percentage, but maybe 10 or 15% of that can be configured during setup. So if you have some INI files where you're doing standard setups, you can kind of get ahead of the game. And then after the fact, you can come in here and this is how you configure the rest of your SQL Server properties. So when you set up your SQL Server instance, there were options available to install different features, some of which were shared features, some of which were server level, but some are database specific. So we're going to take a look at how you can add database features if you didn't during your initial install. And then we'll take a look at the configuration of a database and just sort of look at the options and parameters that are available to set on all of your databases. So first of all, what I'm going to do is bring up the installation center. So this is very similar to when you install a SQL Server. So I'm going to bring up from my 2022 folder, the 2022 Installation Center, and I will get this SQL Server Installation Center. We've seen this in a couple of the other lessons. And I will click Installation. And in this case, I am going to add features to an existing instance. So I still, just like I'm installing a new version, I'm going to click this top link, which is add or an instance or add features. I have to browse to my source files, which are on my C drive, SQL 2022 Developer Edition. I'll hit OK, and the installer will launch. It's going to go ahead and run through all the checks as though you're installing a new SQL Server instance. And if you have anything that's a showstopper, you'll have to reboot or you'll have to fix your source files or whatever. But in general, you can click through this relatively quickly. And just like when installing an instance, you might get warnings such as the firewall needs to be configured or things of that nature. I have nothing failed, so I can just go ahead and move on. Now, when I get to this page, when you're installing a new instance, you choose the option at the top, which is perform a new installation. I want to modify an installation already on my machine. So I will select the second option, which is to add features, and I will pick my SQL Server that is called SQL Inside Out 2 and click Next. Now this pops up and it asks me would I like to add the Azure extension because it's not installed in this database. I do not want to do that at this time, so I'm going to clear that and move on to the feature selection. Now here are the features that I'm able to configure for a database instance. The bottom half is shared, so those can be installed in one copy for all. But the top half are features that are specific to your database. So you can see in this case, in addition to the database engine services, I have SQL Server Replication installed on this particular database. If I needed to add SQL Replication, I could do it here. You'll notice I can't take anything off. So once a feature is installed, it's installed. I can uninstall that entire instance, but I can't take features away. So let's just go ahead and add full text search, data quality services, and the Polybase query services. Now you notice a few things happened on the right here. First of all, down here, it told me how much disk space was required. This is 8 gigs that I'm adding, just these 3 things. You'll also notice it says there's a prerequisite for one of my selected features. In this case, that's the Microsoft Visual C++ 2017 redistributable library. I'm going to back this off a little bit because one, I don't want to use 8 gigs, but you can see I do already have my prereq, so I wouldn't have to install this. Otherwise, this could give me a warning that that has to be installed first. So you'll notice as I check and uncheck, it tells me how much disk space is required in this box. So the Polybase query service is quite large. Like it goes from me needing 423 megs to needing 8 gigs, essentially, of disk space. So I'm going to clear that, and I will clear the full text search, and I'll just install the data quality services feature because it's only 2 megs, and I'm just sort of showing you how you can add these features. So again, you can do this when you first install the instance, or you can go back as we're doing here. If you need something like reporting services, that's downloadable from the web, and they give you a link right here for how to go get that. So that's it. You'll notice the bottom here is all grayed out because this is an existing instance, so I can't change any of its root directories or its shared feature directories or anything like that. I'll click Next. It should basically check to make sure that I'm not going to run into issues here. There we go. That flashed by very quickly. It was this feature configuration rules step. It didn't find anything that was a problem, so it took me automatically to my summary. And you can see here, this is similar to when you install a server, except we're going to go ahead and just put on the, there it is, the data quality services. It's right here under features. And you'll see prerequisites Still listed, but it's already installed, so that will not be getting added this time. So I'll just click install. And unlike a full instance install, this is basically going to go out, see what instances you have, and it's sort of spitting everything out on the screen that it's doing, but it checks what instances you have, make sure you have the right files for installation, and then it goes ahead and it adds the extra feature. This will be much faster than a full install because we're only adding this little 2 meg data quality services feature. There you go. And when it's done, it'll pop up this complete dialog. If there were issues, it would have printed out down here, but it tells me that I installed the data quality services feature and that was successful. I can get a summary of that just as I can for a full install from this link down below. So I'm going to go ahead and hit close, and that's it. So now I've added that new function or that new feature to that particular instance. If I need to add that to all my instances, I would have to go through this each time for each instance to add those features. Now, while we're talking about database features, I want to take a look at the properties of a database and look at some of the things that you can configure. So I'm just going to look at the properties of this worldwide importers database. You'll see there's a bunch of pages. As with servers, the general page is all grayed out. It's informational. It tells you how big things are, how many users I have in the thing, the name, the last time it was backed up, the correlation, stuff like that. The Files tab we talked about in another lesson, so you can reference that. It's the files that make up my database and the file groups that make up my database. I want to look at the options. So these are some of the things you can configure on your database, and some of these are visited in other lessons, so I'll kind of touch on those. At the top, you have your collation, your recovery model, and your compatibility and containment type. The collation is basically things like sort order and what kind of character sets I'm allowed to use. And the default for an install in the US is Latin 1 General 100. If you need a different character set, obviously they have just tons of options. It all depends on the type of data you'll be storing, and it's very specific to your install, but that can be changed here at a database level. The recovery model, which is covered fairly substantially in the backup lessons, is essentially how is it going to use your log? Is it going to be a full logged system where until you back up, that log data stays alive? Is it bulk log, which will log less but still requires backups essentially? And then simple, which essentially uses the log as temporary space until a checkpoint occurs. And then it flushes that data to the database and it deletes the log. So in that case, your log is, backups aren't required, but you also have less backup options. And again, that's covered in the backup section. Now, your compatibility level is one of the features that you do care about. You'll notice here my compatibility level is SQL Server 2016. If I drop this down, I can go back as far as SQL Server 2008 and forward as far as 2022. And essentially what this sets is when I'm writing transact SQL code, how will it behave? And if you have older code in your environment, changes get made as SQL Server releases new additions. And sometimes statements either don't quite behave the same way or don't work at all. And by setting a compatibility level of 2016, I know that if my code can run against a 2016 server, then it should be able to run against this database, even though it's a 2022 database. As you then test your code, and you can update this compatibility level in the future to say, you know what, let's make it 2022 to take advantage of whatever might have changed with the 2022 syntax. There's also database containment, which we're not going to talk about in this lesson. It's defaulted to none, but this is where you can change it if you need to change database containment. Down here are all the other sort of nitty-gritty options that a lot of these you don't have to play with too often, but if you need to mess with any of these settings, or if you have a particular issue, and I'll talk about one of those issues here in a minute, this is where you can find a lot of these properties. So this top section is all your auto-create stuff. Do I automatically increment statistics and auto-create statistics? Statistics are like, it's not quite the proper term, but they're like light indexes, sort of. It's not a great way to describe them, but they're created and they offer information to the query engine when you're querying those tables. Auto shrink is just what it sounds like. It's the opposite of auto grow. So if you have files that have free space in them, auto shrink will run and potentially reclaim disk space. Because remember, with database files, there are two components. One is the size of the file. So in this case, my primary file is about 1 gig. That doesn't mean I'm using a gig. It just means the file on disk is 1 gig. If you look at your general page here, you'll see the total size of your database here, and that's the size of all your files. But then you'll see space available here. Space available is how much free space does the database have inside those files, okay? So yes, this file is 1 gig on the hard drive, but it may only have a couple hundred megs of data inside it that's actually being used. So when you look at these options here, the auto shrink basically can say, oh, I'm only using 200 meg of this gig file, shrink it down. It's a costly operation, and it's also something you typically want to do on your own, which is why the default here is false. So anyway, there's some auto statistics there. This is the section on database containment, which we're not going to go too far into. You have some cursor options. Here you have some scope configuration. We talked in a different lesson about max degrees of parallelism, how many different threads can queries break up on. This is, again, someplace you can tune that. If you're using file stream, you can tune the directory name here. And there's a couple of things down in miscellaneous that you might touch. And essentially, it's some of the ANSI defaults, right? So ANSI null, the default is false. ANSI padding, default false. So if you want to change these and have your database behave slightly differently for ANSI nulls to be enabled by default, you can say true here. And again, these are just some database defaults. Now down toward the bottom, you have recovery, which is when a database is coming online. And in this case, it does a page verify by a checksum. You also have service broker stuff, which we're not going to get into. But this very bottom one, you might run into this and have issues with this occasionally. So I wanted to point it out specifically. This is your database state information. You'll notice the very first one is read-only. If I change this to true, that essentially means this database is read-only and I cannot write to the database any longer. So if you're having trouble writing to a database, check this because it could be a read-only database. It will show, or should show if I click OK. Yep, you have to close all the connections, so that's OK. And I'm going to go ahead and say yes. So what that's going to do is if there's any connections directly to that database, it kicks them off. But you'll notice now next to my database that says read-only. So I can do that, and that's fine if I have a read-only source. But if you're having issues with that or you expected it to be write-only, this is where you change that on this Options tab. So I'll change this back to no because I want to be able to write. False. There we go. And the other thing here, you can disable or enable encryption, which is another topic, but you could restrict access. So by default, the restrict access here is set to multi-user. You'll see I have single user and restricted user as well. Sometimes, especially in certain recovery formats, things where you're trying to set up spares, a couple different reasons, sometimes you can have a database that's in single user mode. So I'm not going to click OK just because it gets a little complicated, but a database in single user mode means the first user that connects is the only user that gets to connect. So this is useful, say in a situation where I have to do some sort of administrative work inside my database. I need to move data around, or maybe I want to take it offline so I can re-index. There's a couple different reasons why you might have to do this, but I don't want other people allowed to connect to my database while I'm doing this because A, maybe they'll get incorrect data, or B, I don't want them adding data if I'm moving where that data exists. And so I want to put this database in a state where I can still connect to it and I can still run the things that I need to run and do the operations I need to do, but no one else can connect. So then you put the database in single user mode. So I will actually go ahead and say, okay, we can play with this. So you'll notice it says you have to close all the other connections. So I say yes. And what that does is that's going to boot everybody else out of my database, make this change. And you'll see over here, this has gone to single user mode. Now I'm going to expand my database here and expand the tables folder. And you'll see I got that back, no problem. Okay. This particular user, whatever connection is made here in my Object Explorer, just connected to the database and listed the tables. If I right click and go to new query, and now you'll see my cursor's kind of thinking, and over here, My database context is set to master, and nothing's happening. My SQL Server Management Studio is sort of locked up because what it's trying to do is establish a connection to that database. So it finally just came back. So let's see what happens. Select star from sales. And you'll notice I'm not getting my IntelliSense, right? Normally I can type sales dot and it says, oh, hey, there's an orders table or sales.order or whatever. I'm not getting that. And if I hit execute, I'll get my query back. But then if I come over here and let's refresh this table listing, see how it's thinking again. And it did not come back, did not show me the tables. So what happened essentially, this query took over and is the single user. I can no longer connect over here. If I start a new query and I copy and paste this same code here, actually it's even trying to connect and it can't. So essentially this single user here has blocked any other connection from happening. So it's going to sort of lock up the management studio a little bit while I do this, because it's waiting for all these connections to time out. And the connection timeout's about 30 seconds. So I can't establish another query against that database. I have my one here, which can execute just fine. And if I go over here, you'll notice this query finally opened, but it changed to the master database. So if I try to change this to worldwide importers, it's going to time out. It's not going to let me. Okay. So I'm in a complete single user mode scenario right now. The other problem with this, if I right-click my database and hit properties, it's going to sit here and twirl and think, and it's not able to open up those properties. So in order to put this back in a multi-user mode, I either have to run a T-SQL query to do that, okay? And it even says, by the way, in this dialog, that an exception occurred, worldwide importers is already open and can only have one user. So it's even telling me it's in single user mode. So I can either run a command line query to fix this from my one good connection, which is this query here, or I can close this. And when I close this, that connection should have dropped. And now when I right click and hit properties, I'm back in. But now this is the only connection. So I'm blocking everybody else. So we're going to go ahead and flip it back to multi-user right here. But that's what the single user experience is like. You get one user, and it's not user. It's not as though because I am the same user connecting multiple times. It's really one connection. It's really what this means. One connection at a time. So I'll turn it back to a multi-user environment, and I'll say yes. And now my database is back. There's a few other tabs in here. Most of these are going to be covered in another lesson, so we'll just talk through them quickly. Change tracking lets you turn on change tracking, which kind of helps with changes being made to your database. So if I turn this to true, you can see I can set some retention periods and clean up, but I can see what's happening as changes are being made in my data. So I'll leave that at false. All of the permission stuff will be covered in a security lesson where we'll talk about SQL Server and database permissions. So this will be revisited in that lesson if you need to check that out. Extended properties are things that, they're just that. They're properties you can tag on your database that are valuable for you. And maybe your application needs to query certain things or see certain things. So for example, if I want to tag some information about my database here, I can double click and I can give it a name such as data version. And then I could type something in here like 2.1. And essentially what I've done is I've made like an internal property, an internal tag that says the data version of this database is 2.1. That doesn't mean anything to anybody except you as the designer of this database. So you might have to have an application connect and say, hey, check my database version. And it can now go look at this extended property. And you can name these whatever you want, and they can have whatever values you want. So you can have a ton of these if you need them. And they're just ways to provide more metadata about your database to your connecting clients. The mirroring tab is used to set up database mirroring and transaction log shipping to set up transaction log shipping. And those are both recoverability options that will be discussed in a different lesson. Last but not least, the query store is covered in the tuning lesson if you want to check that out. But essentially, this is turning on or off the query store, which will cache execution plans, and you can later use that cache to either run a tune against or to just dig through manually and look for queries that are having possibly some performance problems, and gives you a way to capture a little bit of history so you can see what's going on inside your database. So those are the database options. Any features you need to install on your database, be it replication or the data quality services, that can all be done through the installer. And then we looked at the options that are available when configuring a database. Now, there's a little bit more to database configuration and some security pieces and parts that we haven't covered in this particular lesson, but there are lessons on those in this series that you can look up if you have questions on security or if you have questions on database creation. Creating new databases on your SQL Server instances is a fairly straightforward process. You basically set up how big you want them to be, where the files go, and set up all the options on the particular database. But there's a little more tweaking, and there's a couple other little things that I just want to walk through so you can see how everything interacts. So to make a new database, you simply, in Management Studio, and all of what I'm about to show you can also be done via a script. But through Management Studio, I'm going to right-click my databases folder here and say New Database. This brings up the New Database dialog. And the first page is quite simple. You just give it a name, specify where the files are, and specify the owner. So if I call this Inside Out DB, and I can leave the owner as default, that's fine with me. You'll notice it took my database name and it put it down here as the logical file name for my data. And it also put it as the name _log for my log data. All databases need data and log. So that's why it created both of those for me. This doesn't set up any of the file groups. It doesn't set up anything else. So if I want anything more advanced, I can do that here, but I don't have to. I can come back later. So you'll see here, the primary file group got my data. It set them both to 8 megs, my data, my log. It turns on autogrow, and it goes to your default directory that was configured at your SQL Server level. Over here, you'll see file name. This basically will ultimately get set to this name. Right now, it doesn't have a name because I haven't hit OK. And I could type something in if I really cared what it was called, but I really don't. So I'm going to leave that alone. Now, if I wanted to do file groups stuff, I could do that now. So I could come over here and create additional file groups. There's a lesson on database files that you can look at to see how these things sort of work together. But I could do that now, or I could come back and configure that later on. So I'm not going to do anything crazy with file groups. The options page here, there's a whole lesson on database features and options you can look at, and this is basically those options. So you can set all these now. They all have a default value, or I can come back and change these later. So you'll see, because I'm creating this on a SQL Server 2022 instance, the compatibility level is 2022. I have partial containment, recovery model full, and default collation. So when you're happy with all your settings, just click OK, and it goes ahead and creates that database for you. Now, you'll notice if you have gone through the lessons or if you've already played with SQL Server, there's nowhere for me to set in here anything about, like, here's database settings, but this is just index fill factors and log file locations. So there's no way for me to set all these defaults. So when I say new database, how does it know to set it to 8 meg and make it 64 meg of auto growth? And how does it know these are all the options I want? So one answer is it could just be these are the defaults and you live with them. But that is not the case. Because there are so many options on a database, rather than store all these in some sort of settings dialog at the server level, there is a very special system database that's installed with your SQL Server that's called Model. To see your system databases, you'll expand this system databases folder, and you'll see we have 4 in here. There's others depending on what you have installed, but these are sort of your primary 4. Master, the database that knows everything about your server and all the databases and all the logins. MSDB works with the SQL agent and contains all the jobs and things that you can schedule and run on your instance. TempDB is just that. It's a temp space for doing work when you create temp tables or temp variables. data is stored in TempDB. But then there's this model database. Nothing is stored in model. And if you expand it and look, there's no tables, there's no views. Model is basically a big empty database. But because it's a database, it has all the settings and all the configuration that your user databases have. So you'll notice if I right-click model and bring up its properties, its files are set to 8 meg and 8 meg. And the auto growth is 64 and 64. And if I look at the options, all these options are set. This essentially becomes my de facto default for all databases. So say I want to auto-create incremental statistics. I can change this to true. And auto-update statistics asynchronously. I can change that to true. And I'll hit OK. That saves the change to my model database. And now, when I go to my database folder and say new database, if I look at options, those things are now true. So essentially, when you go to create a database, it clones all the options from model and puts them into this new database. So if I don't want auto growth on by default, I'll go into my model and I will say, don't enable auto growth. This will not affect any other database. So I'll just hit OK on model to make that change. And you'll notice my inside out DB, which we just created, if I go to its properties and its files, it has auto growth because that's what it was when we created this database. But because I changed model, if I make a new database, auto growth is now off. So essentially, that's the role of your model database. Now, it is a database, and you'll note that if I go look at these properties, go to the files, right over here is the path to that file. And it's the install directory path for your SQL Server. So let me just very quickly pull up a file browser, and we'll go to C, Program Files, Microsoft SQL Server, and we'll just drill in MSSQL 16.insideout, MSSQL, data. You'll notice in here there's a model MDF, and then there's some backups, and then there's the model log. These both exist on my hard drive. They are both 8 meg on my hard drive. They're taking up 16 meg on my hard drive. And literally they're just sitting here to hold settings. There's no data stored in these. But because they exist, I just want to caution you against if you want all your databases to be, I don't know, 5 gig whenever you create them, that's probably the one thing you want to leave out of model. You don't want to set your model database to be 5 gigs necessarily, because now it's literally going to take up 5 gigs of space on your hard drive for no reason, because it's fairly empty. So that's the one place where I would steer away from using model to size your databases. Just use model to do all the settings and all the configuration that you want, and then that'll be applied when you create a new database. Now, whether or not you use model is sort of up to your environment. In a lot of SQL environments, you're not constantly creating databases. So this is there, and it's something you can utilize. But in general, a lot of SQL installs, you have these big systems and they're running databases, and you don't really change the database all that often. So if you're running the kind of system where you're adding databases on the regular, model might be a good thing for you to utilize. But otherwise, you can just sort of leave it alone. And when you need to create new databases, just make sure you either script it or create it with the options you want. And I do want to show one more thing. So I said, and this applies to all of Management Studio, you can script any of these things. So when I right-click, new database, I get it how I want it. Let me just put inside out, I'll just call it script DB, and I'll spell it with all kinds of crazy lowercase and uppercase letters. And instead of hitting OK here, when I'm happy with it, what I can do is I can hit this little script button up here. And you'll notice it's a drop down. So I hit this, and I can either script this action to a new window, I can save it off to a file, to my clipboard, or I can even save it as a job step in my SQL Server agent. Probably wouldn't want to save creating a database as a job step, but maybe creating users or I don't know. There's lots of reasons why you'd want to run things in jobs. But the bottom line is everything in Management Studio, because all Management Studio does is run scripts against the database, is a script and therefore is scriptable. So I'm going to, rather than hit OK, say script this action to a new query editor window. And you'll notice that this query editor window popped open behind my dialog. And I'm just going to go ahead and hit cancel. This explicitly takes every single setting that was set in that database dialog and scripts it out. So here's all my auto close and auto shrink, and it was everything set in that dialog at that time. Here's the name of the database, the name of the files, the path to the files, and if you scroll down, here's the altered statements because they have to alter certain things to turn certain parameters on or off. And this is what would have run in the background had I clicked OK. Now, not all of this is needed by default to run a script. So if I were to run this, I'll just hit F5, which is execute, you'll see it completed. And I can come over here and refresh my database folder. And there's my inside out script DB. But on a fundamental level, to create a database, all you really need is the name and the files. And you don't even really need the files. So I can delete everything down here. Delete all of that. Okay. I can delete this with ledger. I can delete this containment. And I can take it down to create database with a name. What are the files? Now, if I try to run this again, it's going to fail because I already have a database with that name. So I could call it inside out script 2. I can keep the file inside out script. That's fine because these are logical names that are stored inside the database. What I can't, however, keep, if I scroll over, is the physical name of the file. That's the thing at the end of this path. So here, I would at very least have to change these two. So I can change that one to inside out script 2 MDF and change this one to inside out script 2 _ log. And then when I've got everything the way I want it, I can hit go, and you'll see I still created my database. So I can refresh, and now I have an inside out script 2 database. But because I didn't specify every single option that's available on that create database dialog, where do you think it got all the options to create this database? If I right click and I look at the properties and I take a look at the options, auto creates incremental statistics and auto creates statistics asynchronously are true. So it goes and pulls all the other stuff from model. So there again, if I create a database, this dialog is filled out by model. But if I run a create database statement where I'm not specifying all the options, those options are filled out by model. So it works both ways. Okay. So that's a little bit about how you can create databases. We looked at using both the GUI and Transact SQL to script those out. And you can write your own statements as well. You don't have to use the dialog as a starting point, but it's a fairly handy way to do it. So with that, you should now be able to run off and start setting up your own SQL Server databases. Welcome to our lesson on provisioning Azure SQL databases. In this lesson, we look at the basics of using SQL Azure databases and servers. While this topic goes much deeper than we will cover, with the ever-expanding usage of cloud services, it's important to at least understand these basics in order to support SQL Azure in your environment. This lesson covers understanding Microsoft Azure and database as a service concepts, how to provision a logical SQL server, how to provision a database, and how to set up security in an Azure SQL database. Let's get started. So with this lesson, we want to take a look at sort of an introduction to Azure. What is Azure? It's Microsoft's service, software as a service or cloud services platform. It's sort of all those things. It's essentially a way for you to get servers or databases or even Windows machines without having to physically purchase a Windows machine and install SQL on it and set up databases. Now, if you're not familiar with software as a service or cloud services, frankly, what they are, I mean, some people get their head around it, and everyone says like, oh, your photos on your phone, they're all backed up to the cloud, and this is all the cloud. Well, what is the cloud? It's not magical. It's literally just physical servers somewhere on the internet that you don't own. So it's not as though the photos on your phone are being backed up to some magical space. They're going to a server and ultimately being written to a hard drive in someone's data center. The same thing applies when you start to talk about Azure, whether it's a SQL database or a Windows machine or a whole SQL server. All that is a database or a server at Microsoft somewhere in their data center on their servers that you can connect to via the internet. So when we talk about Azure, we're talking about shared database services. Now, these are great because I can provision them, I can get them quickly, I can make them as large as I need to make them. I can have servers where I can add demand. When I have more traffic, I can increase the demand on my servers. I can double the processors, whatever I have to do. And you're paying for these things dynamically. So rather than spending $100,000 on hardware and installing software on it, and I'm stuck with that, I pay Microsoft money every month to give me database, or give me servers, or give me whatever it is. And if I need more power or more servers, I can quickly and instantly expand my power, my size, what have you. So it's a great way to set up infrastructure quickly, and especially if you're going to be hosting some sort of shared environment, websites, things of that nature. So I'll take a quick look at connecting to some Azure stuff, and then there's other lessons on how to provision these items. So if you look in my SQL Server Management Studio, I'm connected to my local database instance, which is installed on the physical machine sitting here in front of me. Now, if I hit connect, database engine in this case, I can pick an Azure server. And I'll just zoom in on that so you can see. The name of that server, in this case, is SQL Server Inside Out .database.windows.net. So this is a fully qualified name that's going out over the internet and connecting to this server to get me access to my database on that server. I'm using SQL Server authentication, and I have an account pre-configured, and this is all in the lesson on provisioning databases and servers for how I set this up. But I have this login, it has a password, and I can just now go ahead and hit connect. So I'll do that. And you'll see it thinks for a second, but then it pops up over here, and it's a slightly different looking icon. So let me collapse both of these down and just sort of zoom in again for you. You'll see this one is your standard SQL Server database icon. That's what you see when it's a local server or a server you're connected to on your network through a traditional SQL Server connection. This one here, you'll see here's the fully qualified name, and there's a database folder, a security folder, and an integration services catalog folder, and that's it. I don't have access to all that other stuff because this isn't a full server. This is a provisioned Azure database. So if I look underneath here, you can still see system databases as you would with a standard server. You don't see any of the others. You don't see master, you don't see model, you don't see tempdb. And I have my inside out database here. So if I expand that, inside of this should look very familiar. This looks just like a database on your local servers. I can have tables in here, views, stored procedures, whatever I want. But this database isn't served locally on my server. This database is coming from Azure. It's coming from the cloud. So briefly, I'm going to flip over to the Azure portal, and we'll take a look at what I mean when I say the cloud. So here's the Microsoft Azure dashboard. I'm logged into my account, and everybody can go set up a free Azure account, and you get, I think it's $200 worth of free stuff before you have to start paying. So you're able to sort of play with the environment and understand Azure for free, basically free, no cost, unless you start really using it. And you'll see here on my dashboard that I have a couple resources. One, I have a SQL Server Inside Out, which is a server. And two, I have that Inside Out 2022 database, which we just connected to. So if I look in this menu, I can go see all the different things I can get from Azure. So this isn't just a SQL Server discussion. There's app services, there's storage accounts, there's Active Directory, there's all kinds of stuff you can get from Microsoft and their Azure services. I want to look at SQL databases. So let me just click this, and you'll see I get a list of all the databases that I have set up. And this one is on my free trial, and it's still trying to show me little tidbits like, here's how you can make a reservation, and please click next to learn more. And that's typical of new websites. Sometimes they give you that little tutorial. But you can see here, I have this Inside Out 2022 database, and it's on my free trial subscription, and it exists on my SQL Server Inside Out server, okay? And you'll see that if I hover over this, it kind of gives me a little more information about the resource, right? So it's a database, it's in the Eastern US, there's a resource group set up, it has a pricing tier, all this other stuff. So there are some other lessons on provisioning SQL databases and SQL servers that you can reference to see how all this was created. But for now, I just sort of wanted to show you this is the Azure portal and this is my database. You can also see your servers here. So if I click into this guy, there we go, you'll see this came up and it shows me the database, and over here you'll see the server it's on. This is the same server name we connected to in Management Studio, SQL Server Inside Out.database.windows.net. And if I click that, I go into even further into my server. So here is how that server is configured. Even though I provision this as a SQL database, there still has to be a server attached to it. So that's what this part of it is. So when I connect with Management Studio, I connect to a server, okay? So that's why that there's still a server component in here. If I want more control and more of a full-blown SQL Server, I can also do that. But this is sort of a stripped-down version so that I can provision databases, okay? And back in Management Studio, again, I have my server and I have my database. And this is my Azure Cloud database stored on some server somewhere in the Eastern United States by Microsoft. So that's sort of a high-level concept of what Azure is and what cloud services are. And there are some other lessons you can look at to provision these items and actually get started using the Azure services. Managing and maintaining SQL servers can be expensive and time-consuming, and that's where Azure services can really help you out. You can provision databases and servers online and use them kind of on demand. And so we're going to look at how to provision a logical SQL server in Azure as opposed to having to have physical hardware and provisioning it on something physical in your data space. Okay, so I'm going to open a browser window and we're just going to go to portal.azure.com. I'll paste that in. And if you don't already have a Microsoft account, you'll have to walk through the process of creating one. I'm already logged into mine, so it pops up. Now, a couple things to note. You'll see I have some things popping up on the right side here. Sort of tells me how much money I have left in my Azure account, because in general, you pay for these resources as you use them. So as you move data up and down, you pay for it. You can get a free Azure account, and they give you probably saw that pop up, they give you $200 of free Azure use. So you can look at your account here, and if you dig into this, it'll log you into your account details. It'll show you how much you have in your Azure. So here's your subscriptions and all my various Microsoft stuff. And I can go dig down into this and find my Azure account. And that's how you'll know how much you're using. So not a big deal. You get $200 for free. You can go ahead and set that up at any time. What we want to look at, I have a server and I have a database provisioned, but we want to look at how to provision a SQL server, okay? So I'm going to go to this create resources function right here, and it's going to pop up and ask me what I want to create. And you'll see that there are tons of different things. Here's some popular services. I have Azure stuff. I have web stuff, the Red Hat Linux, Windows 7 Enterprise. I have all kinds of stuff that I can create. But what I want to create is a SQL server. So I'm just going to type SQL space server, hit enter. And this is going to go out and show me all the different things that I can provision. Now, I can provision a SQL Server, like right here, 2019, running on Windows Server 2022. So this will literally set up a virtual machine that has SQL Server 2019 running on top of Windows Server 2022. So if I create that, I then have access to go in, and it's a full-blown SQL Server, and I can manage everything about it, and there's a Windows involved with it that I can get into, and there's all kinds of stuff that I can access. It's kind of like it's my own server, but it's a virtual machine running in the Microsoft Azure cloud. I don't need something quite that large for this, so I'm just going to provision a logical SQL Server, which is a stripped down version, but it's an Azure SQL Server. So I'm going to come over here and click this guy, SQL Server Logical Server. So I'll hit that. It then takes me to an overview of what this is. It's a cloud service built for application developers to scale on the fly, yada, yada. It's a server that I can scale up and down as I need. Okay. If I look at plans, this is sort of where we talked about the different ways you can use and set up Azure and what your plan is set up. And this is a software plan. It basically gives the same explanation as was on the overview page, but it basically tells you what it is and how you can use it. Depending on the service, there are different plans available. This one is what it is. It's a standard logical server. And then there's some usage information and support and some ratings and reviews. And you can see here I can pick my plan. Well, in this particular case, the SQL Logical Server only has that. So that's all I'm going to pick. And I'll hit Create. Now, this is going to go ahead and ask me all the details about my server. There's not a ton to be done here, but there's a few things you have to look at. One, subscriptions. You can have multiple subscriptions. So you can say, I only have free trial. But you might be in a corporate environment where you have multiple subscriptions. And maybe one is for something you use for your production accounting department. The other one you use for your marketing department, whatever. You can have these different subscriptions. So you can pick the one you want. You then can have resource groups. And again, Microsoft is pretty good about putting these little tags here. So if I hover over it, you can say all your subscriptions. If over this, it's a resource group is a collection of resource groups that share a life cycle or a permission or a policy. So if you don't have a resource group, you can create one. I do. It's called Inside Out. I created it for these lessons, so I'll pick that one. Server details. You'll notice you enter a name, but it'll be .database.windows.net. So whatever you enter, it'll fully qualify to this .database.windows.net. And you can pick the location. Now, you'll see when this comes up, there's a whole bunch of these. And, typically you pick something fairly close to you. But you'll notice if I pick West US 2, it says your subscription does not have access to that. So that's the other thing they've done in the free trial subscriptions. They've limited where you can put these things. So you can't just pick anything. In a real one, you can pick whatever you have access to. I do have access to West US 3, so why not use that? And we'll just call this, and you have to make sure the name isn't taken. So as I type, you'll see over here, my server name shouldn't contain reserved words. I'm good there. It can't contain, your server name can contain only lowercase, so I'm bad there because I put a capital I. So I'll take that down to a lowercase. And now it's thinking, and it says, oh, look, that specified server is available. But I don't necessarily want to name it inside. So maybe I'll do inside_out. And then it yells at me because it can't contain hyphens, and it can only contain lowercase letters and numbers. So again, no underscores. So I'll call it inside out. It'll think, nope, someone's already using inside out. So if I call it inside out server, see what that one comes up with. That name is available. So you'll see the check mark came up green. So we can call this inside out server. Cool. So we'll do that. Down here, you'll see the authentication methods. I can use Azure Active Directory, but I don't have an Azure Active Directory set up. Or I can use both SQL and Azure AD. Okay. But again, I don't have Azure AD set up. So I'm just going to use SQL authentication. Then you enter your server admin login. So I will just call this IOadmin, which happens to be the same thing I set for the password on my other server. No big deal. And I'll set the password to something. Okay. So there we go. So now I'm going to hit next. When I hit next, it asks me to save my password, but I'm not going to do that. This is basically the networking configuration. You can see that there is not a whole lot here because it just says configure access, firewall rules, allow Azure services and resources to access this server. So if I say yes, other Azure services can access this server. I really don't care, so I'm going to go ahead and just say yes to that. And at any time, I can click back to basics, and I kind of go back in my wizard. So that's what that is at the top. I just wanted you to see that because like these 4 tabs sort of disappear as you move forward. It's kind of strange, but you can click back. So anyway, I'll go back to networking. Yes, that's fine. I'll click next, and that'll take me to additional settings. So I can, in this case, I can add Microsoft Defender to my server for SQL. And that's free trial, and if I want to keep it, it's $15 a month. Well, I don't want to say yes because I don't want to accidentally start paying $15 a month, so I'm going to say not now. Next, I can give it a tag, and these are like pairs that allow you to consolidate things. So again, I could have a billing department or a marketing department, and it's for a lot for billing purposes, so I know when my resources are used, who used what. I'm not going to worry about making a tag right now. And then you come to a fairly standard thing in Microsoft Wizards, the summary. So here's everything I picked about the product, the names, the server, and the networking and all that. Okay, so now I'm happy with this, and I can go ahead and hit the Create button. Now, because it's procuring a logical server, this can take a little while. So you'll see up here, it's checking the progress, and a deployment is now in progress. Okay, so I can close this little window here, and I can, in fact, keep jumping around my dashboard and doing things. But you'll see up in this upper right-hand corner under this little bell icon, there's like a little line moving back and forth. That's telling me something is in progress. And what's in progress right now is the deployment of this new server. So down here, you can kind of see, oh, the status was accepted, meaning they took all my details, they've accepted this, they're going to go ahead and create the server and get everything set up, but it takes a little bit of time for this to deploy. You can kind of start to look at some of the different pieces and different settings of this server, like here's your login, your password. You can see outputs. There's no outputs on a logical SQL server. And then you can look at like some templates of things and how things are created. So you have access to some of this stuff, but this server doesn't exist yet. Okay, it still says deployment in progress. So if I go back to my dashboard, and here we go, to my home, you can see under my recents, I have my old server and my SQL Server database. And if I hit See All, you'll come here, and all I see is the server that I already had in the East location and my Inside Out 2022 database. So because it's done, if I go back to my dashboard here, you'll see under my All Resources, I now have my old server, my old database, and this new Inside Out server. So I'm going to click that, and I have this new server, insideout.database.windows.net. It has this IO admin password, and if I click this little handy dandy copy to clipboard thing that only appears when you hover to the right of the name, it copies the name of that server to the clipboard. And then back in Management Studio, if I hit connect and I paste in this new server name and I type in my password, I'll check remember password and hit connect, it's going to pop up and yell at me. And basically what it's doing is it's telling me that my client IP does not have access to this server. So remember, this is set up on in the cloud, the magical cloud. So it's on the internet. Okay, so because of that, anyone on the internet can get to this server, presumably. So there's firewalls that are put up on the Azure side, and you can set firewall rules for who is allowed to get to this server and who is not. So if we flip back over to the Azure portal, from here, I can set up some rules to allow access to this server, okay? So I'm going to go ahead and click the Show Network Settings link right here in the upper right of my server. This is going to take me to the Access page, and you'll see here I have public network access. You can either disable it or set it to selected networks. And you can set up a whole virtual network, and you can do all kinds of stuff. But right down here under firewall rules, you can allow certain public IP addresses to connect. To make your life a little bit easier, Microsoft has given you a little click button here that says you can add your client IP address. So if I click this, essentially it creates a new firewall rule with the IP address I'm currently connected from. So it knows my IP because that's how websites work. They know where you're coming from. And I can click this and then I can click save. And what that'll do is that'll put a firewall rule in place that allows me to connect to my server. So now if I go back to my Management Studio, I'm going to cancel this firewall rule. By the way, this here basically was saying if I had the right account saved in my Management Studio, I could have logged in to the Azure portal right here and it would have added this firewall rule down here. But this firewall rule is essentially what I just added. So it basically does the same thing. We just did it through the portal instead of through here. So I'm just going to hit cancel and then hit connect again. And this time you'll notice I connected because now I have access through the firewall. And when I connect to my Inside Out server, you'll see it's here. It exists. It does not have any databases, or should not. There you go. It does have the one login, which is the one we just connected with. And that's basically it. I provisioned a logical server. So from here, you can start adding databases and you can start working with this as though it were a local database to some extent. So remember, when you're working with Azure, you're just working with servers and databases and data that's stored on Microsoft servers in their data centers, and you're just accessing it via the internet. And in this lesson, we provisioned a logical SQL server, and we looked at how to open up that firewall so we can talk to it. Now, if you want to start working with this and make it useful, you're going to need some databases, and there's another lesson on how to add those. But once you get these going, you have a great resource for on-demand servers and databases that can be expanded and made faster as your demand needs. In order to start fully utilizing the SQL Azure cloud, you need to set up some databases so you can actually start storing things up there on your servers. Now, these databases are going to look and feel and act a lot like local databases, but obviously they're provisioned on the logical servers up there. So we're going to take a look at how to provision a database. Now, there's a few ways you can do this. You can do it through Management Studio, but you can do it through the Azure portal, which I prefer because you have the full set of options. So we're going to flip to the Azure portal. So here I'm connected to my Azure portal, portal.azure.com. You can log into your account. And you can see under my All Resources here, everything that I have provisioned at this point. I have two servers. I have an Inside Out server and a SQL Server Inside Out server. This Inside Out server was provisioned without any databases on it. And since this topic is about provisioning databases, we're going to provision some right here. So you can see over here, there's some quick starts and some tutorials. So I can click SQL Database right here, which will take me to setting up a database as a service. Or I could click Create a Resource. Or I could go to this and go to my SQL Databases. There's 100 ways to skin this cat, but I'm just going to go to the SQL Databases list, which shows me my existing database. And then I'm going to go ahead and click Create to add another one. So this will come up, and it looks a lot like provisioning a server. It wants to know what you're going to provision this on. This one starts giving me a cost estimate. Logical SQL Server provisioning doesn't do this because you're just provisioning the server. What they charge you for is DTU, which is like data units. It's how much data you're moving in and out of here. And essentially through this process, you're able to sort of estimate your cost per year based on how much you're going to move around this server. So you'll see right now, with the standard usage, it's saying it's going to cost me $14.72 a month. And with your free trial, you get $200. So this would take a while for me to use that up. But we'll talk more about that in just a second. So to provision this server, the first thing I have to do is pick my subscription and my resource group. Free trial and my Inside Out group is fine. Then I have to give it a name. So I'm going to call this database New Inside Out Azure DB. No, we'll just call it Azure. Don't need to have DB at the end. Okay. And that's the name of my database. You'll notice on the right, it checks all the boxes, meaning it doesn't have special patterns. It's less than 128 characters, no reserve words, blah, blah, blah. I've used a valid name. That's what you want to see there. Then you want to pick your server. So I have two. I have SQL Server Inside Out, which is in the east, and I have this Inside Out server, which is set up on the west. I'll pick the west one. You could also right now hit create new, basically go off and provision a whole new server, and then come back and finish provisioning your database. Now down here is the compute plus storage. So if you hover over the little info, it'll tell you to choose a service tier that fits your need. So this is standard, which is 10 DTUs and 250 gigabytes of storage. I'm going to click Configure Database, and that's going to bring up this little service and compute tier configuration dialog. Okay? And what this basically says, I can start with a service tier to pick the kind of data rates and storage I think I'm going to need. Or I can start sort of dragging things around on the screen to get an idea. So the default is standard, which is for workloads with typical performance requirements. You can pick basic for less demanding. You'll notice some of these are grayed out. Some of these aren't available as part of your free trial subscription. But as you choose these different things, you can sort of see what happens with the cost. So right now it's $14.72 per month. Let's pick this general purpose scalable computing. So all of a sudden, when I did that, I can start to select a whole bunch of other things. Is it provisioned resources that are pre-allocated and they're based on the number of cores? Or is it resources that are auto-scaled and based on, it's per second and based on cores used. So that's sort of like it can change a lot, and then it's basing it still on the cores used. And so you can see this breaks it down for you. How many gigs? What's your max storage? Here's your estimated storage cost. Here's your estimated compute cost. All sort of rolled up for you over here. So you saw when I was provisioned, and I'm basically saying I want this pre-allocated, not auto-scaled, and it's billed per hour. All of a sudden, this was going to cost me $327 a month to run this server. So it can get expensive, but depending on what you're doing, if you compare this to the cost of $100,000 of licensing and more in hardware, that seems kind of reasonable, right? So it all depends on what you're going to do and how long you're going to use it. So I want to flip this back just to standard for now. And I want to look down here at the DTUs. So as I drag this up to say I'm going to use more data, you'll see at some point it yells at me because I'm on a free trial and I'm limited to 50. So I can start to play with these. And if I was on a full trial, I could see what it would cost me to get a lot of data transfer, and my max size of, say, 250, I can get this all up to $73 a month. So you can start to play with this, and then depending on your subscription, you can set different configuration options and get it to a price point where you feel like it'll work with you. If I go to this general purpose and I come down here, you'll see I can also scale based on cores, right? So for standard, I can go up to 80 cores, and I can go up to 415 gig of memory. So I could take this cores way up. I'm sure it'll yell at me at some point, yep, because I'm on a free trial. So it can only provision basic through these other standards. So I can't even start doing some of this stuff because I'm on a free trial. But in general, you can come in here and you can start to manipulate these values and get an idea what it's going to cost you to run these servers, okay? So we're just going to stick with, I'm actually going to do basic for less demanding workloads. And again, this is estimated. What your actual cost will be dependent on how much data you literally start pushing back and forth. So I'm going to do that, hit apply, and that's fine. I'm making a basic 2 gig storage database, pretty small. You then have some redundancy options. So you can choose how your backup storage redundancy is. Is it locally redundant, zone redundant, or geo redundant? So that kind of depends on where they replicate your data and how things work. And you're able to kind of configure that on a per database level, changes the services, changes your costs, all that good stuff. So here we go. I'm a basic database. It's going to cost me $4.90 a month, assuming I use it. I can click review and create, or I can click networking. So if I go to networking, I can do some more. So here I can say, can other Azure services add this? Do I want to add my IP to the firewall? Which, sure. Do I want any private endpoints? So do I want set up virtual network endpoints between this and another Azure service or another Azure network? All this stuff's configurable. And if you click next, you can configure more and more and more until you're ready to create the thing. So I'll just click next, and here's security. You can get Microsoft Defender. That's $15 a month. Do you want to configure tamper-proof ledger stuff? And there's all kinds of this stuff. I'm not going to configure any of these. I just kind of want you to see what's available here. Additional settings, do I want to start with a blank database? Do I want to use an existing backup? Do I want to start with a sample database? And in which case I'll get AdventureWorks. And it even says it'll modify the compute storage settings for backup compatibility. So that's what this is reminding me of, because now I'm going to have some data, so it's going to have to change something. So that's fine. I'll say okay. Correlation, I'm fine with Latin general. Next, you can set up tags. Again, these are things you can set up to sort of name this database so that I know it's a marketing database or an accounting database or whatever. It helps with your billing. And then finally, I can just skip right ahead to review and create. And then here you go. You get your summary. It's going to create this database on this subscription in this resource group on this server. And it's a basic 2 gigger and it's geo-redundant and all the other things we selected. So I'll click create and off goes Azure, and it should go through the deployment process similar to how it went through a process when you deployed a logical server. So now my deployment is in progress, and this little bar will just run around by this little notification icon. And it shouldn't take as long as provisioning a server because this is just putting a database on an existing server. And you can see here now that my resources, my inside-out server was okay. It has accepted this new database, and deployment is in progress. So this will just take a minute, and we will have a new database that we can go look at. There we go. So the deployment is now complete. And you can see I get this big deployment complete tab, and there's next steps, and which is basically go to the resource. But now I can start using this thing. So if I click go to resource, it takes me to that database. And then I can see all the different properties and options of this new Azure database we created. We're going to flip back over to Management Studio, though, and just take a look. So here's our inside-out server. And if I right-click databases and hit refresh, I should now see our newly deployed database, and there it is. And because, remember, we set this up as a sample database, if I look inside this and expand tables, I should have the tables that are part of that AdventureWorks database. So I've sort of put sample data in here. There you go, there they are, to give me sort of a starting point. And this was more to play with. I probably would never put sample data in here if I was creating this for real. But now I can see some data, and I can start manipulating this data. I can pull it down, I can read it, I can write it, I can do all kinds of good stuff. So that is how you provision a database on Azure. And the important thing to remember here is just because I'm provisioning a database, there is still a server that goes with it. So anytime you provision a database, there's a logical SQL Server that it's stored on. Or if you did the full-blown SQL Server install on a Windows machine, you could also have that out in the Azure cloud, to where now you have a full SQL Server that you have full control over, where you can deploy databases. But if you're going to stick to the logical stuff and stick to the basics of Azure, this is how you get a logical database deployed onto one of your logical SQL servers. So in working with Azure databases, you have a couple different levels where you can set security. It's not quite as full-featured as setting up security on a local instance, but it does give you a whole lot of area where you can control who has access to what and who even has access to see your SQL Server to begin with. So the first thing I want to look at is in our Azure portal. I'm going to show you the server that I have set up here. I have a server here called Inside Out Server, and this was provisioned in the Provisioning the SQL Server lesson if you want to check that out. And I'm going to click into it, and from here you can see the full name of the server. So I'm going to copy that, and when I created it with an admin account and an admin password. That's what happens when you make a server. So I'm going to flip over to my Management Studio running on my local machine and connect to this database. And I'll just type in the username and the password and make sure I have the right one, paste that from the copy of the last screen, and I can hit remember my password and I can hit connect. The first thing you're going to run into is this. Step 1 of Azure security is firewall. It won't let you talk to the server if you don't have a firewall rule configured. We looked at this in the lesson when we provisioned a server, but I want to rehash it a little bit here because it's the first step in all security to Azure. So I'm going to cancel this little dialog and flip back over to my portal. And here you'll see there's a network settings selection. So I'm going to click that. And I can either disable public networks, which means nobody can get to it, or I can do select networks and create a firewall rule. You'll see I also have private access up here that I can set up, and these are more virtual endpoints that you can create within the Azure cloud. We're not going to worry about that right now. I'm just going to go to public and give this thing access to the internet so people can get to it. So I'll say selected networks, and if I click add your client address, you'll see I get a rule that's adding just my client IP. Now I might be fine with that, or I might need to add an entire range, say an entire office worth of IPs, in which case I could set this at a start IP and this at an end IP and give all IPs in that range access. I'll leave it alone. This is fine for me to just go ahead and add my client address, and I can hit save. Alternatively, if it's not my client, I can just hit add a rule, and you'll see I get a blank add firewall rule dialog where I could give the thing a name and a start and an end IP, because I'm not going to always be adding it for my subnet. I can probably set up other subnets in my office and other offices around the world, and so I need to set up probably several rules ultimately to provide access to this server. Now, that's hole number one. I'm now through the firewall. So if I flip back over to Management Studio, I can then proceed with the next level of security, which is your login. It had you create an admin login and password when you provisioned the server in Azure. So I typed that here, and now with a hole in the firewall and the correct username and password, I should connect to the Azure database. Now, from here, you'll see the security folder does exist similar to a security folder at the SQL Server level on a local instance, but when I expand it, all I see are logins, and I don't have any of this other stuff. I don't have server roles, credentials, none of that. Because remember, with a logical SQL Server on Azure, I haven't provisioned a full-blown SQL Server. I've provisioned a logical server. So while somewhere there is a SQL Server hosting this database, I don't have access to the whole thing. I have access to who's allowed to talk to my little virtual server, which is this inside-out server. So I can create logins that get access to my local server and therefore my databases. But if I right click, you'll see there's no properties. All I can do is say new login or script this login. I don't have everything I would on my local server. So if I click on my login here and look at properties, I can give it access to different things on the server. I can give it access to different databases. I can do all this stuff. That doesn't happen with Azure. All I can do is set a login that has access to Azure and to my fake little server, my little logical server. So if I right click and say new login, rather than getting a dialog like I do for a local one, I get this template that pops up. And it basically gives you some information in the top and the bottom about what this is and what you're trying to do. But essentially what this gives you is a script for create a login. And then it gives you sort of a breakdown of what each of the pieces it needs are. So we'll just delete these comments, just focus on the code itself here. There we go. Whoops. Gone. And what we're going to do is we're going to create a login. And we'll just call this login, and everything between these greater than, less than, these brackets is telling you what this is. It needs a SQL login name. The type is sysname, right? And it's basically your login name. So we're going to call it, let's see, IO user. So we already had an inside-out admin. Let's make an inside-out user with password, and then I have to give it a password. So we'll call it PA $WRD. No one will guess that. We'll call it password. I can't do anything else. I can't say with security permissions, or I can't say with ability to add databases. I can't do any of that. I can just create a login with a password. So I'll hit execute. It goes off and it says command complete successfully. And if I right click and refresh, you will see I now have an IO user. Again, I can't do anything with him, but this user can now log on to Azure. He has no permissions, presumably on the server, but neither does admin really, if you think about it. It's just a log on onto this Azure server. So what's that good for? I can then give these guys access into the databases. So on this particular server, I only have this one database called New Inside Out Azure database, okay? If I had multiple databases, there are two levels of security in SQL. And there are two levels of security in Azure. There's logins, which get you access to the server, and there's users, which get you access to the databases. So if I have multiple databases, I only need one login. I can log into the server once, but then I can get permissions into each of these databases. So now that I've created these, I can expand my database here. And you'll see down here I have a security folder. It looks a lot like the security folder I would have in a local database. And I have users. And when I expand users, you'll see I have DBO, which is the only one available, and guest, information schema, and sys. If I zoom in on that, you'll see have little X's because those accounts aren't enabled. So if I want to give access, I can right click and I can hit new user. And again, it drops me to a script. So Azure doesn't have a lot of dialogues that pop up. You kind of have to do everything through scripts, okay? So what I'm going to do is I'm going to create a user. This is the username, and I'll call him IO user, okay? And I will create this from the IO user login. So I'm going to have the same username, same login name. So there we go. I'm creating a user in my database called IO user for the login IO user. And I can have with default schema, I'll use DBO. So DBO is the default value. That's fine because that's the schema in the database that's already there. And then down here, optionally, this just gives you more syntax. I can add this user to a certain role. So the default it shows you is to add that user to the DB owner group. I may or may not want to do that, but the user I want to add, we do have IO user, but the role, probably not that one. And if you expand roles, you'll see I have database roles, application roles. These are, again, similar, if not the same, as what you would have in a standard local database. So rather than adding him to DB owner, I want to add him to DB data reader, which is a group that will allow him to read data. And I want to copy that line, paste it, and also add him to DB data writer. Okay, so I'm going to create the user for this particular login, and I'm going to put him in these two roles, data reader, data writer, and we just click execute, and it fires off and command completed successfully. So now if I right click and refresh my users folder, you'll see I have a IO user who is now in this database. So that is like the third hurdle. So you had to get through the firewall, which we set up for this IP. You had to get onto the server, which you did by having a login, this IO user login. And then you had to be able to get into a database, which we did by creating this IO user user. So the hierarchy of how SQL Server uses logins and users is also explained in our lesson on SQL Server security, where we'll talk about server level security and database level security. But those same concepts apply up to Azure. The big difference is with Azure, because I don't have a full-blown server, I don't get any of the server permissions. I get only logins. And then from there, I can put users in my databases where now I do have access to sort of everything that I would have in a database. I now get the different roles. I can set up whether they're allowed to read tables, whether they're allowed to create objects or tables or procedures or views in that database. And that's all done through SSMS. Now, if I flip back over to the portal here, you'll see back in my dashboard for these particular servers and databases, I don't necessarily know anything about the inside of that database. So here's that database we were just working with. And if I click on this, it tells me the server name. I can show the connection string for that database. I can see the trial level, and you can kind of see, how much compute utilization I've used, how much disk space I've used of what I've allocated. But I don't see anything in here about the internals of the database. I don't know what tables are there. I don't know what users have access. And that's because, remember, on your Azure portal, you create a database. It's an object. It's a thing that exists on a server. What goes in that database is all managed through SQL Server Management Studio. So you'll do that down locally on your machine. So if you take the 3 lessons that we've done in this whole course and look at provisioning, logical servers, provisioning databases, and securing Azure, you should have no problem setting up some connections and starting to utilize Azure systems and Azure databases in your day-to-day design and development. Securing SQL Server and data is absolutely critical. Let's look at how to implement and manage user security and permissions in SQL Server. Then, let's tackle how to secure the server itself as well as the data through encryption and data masking. Welcome to our lesson on implementing and managing SQL Server user security and permissions. This lesson covers the basics of SQL Server security. Security is important for many reasons. You could have your system attacked and data be compromised. You could have a user with too many permissions accidentally delete or overwrite important data. And these days, a company-wide SOX audit will go over your SQL servers with a microscope. No matter the reason, security in SQL Server is just as important as security in all your other systems. This lesson covers understanding logins and users, setting up permissions in SQL Server, and how to migrate SQL Server logins and permissions between servers. Let's get started. So one of the first things you have to do to secure a SQL Server is properly set up your logins and your users. Now, in SQL Server, those two terms aren't interchangeable. I know in a lot of systems, you'll say user account or login account or whatever the case may be. In SQL, they're both very distinct and different things. So we're going to take a look at both logins and users and help you understand what they are and how they work together. So here, I have our Inside Out 2 SQL instance running, and on there I have an HR database. Now, logins operate at the SQL Server level. So someone with a login is able to access your server. Someone with a user account is able to access a database, and you have to have a login to get into the server in order for your user account to allow you into the database. So typically they're the same names, but they don't have to be, and you can have one without the other and vice versa. So we'll go through them all here real quick. So under the security folder, under my server, one of the folders you'll see is called logins. And if I click this, you can see all the logins that already exist on this server. Typically, there's an SA account enabled or disabled depending on your security level. If you're using SQL authentication, it's enabled. And then you'll have the account you use to set up the SQL Server, and there'll be some other various service accounts that are needed to run the system. These are all created when you first set up your system. But we're going to create a few more. So first step, because I don't want to do this with Windows accounts because it's just a little bulkier, I'm going to enable SQL Server authentication on this server. To do that, you right-click the server, select Properties, and under the Security page, I can change this Security Authentication mode to SQL and Windows Authentication. So I'll still have both Windows and SQL Authentication, but this will allow me to create some local accounts, which is just a little easier when trying to demo logins versus users. So I'll hit OK, and this is going to pop up and say this will not take effect until your SQL Server is restarted. Very important, when this says your SQL Server is restarted, it means the instance of SQL, not the entire machine. So to do that, I can just right-click on my server here, and I can come down and select Restart. So that'll go ahead and it'll warn me, but I'll say yes to that, and essentially what it'll do is it'll stop the SQL Server service, and it'll restart that service right after. So now, when I click into my security folder and look at logins, you should see that the SA account is still disabled, but I should be able to enable it now because I have now changed to SQL authentication. So now I can enable it, I can hit OK, and it allows me to do that because SQL authentication is enabled. So now the SA account works, which is a built-in SQL Server login. So let's get started by creating a brand new login. So on this system, you'll see I have a database called HR. So we're going to create some logins that sort of revolve around that sort of mentality. Think about an HR database. So I'll just right-click and select New Login. And I'm going to call this HR Admin. So this is the login for our HR Admin. Is it Windows Authentication or SQL? We're going to use SQL. If you use Windows Authentication, you would map this to a Windows account. So this would actually have to be a Windows login name. But we're going to use SQL because I can do a little song and dance if I use SQL logins a little easier than with Windows. So I have to give it a password. So I'll just set the password here to password. Obviously, I don't recommend that in the real world. This is just for a demo. And then down here, you'll see I can enforce password policy, expiration, and stuff. If I enforce policy, it's not going to take the password. So I'm going to turn that off. Now, not a best practice. Typically, if you're using SQL authentication, you do want to conform to policy and you want to do some stuff around changing at the next login and stuff if you're sending accounts off to other people. But again, for the purposes of this demo, I'm going to turn this off. Okay. And again, Windows authentication in a production environment is preferable to SQL authentication. Now, there's a bunch of other stuff you can do here. There's server roles, and there's user mapping, and there's securables. That's all going to get covered in a different lesson about managing server-level security. So you can refer to that if you want to look deeper into this particular aspect. Right now, we're just sort of discussing what a login is and how it works with a user account. So that's it. I'm going to go ahead and hit OK. And now I have this HR admin login. What could he do? Well, let's find out. I'm going to go ahead and hit connect and database engine. And what I'm going to do is I'm going to just connect back to the SQL Server, the same one, this inside out too. But I'm going to use SQL authentication. And I'll just type HR admin, password, and I'll hit connect. And you'll see it allowed me to connect to the SQL Server. But if I expand databases, HR, it tells me the HR database isn't accessible. So I can see that it's there, but I can't see what's in it. And if I look at system databases, I can see those because I need permissions into these in order to even log on to the system. So what's happened now is because I have a login called HR admin, he basically can get into any database that has public access. Okay. And we'll talk about security inside databases in a lesson about securing databases. So you can check that for some of these other concepts. But because I haven't given him access any further, this is all he can do. And he basically gets the bare minimum rights on a server. So he can't really start looking at a whole lot. He can see his own admin login. He can see the SA admin account. He can't see anything else. So he's pretty much locked down and limited to what he can do. So that's what a login gives you, is access to the server. And he has very few permissions on this server. But now, if I want him to further have rights into a database, because I probably don't want to give everybody lots of rights on my server, but I could give them rights into a database, you need to create what's called a user account. So if you look under my HR database, and I'm going to go back up to this connection here where I'm connected as myself, which is the admin account, so I can do things. I'm going to expand this HR database. And there's a security folder here as well. And if I expand that, you'll see there's a users folder. And in here, these are all the users who have access into my database. Now you'll notice my account does not have access into this database. You don't see me listed here. But what ends up happening, because I'm an admin at the server level, I get mapped into this DBO account. DBO is the database owner. So I'm in here because I'm sort of mimicking this DBO user. But let's create a user to allow our HR admin into our system. So I'll just right click and I'll hit new user. And you'll see here I have some options of what kind of user I wish to create. So I can make a SQL user with a login, which is what we're going to do. But I can also make a user without a login. So I can have a user in this database that does not have a login on the server. And there's different reasons why you do that. And we'll talk about that in the lesson on securing databases. You can also map to certificates, to asymmetric keys, or directly to Windows users. So what we're going to do is create a SQL user that does have a login. So it's from one of our logins on the server. So we'll select this first option. Here, we pick that username. So if I know it, I can type it in. If you don't, you can go browse and find it, but I'm going to go ahead and add it because it's just simple. It's HR admin. Okay. I'm sorry. This is the username. So I'm going to make it HR admin because I want it to match. And then the login name is also HR admin. And you can click this little ellipses here and browse out to find it. So I could do a little search and hit HR, and then it'll find, here you go, HR admin. Then I can check it, hit OK, and it brings it in. So I want the login name and the username to be the same. Again, they do not have to be. I could have an HR admin username, and in this database, it could be called something completely different. But it maps this login to this user. Now, finally, the default schema. This is kind of a next level sort of thing as far as security. Databases can have schemas, and those schemas can then have tables, and then you can divide your database up. So the sample databases in SQL Server Worldwide Importers, for example, has a sales schema. All databases have a schema that sort of belongs to each user. So there's always one called DBO. So I'm going to make it DBO for now. That's just the easiest thing. And there's more information on this and schemas in some other lessons. So that's it for now. That's what I'm going to do is create a login tied to this new user, and I'll hit OK. So now my HR admin login is mapped to this HR admin user, and this person should now have access deeper into the system. So if I right-click and refresh my database, the little plus symbol comes back, and now I can expand it, and you'll see my HR admin can now see a little more into this database. Now, what it's seeing, so if I hit tables, there are no tables because I have not created any, but what its access is basically mapped to is anything that public can get to. And that's a whole other security conversation, but I'll show you a couple quick little things here. So let me come back up to my admin account and go back to my user, HR admin. So you'll see here, if I click membership, he's not in anything. Okay, so he can't really do anything in this database. So if I were to create a table called, I don't know, we'll just make an ID, that's an int, that's fine. And I'll save this table, and we'll just call this table payroll. Obviously, there's not a whole lot in here, but that's fine. So I'll create this payroll table. So it now exists in this system. I'll refresh. There it is. My HR guy, if I refresh, doesn't see that table because he has no rights into it. So he can't see anything that's going on. So I would have to give him further permissions in order to get into this table, which again is covered in the lesson on database security. So for now, the takeaway I want you to have from this lesson is how to create logins and then how to map those logins to user accounts. And there's a couple of lessons. We're going to talk through securing SQL Server, securing databases, and ultimately how to migrate logins around. And so that will kind of bring this discussion full circle. So the takeaway from this one is how to create logins to give access to the server level, and then how to map those logins down to users to provide access into the databases. So in this lesson, we're going to look at how you can secure your SQL Server and what permissions you can set up both at a server level and a database level. So we're going to be talking through logins and users, which we cover in another lesson if you want to go check that out. But in this lesson, we're going to talk about actually providing permissions to do things at both a server and a database level. So over here on my SQL instance, I have a couple of databases set up, an HR database, the Worldwide Importers demo database that you can get from Microsoft. And this server has a couple of logins. It has an HR admin login, an SA login, and we're going to create a couple others just to sort of keep things moving along and show you how some of these permissions work. So we're going to start by making a new login. And I'll just create one as a SQL login called payroll admin. Okay. And so I'll do SQL authentication just for the sake of demo, but this could also just as easily be a Windows login and all the same stuff we're going to show as far as security would work. All right, so I'll click OK, and that'll create the login. Now, I want to just go right back into that. It's a similar dialog to look at the properties, and I could have done this at the time I created it, but I just wanted to get the account created. So the first thing you're going to start to secure in SQL is everything at a server level. So a server hosts and manages all the databases underneath it. And therefore, there's lots of things you can do at just a server level without even touching a database. And a lot of that stuff is controlled through some of this server level security, through roles and through securables. So let's first start by looking at roles. So you'll see a bunch of internal stuff that you can kind of ignore here. But in general, what you'll see down here are roles that the server has that are sort of pre-set up groups of permissions that can do things on your SQL Server. Now, all of these are documented in Microsoft's documentation. So if you hit this help button, it'll take you out to the web and it'll tell you what each one of these groups does. But I'll give you sort of a high-level overview. So you'll notice by default, this login I created is in the public account. So there's certain things that public has access to. Stuff like reading into the master database so that they can actually log in, because without being able to connect to certain pieces, you can't even log into the server. So public kind of gives the bare minimum that's required to log in. And beyond that, they really can't see or do much on the server if they're just in public. Then you have some other groups: bulk admin, DB creator, disk admin. A lot of these do sort of what their name implies. So DB creators can make databases, disk admin can mess with your files, security admin can create logins, setup admin can do setup tasks, and so on and so forth. But you have server admin, which is sort of I can administer the server, but I can't really do much else below it. And then you have sysadmin, which is sort of your super user account. So sysadmin can do pretty much everything and also has access into all your databases and becomes mapped to the database owner of all databases. So sysadmin is by far the most permissions. It'll let you do literally everything on this server. So what I'm going to do is I'm going to make the payroll admin just stay in public for now. But the HR admin here, go back to them, I'm going to give them access to security admin. Okay, so that means the HR admin should theoretically be able to create other employee accounts on the system. And I'll demonstrate this very quickly by just connecting to a database engine using my HR admin account. And we'll connect to the same exact server. And it pops up down here. And so my HR admin, if I expand security and look at logins, can see all my logins. And as HR admin, if I right click here and say new login, I can create a new login. So I'll just call it employee 1, SQL authentication, and I'll enter a password. So essentially, as HR admin, I'm able to do security admin. Nobody else would be able to do that except my system administrator account, and my payroll admin still doesn't have any rights. So that's the first way you can assign permissions at the server level. You can use these server roles. Now, the other way is by giving them direct access to securables. So let's look at payroll admin again, because this guy doesn't have any permissions. Go to properties, and you'll see there's a securables tab. Okay, and down here are all the individual permissions that I can set on the SQL Server. Okay, and I'm just going to move this over so you can see all these columns. We have a grant option, and I'll explain these in just one second, a with grant option, and a deny option. So you'll notice the only thing this guy has right now is he can connect to SQL Server. And it tells you who granted him this right. The system admin account granted him this right. So SA is it's like the God-like account on SQL Server. It can do everything. It is the super admin. He has connect to SQL permissions. That's sort of part of him being in this public group. And if you look over here at effective permissions, it gives you basically a list of everything that they can do. So you can see he can connect and he can view any database. And these are the explicit permissions. And you'll see as I scroll down, view any database isn't here. It's not really something that you can assign at the server level, but it shows up as part of his effective permission set. Now, if I want to give him access to do something like manage security, I can put him in the security group. But if I need to be more granular for whatever reason, so if I want to say, view any database and view any definition and view, I could start checking these things off one at a time until I have all the permissions that he needs. It's not the most efficient way to do things, but you are able to come in here and do that. So for example, if I wanted him to have security-like roles, like we gave to the HR admin through the group, you would have to come in here and say that they can, let's see, alter logins. I guess alter login would be about the only one. But anyway, you're picking these little onesie-twosie things. So it's not the best way to go, but I wanted you to know that this is in here and you can do it. Now, something that's interesting is with any one of these permissions, you notice with the groups, I could put you in a group or I could not, a role, right? That's it. With a securable directly, with any sort of, and this is going to apply to database level as well when we get there, you can do one of three things with all these permissions. You can grant a permission, You can grant with grant, which I'll explain what that means in a second, or you can deny a permission. So essentially, you'll see his effective login permissions are connect and view any database. That's effectively what he gets. However, if I come down here to view any database, which you'll see doesn't have a setting here, he's getting this kind of from being a member of public, and I click deny, what this effectively does, deny overrides anything up the chain. So with deny, you're saying, I don't care what permissions he has, take away view any database. So it's the most restrictive thing. So if I put that in here and hit OK, and then we'll come back in and look at him, back to his securables, back to effective, you'll see he no longer has view any database. That's gone. And deny is so restrictive that if I were to put him in, say, the sysadmin role and hit OK, and then come back in and look, you'll notice here under securables, his effective permissions are pretty much do anything to the whole database. But if I look, you'll see connect any databases here. So you'll see here he can still connect, but he can't view any database anymore because I denied that permission. Now, even if I were to put him in a role such as database creator or disk admin and hit OK, when I come back in and look at his permissions, those roles have given him additional things that he can do. So if I go to securables and look at his effective permission, you can see I can alter resources, I can connect to SQL, and I can create any database, but I still can't view any database, which would be fairly important for the database creator. So this deny completely blocks it. So if you have somebody who has access and you need to, for whatever reason, deny them a permission such as connection or doing something, you can do that with this deny option. Now, there's also this grant and then with grant option. So what this permission is doing, and again, this will apply to the database level as well, is I am giving them that permission to, so for example, let's just say, pick one here, shut down. Let's say I'm giving this person rights to shut down the server. I can grant them that permission and I can hit OK. And they now have rights to shut down the server. If I also give them the with grant option, what that means is they can shut down the server and they can also then provide that right to somebody else. So now payroll admin would become someone that could be a grantor, and they could actually go in and provide someone else the permission to shut down the server. So grant means they can do it. With grant means they can also provide others the ability to do that same thing. Okay, so those are the three sort of ways we can assign things: grant, with grant, and then deny to completely block it. So at a server level, that's basically it. You can do these things. You can be in these roles here, and that's essentially all you can do at a server level. Now, when we go to the database level, it's a little more granular because we're now dealing with tables and views and executables and all kinds of stuff. So we're going to jump down to that level now. So what I'm going to do is I'm going to give payroll admin here a user account in our database. Now there's two ways to do this. One, I could go to the database and say make a new user and map it to this login and give it a name and go through all that. Or two, at the server level on the login itself, there's a user mapping page. And if I click this, I can just select which databases I want this login to have access to, and it'll create them a user account. So I'm going to give them access to HR and worldwide importers, and you'll see when I do that, it automatically populates the username to match my login name, and I'm perfectly okay with that. And then down here, I could put it into some different roles if I wanted to right now, and you'll see it does get public by default, and I cannot uncheck that. So anytime a user is set up in a database, it's part of public, so it will get to do or see whatever permissions you grant to public. So I'm not going to change this for now. I'm going to leave it alone, but I'm just going to hit OK. And that will essentially make the payroll admin a user in both my HR database and that worldwide importers sample database. So let's go in to worldwide importers. And in here, under security users, you'll see there's my payroll admin. I also want my HR admin to have access to this. So I'm going to do that one the other way. Right click, new user. And I'm going to find the login I want, which is HR. Hit OK. There it is, HR admin. And I want the username and password to be the same thing. And it's a SQL user with a login. So this maps straight across. I'll just hit OK. All right, so now both my users are here. Down here, I'm connected to this server as HR admin. So if I come down here, you'll see I can see both these databases. That's fine. I can expand worldwide importers, and I can see kind of a layout. This is part of being a part of public. And if I expand tables, you'll see I see nothing. And that's because HR admin does not have any rights inside this database other than public at the moment. So we're going to fix that. So back up under my admin account here, I will expand users. I will right-click my HR admin and hit properties. And similar to the server level, I have, it's called membership, but these are still database roles, okay? And this is similar to the server level. Now at the server level, I had a bunch of built-in ones. In this database, there's some user-created roles, which we'll talk about here in just a second. And now I can put HR admin into any of these roles, and they give them permissions to do things. So access admin can control security, backup operator can back up. Some of the ones you might use a little bit are DB data reader and DB data writer. And those do just what they say they do. They allow you to read and they allow you to write. You can also use one of these deny accounts. So if I want to make sure that a user does not have any read or write access, I can put them in DB deny data reader or deny data writer, which means it doesn't matter where else they got the permission to read or write, they would be blocked that permission if I put them in there. You can also put them in DB owner, security admin. I mean, those are the built-in roles, and they give you different functions in the system. You can then create your own roles, like sales, external sales, far west sales. So they have all these sales groups, and these sales groups have different access to different pieces of the database. For now, I'm going to put HR admin into DB data reader and DB data writer, which essentially says they could read and write from all the tables in my database. And I'll hit OK. So now when I come down here, if I refresh my tables view under my HR admin account, I should get them all, and there they are, because I have rights to read all the tables. Okay. I also have rights to write. So if I right-click and do a new query, I could write into a table. So for example, I could select star into orders copy from sales.orders. And actually, I want to put it in the same schema, so I'll put sales in front of it. I'll execute that. And you see, create table permission is denied. So I have the right to write data, sorry, it's write with an R and write with a W, to a table. I can write data. But I don't have any rights to create tables. So trying to copy into another table blocks me. So if I want them to be able to do that, I have to give them create table permissions. Now, again, there's a couple different ways you can tackle that. I can right-click HR admin, and I could put them in a group up here that has table creation permissions, and that would be DDL admin. So DDL is data definition language. So that would allow them to create tables. But DDL admin allows them to create anything, tables, views, stored procedures. So if I want to be granular and only give them the right to make tables, I can do that through securables. And securables at a database level are very similar to securables at a server level. There's just more of them. So instead of showing them all here, you actually have to go find the ones you want. So I'm going to hit search, and what objects do I wish to add? I can add specific objects, all objects of a type, all objects belonging to a schema. So if I could say all objects of the types, and then you can see, look at all these objects I can pick. Tables, symmetric keys, database roles, stored procedures. And this lets you sort of filter it down to pick the thing you're looking for because there's just so many permissions and securables. So I'll pick tables and hit OK. And then you'll see here, I can give them permissions to do things on every single table in the database. So if I wanted them to read or write from specific tables, I could do that. I could also let them alter the table, delete the table data, insert, select, take ownership, update. I can do all this stuff, view the definition, same kind of permissions as we saw at the server level, grant, with grant, and deny. So what about databases? So if I pick databases and hit OK, you'll see here I have the Worldwide Importers database. There I can click, and now I can give you permissions to do things to the database. And you'll see I have alter any, there's alter stuff, alter full text catalogs, alter schemas, alter whatever. And if I keep scrolling down, you'll see my create functions. So I can create functions, I can create procedures, I can create roles, I can create schemas. And right here, I can select create table. So at a database level, I can give you the permission to create a table. So I'm just going to go ahead and click grant on that particular feature, that particular permission, and hit OK. Now the HR admin who is running this query should have the ability to create tables, and I should be able to execute this query. There's also schema permissions. So I didn't talk about that. By default, each user is in a schema, okay? And if you look at HR admin, they own no schemas, but if you go to general, you'll see their default schema is DBO. So if I were to attempt to create this table in that schema in DBO, I could do it. But I can't create it in sales because that's yet another permission. So we'll go back to HR admin one more time. We will search here for all objects of a specific type. Okay. We will scroll down to schema right here. Whoops, there we are. And I'll hit OK. And you'll notice it loads up all the schemas in my database. If I click on the sales schema, you'll see down here things that I can do in this schema. So I can alter it, I can insert, I can execute, I can take ownership, I can do all this stuff, I can view definitions. And I could really start doling out permissions at very fine levels. So I could go in and give them the ability to do things at this schema. I can make them members of this schema. So there's all sorts of things that you can start to do with these permissions. So at some level, if I want them to do something like create tables, it's going to be easier to make them a DDL admin. So let's just go ahead and do that, and I'll hit OK. And we'll go ahead and run our little query here, and it should fire right away. And now he creates this table called sales.ordersCopy. So no problem. So you can dole these permissions out onesie, twosie, but a lot of times it's easier to do it through these roles. Now, you can also build your own roles, which is something that I highly recommend you start doing as you move into designing your own databases. To do that, instead of looking at my users folder, I'll look at my roles folder. So roles, and you also have schemas here, by the way. So these are all those schemas we talked about earlier. So just real quick, I want to show you the sales schema. You can see here it is. It's owned by DBO, and then permissions. So here I could add other people. So I could add people in here. So users are roles. So for example, let's go back to HR admin again. There it is. So HR admin, you can see this is sort of the same set of permissions I had when I looked at HR admin and said, what permissions do I have in the schema? Here in the schema, I can add the user and see which permissions that they are granted, or I can grant them permissions. So you can sort of work from either direction. And we're going to do that with roles. So I'm not going to change this right now. I'll hit cancel. And let's look at roles. There are two kinds, database roles and application roles. I'll talk about application roles very briefly in just a second, but we'll start with database roles. So here is the built-in ones, these guys that all start with DB. So if I look at DB, DDL data admin, it shows me who's in it, and that's about it, okay? Because this is a built-in system role. So it grants the permissions that it grants. And again, you can go look at the Microsoft documentation for specifically what each one of these groups does. But if I want to play with one of the user roles, for example, let's look at the external sales role. So the external sales role here, you'll see does not own any schemas. There are no members currently in this role, but we can add one. Let's add our payroll admin. Okay. So now I've got my payroll admin in this external sales group. But what can this group do? If I click securables over here, you'll see nothing down here in permissions. So essentially, I could now assign things to this role. So I could go search and say all objects of a particular type, and I could say tables, and then hit OK. And now I can see all the tables, and I could go through and say, okay, they need access to orders, so let's give them select permissions to orders. They need access to order lines, so I can give them select permissions to that as well. And I can go through and check a bunch of stuff like that and add permissions. Alternatively, I could search for all objects belonging to a particular schema, in this case, say sales, and hit OK. And now I see all the sales objects here, and it's kind of the same because I've got warehouse is also here because I set all tables, but I could then pick a sales table and give them more permissions. Or I could search at the next level up, so I could say all objects of a particular type, and I could say schemas and hit OK. And now I could look at the sales schema itself, and I could say, oh, here's the select permission for sales schema, and check that. And now what I've done is I've given them the rights to select from any table that's a member of this sales schema. Okay, so I'll click OK. And now we'll just go back in and look at external sales one more time, kind of to clean it up. And if I look at securables, you'll see down here, and I now have things filled in. So I now see that for the sales schema, they've been given select. And for order lines and orders, they've been given direct select access into those. Okay, so I can start to collect these roles and put people in them, and then give the role the permission the user needs, rather than having to give each user its own individual permissions. Now, one thing I do want to point out is this has been something that people have struggled with over the years in SQL Server. I give a user, and especially if I'm like in a development environment, I give a user data reader and data writer rights. That allows them to read and write from my tables. It allows them to read from my views. But one thing it doesn't let them do is execute stored procedures. So stored procedures are basically hunks of code that you can run. They're like little functions, but it doesn't allow you to execute them. There's no DB data executor role, okay? But what you can do with schemas is you can allow them to execute every stored procedure in a schema. That's actually a pretty handy way around making like a database executor role. So if you look here, I have schemas for application, integration. There's all these different schemas that exist for these stored procedures. But say I want them to be able to do the integration stuff here, these get transaction updates and get sales updates procedures. So what I can do, and we'll just do this for HR. Actually, we'll do this for our Far West sales group. Why not? I'll hit properties. We will add a member. We'll add our HR admin in here. Okay. So HR admin is now a member of this Far West sales. And we'll come over to securables, and I can then search for things, and I'll get all my schemas again. So all objects of a type. I'll pick schema. Here they are. And those were the integration stored procedures. And I can go double check that. Yes, those are the integration stored procedures. So I can click on the integration schema, and then down here you'll see there's an execute permission, and I can grant that. Hit OK. So I'll hit OK, and then we'll just go back in and look a little cleaner if we close it and come back in. There you go. The integration schema, they now have execute rights. So that means they can run all the stored procedures in that schema. So if I really wanted to make a DB executor type of role, I would have to add all the schemas, and then I could say execute all the things. So I could go through and say all objects of a type. I could add all the schemas. I could add all the all the schemas, and then give execute permission in each one. You can also list all the stored procedures and give them one by one. That's kind of a pain in the butt. So if you look at here, I'll just select a few of these things so you can see. Here are the schemas that I can put permissions against. Here's individual stored procedures I could give you permissions. And when it comes to things that are defined like views and procedures, typically I can give you rights to make them, alter them, execute them, and that's all kind of reflected down here. And then at the database level, these are alter any create any, and def here, you should see execute. So I could go to my database level and say execute, and that is truly a DB executor type role. So everything in the database you would be able to execute, all stored procedures. So you can do that through this database level. Now, obviously, we could sit here and dig through every possible permission in the database for just hours, but we're not going to do that. There are just so many of them, but this should give you kind of an idea of where you can start to go to set up roles and set up permissions and set up users. Now, one last thing I do want to touch on. We saw briefly when I was looking at the roles folder, there's also something called application roles. Application roles are kind of a unique animal. With an application role, I can create one, and you'll see it has a very similar look, not this part, but own schemas and securables are very similar to a standard role. The difference is it has a password, and there's nowhere here to say who's a member of this role. So here's how this works. We'll call this temp read, okay? And I'm going to give it a password. Okay, and I'm going to say that at the database level in worldwide importers, they can select. That makes them a data reader if they're using this application role, okay? And it's called temp read, and I made the password. And I'll hit OK. So now this role exists. We're just going to create a new user. And I'll call him EMP1. He is a SQL user without a login, and he has no permissions whatsoever, okay? I'll click OK. So if I attempt to use him to read, and we can do a little trick here. We can execute a query as another user. So what I'm going to do is open up a new query here, and I want to log back in as my admin account. So I'm just going to hit change connection and change this back to Windows, hit connect. Okay, so I'm going to paste a little piece of code in here, and essentially what I want to do is I want to attempt to run a select using the employee1 account and select all from sales orders, okay? And let's just get into the right database. And this employee1 account doesn't have any permissions, so I shouldn't be able to run this select. And this is a little trick. I use this to test permissions all the time. I can execute as an employee or as a different user using this statement. And then any code in here will execute as though I'm logged in as them. And then at the end, you hit revert, which basically means go back to being me, my admin account. So I'm going to run this, and you'll see the select permission was denied on the object because we don't have any permissions. But we want to use this application role. So the way this application role works is I can activate it at any time if I know the password for the role, and then I'm automatically given the permissions of that role for the rest of my session. So without being in any group, we can use this role. All right, so to do that, we're going to activate this application role. So I'm going to execute exec. This is the procedure, sp_set app role. You need to know the name of the application role, and it'll start helping you here with IntelliSense, and that's temp read, so I can just drag that in if I want. So temp read is my role, and I made the password. So comma, password. Okay, now, if I run this, first thing that's going to happen is it's going to execute this piece of code, which will set the app role, essentially giving all the permissions assigned to this role to this user for the rest of the session. Then it'll attempt to select from sales.orders. And you'll remember we gave this the rights to select. So I'm going to go ahead and click execute. But you can see it selected all that data when I executed as this employee. So that worked, and that user now has the select permissions for the rest of that session, which is over because the query is done. But if I was logged in as that user, I can set this app role and I can get these permissions. The message it gave me here was that the current security context that was set by app role cannot be reverted. So basically all that's saying is EMP1 still has his rights, but until his session ends, which it did. So it's not a big deal. Now, why are they called application roles? Last little piece of information here. Imagine if you have a software app that connects to your data and has to do things in your database. I have two choices. I can either give all the logins into the server rights to do stuff in the database. So I could set up 50 logins and they all could log directly into my database and do things. Or I could set up a single login that the application knows about and it could log into my database and do things. But in either of those cases, I have accounts that exist that people could then potentially use to log directly into my SQL Server and do things with tools like Management Studio. With an application role, however, I can create this role. I can give the logon the application uses next to no permissions. And when the app starts up, it can call this set app role procedure and specify the password that it knows about. And all of a sudden, magically, the application has access to do everything it needs to do in my database. But the second it disconnects, all those permissions go away. So you're preventing users from being able to log directly into your server with an account that the app uses and do anything because they still need to know that additional password. Okay, so that's application roles kind of in a nutshell. I know this is a lot. We've covered a lot of information in this, but there's sort of just a big chunk and eventually you have to just bite it off. Key takeaways, just remember you have logins, which get you up to the server level permissions, and then you can set server roles, and there's a handful of securables you can set up there. And then once you're down into a database, you can start mapping users to permissions or put users in roles, which then get permissions, or use application roles to sort of bring all your permission sets together and be able to assign those permissions out to people that need access to them. And they're divvied up by database, by schema, by type, however you want to do it. But you have a lot of granular control over what users can do. So hopefully this gives you enough to get started. And then as you expand and start doing other design with, say, functions and procedures and you name it, you'll be able to go in there and set all the permissions up and allow your users access to what they need access to in order to get their jobs done. So when you move databases around, you move the users of those databases. But the logins, which we know are set up at the server level, are handled at a very different location and in a very different way. So I want to walk you through a problem that's fairly common and then show you a couple ways you can remedy it. So on my systems here, I have two instances of SQL. And on this one down here, I have an HR database. And I just want to show you in this HR database, I have a couple of users, HR admin, payroll admin, okay? What I'm going to do is take a quick backup of this database. So I'll just go to tasks, backup, and we'll remove that file, and I just want to put it to C inside out, and I'll call it hr.back, okay? And I'll just copy that because I'm going to use it again, and I'll hit OK. I'll do a full backup, and I'll hit OK, and the backup succeeded. No problem. It was a quick, small database. Now I want to come up to this other instance, which is another server, and I'm going to restore that backup. So restore database. So I'll go from a file, and I'll add, and the file I want is the one we just used, C inside out hr.back. I'll hit OK, and I'll restore that as the HR database. This kind of handles the move, so you'll see that this will restore to my inside out 2, which is where it came from, but I don't want that because that would then overwrite the file that's in my inside out 2 instance. So I'm just going to change that inside out 2 to inside out, which is the path for the instance I'm restoring this to up here, SQL inside out. If you want more information, there's a whole lesson on backup and restore that you can go reference for some of this. I'm just doing this quickly to show you the issue with a migration. So I'll just go ahead and hit OK. And it says the database has been restored successfully. So I'm good, right? All set, no problems. But here's what happened. So remember, SQL Server security is broken into 2 parts. Logins get you access to the server, users get you access to the database. And I just backed up and restored a database. So it would have brought its users over. So if I look in the HR database, under users, there's my payroll admin, there's my HR admin users as expected. So everything's peachy keen, except if I look at the security folder on my server level and look at logins, I don't have an HR admin, I don't have a payroll admin. So these users came over, but they don't have access to this server, okay? And if I look at the user directly, so let's just pick HR admin, I'll double click him here. You'll notice that on general, he is now set up as a SQL user without a login. So this user account exists in this database, but it does not have a login on the server, okay? Now there's a couple ways that you can migrate logins. And there's an article that Microsoft has had in its support base forever. And you can see it's dated 11/2 of 2022, but this article has been updated over and over and over and over again. And it's one of the ways you can transfer logins between instances of SQL Server. And it gives you a few options for doing it. One is reset passwords. Two is transfer the logins from server A to server B. And you can actually do, I think it talks about it in here. Yep. You can use SSIS to transfer logins. There's a couple different ways you can do this. But essentially, this is the easiest way. And this particular article tells you how to do it. So there's this giant section of script here. And this section of script is something you can create that will allow you to basically script out information from the SQL Server to copy logins over. So I'm going to click this copy button here, okay? And then we're just going to switch back over to our SQL instance, and we're going to do a new query on our inside-out server, okay? Our to server, where the database came from. And I'll just paste all that code in, and you can see it's quite a bit here, but I'll just run it. And what this is going to do is it's going to create a couple of stored procedures, and it talks about it here in the documentation. It creates two stored procedures, one named SP hexadecimal and one named SP help rev login. Okay, help rev login uses hexadecimal to do a couple fancy little things. And so I'll just flip back over. I don't know why this isn't just built in to master. They just never have. And I'll just delete all this code because we don't need it anymore. And we're just going to run SP help rev login. Okay, this is the procedure we just created in master. You'll notice it's mad at me because it can't find it. IntelliSense doesn't know it existed. Little side tip, if that happens and it's something you just created, it just means your IntelliSense database is out of cache, so it doesn't know it's there. So all you have to do is go to Edit, IntelliSense, and then refresh the local cache. And now it should go refresh and realize SP help rev login is in fact a thing that exists in the database. So just a little side tip there. All right, I'm going to run this. And you'll notice this spits out in text format. Now this is important. You want this in text format. If this was in grid format, it would be way harder to read. And so you want it in text format, which is great. What I'm going to do is I'm going to copy, Control A, I'm going to copy what it generated in this output, okay? Then I'm going to go over to my second SQL Server, run a new query, and I'll paste that in here. Now you'll notice what this is doing is it's attempting to create all the logins that exist on that secondary server. So I'm going to kind of go through, they tag each one with a comment. Login, this one, login, this one. I don't want all these system logins. So I'm just going to start looking through and deleting it. I don't want employee one. I don't want my login. I do want HR admin. So I'll delete those up above. I'll leave the HR admin. And I don't want that one or that one or that one. All these services I don't want. I don't want that. I do want payroll admin. That was my other one. And I don't care about the completion time. All right. So you'll notice what this is doing is it's basically scripted out the logins and all their permissions from the other server and then turned it into a create. So I can use this script to recreate that login someplace else. So you'll see it'll only do it. It has a check. So if it doesn't already have an HR admin login, that's what this is doing here. If it doesn't exist, a principal with this name, then begin and create the login. After creating the login, you'll see it also executes add server role member to add it to any particular roles that it might have been a member of. In this case, both of them did have that. Now, what about the password? I had set both these accounts to have the password of password. Well, using some of those hexadecimal procedures it created and a little bit of internal magic, what it was able to do is get the password out in hash format. So this is sort of how SQL Server hashes and stores the password in the database. But it's not human readable, and the way it works is when you log in, it takes whatever password you're providing, runs it through a similar hash, and matches it to this. And if the hashes match, you've used the right password. But SQL doesn't really store your password. Any good system shouldn't. So it stores this hashed version. So using that other procedure that it put on, an SP help rev login, it was able to recover the hash from the store. And now I have the password's hash. And so you'll see when I create the login with password, normally with password equal, you specify what you want the password to be. But if I scroll over here, you'll see after that long hexadecimal string, they added hashed, so that they know that that password that it's being provided is the hashed version of the password. So that's step one. We were able to get the hashed version of the password. Now step two, this is all for the linkage. Okay, so when you create a login at the server level, it has what's called a SID, a security ID, and that's this big value here. And if you go look in the sys logins table, you can see this SID, but this is how you make that link between a user and a login. So the user in the database says, hey, I'm a user, and the login I'm tied to is that SID. Okay, it doesn't tie by name, it ties by SID. So in order to de-orphan these users we have in the HR database, the logins with the correct SIDs have to exist on my login side. Okay? So here it goes ahead and grabs the security identifier, and these are sort of randomly assigned at the time you create the login. So if I were to just go create a new payroll admin on my new server, it would have a different SID, and therefore the linkage between the HR database and the login would not work. So that's why this has to grab the SID and bring it over. So then you can see it just sets the default database to master and basically all the other quick stuff that you would use whenever you set up another user. So we're going to go ahead and execute this, making sure we're on the inside out server. We are. So I'll just hit execute. So after I clicked execute, you'll see the command completed, and we should now have these logins on our server. So we'll go down to the security folder. We'll look at the logins, refresh, and bring up our Object Explorer details, and you'll see here's HR admin and here's payroll admin. Now those should be created with the same passwords and the same SIDs that they were created with from the previous server. So we look at our HR database now, and we look at users. I'll do a refresh here, and I'll double click HR admin. And you'll see HR admin, if I come back up to general, is now set to SQL user with login. So you remember before we did this, it was set to SQL user without a login, and it didn't understand the linkage. So by using that SP help rev login, I was able to pull the server logins over, and then my database linkages were maintained. Okay, and had I just created it manually, an HR admin account, the linkage would have been gone, and I would have had to go in and remap the user to the login. So I was able to migrate using those SP help rev login stored procedures. Now there's a couple other ways. SSIS, for example, offers some tasks that let you do something similar. This really comes into play in two areas in SQL Server. One, kind of like we did here, I'm migrating a database to another server, so I need to make sure I migrate the logins. You might also be doing a high availability standby server, either using replication or something of that nature, and you have two SQL servers where you're replicating the data from a database across to have a hot spare or a standby server. And if all you do is migrate the databases from server A to server B, when it comes time to fail over, if server A crashes, you won't have any of the login information. So it's a good idea to look into these sorts of processes, either using SSIS, which we didn't cover, that's a little more complex, or using these kind of stored procedures to migrate the logins from server A to server B regularly. So it's important to keep in mind that you have to do something like one of these processes to regularly migrate the logins from server A to server B, so that when you do fail over, those logins are in place and you don't have a bunch of orphaned users in your database. So hopefully this gets you what you need to start moving logins around. And if you've had issues migrating databases, this should help you fix those issues and keep those users linked to their proper logins. Welcome to our lesson on securing the server and data. Beyond basic login and user security, SQL Server offers more secure ways to protect your data from potential breaches. If you store sensitive data such as medical information, credit card data, or other personal information, then protecting that data is of the utmost importance. You may even have to prove your data is safe during an outside audit. In this lesson, we'll handle SQL Server encryption, we'll set up row-level security, I'll help you understand data masking, and we'll configure SQL Server audits. Let's get started. So quite often, our SQL servers are holding data that could be considered sensitive. I mean, how many times have you received an email saying your login and password or your credit card number was part of a data breach and they recommend getting a new credit card or changing your password? It happens because companies out there have your credit card number and they have your passwords. And so you have to take good care of that data to make sure that no one can breach that data and therefore undermine your customers or undermine your internal information. So one of the things SQL lets you do inside a database is encrypt certain pieces of information. So let's take a look at our worldwide importers database and find something that could be considered sensitive. So I'll just write a simple query to select star from sales.orders. There we go. And we'll run that. And you can see I have a lot of information in here about the customer, the salesperson ID, a purchase order number, things of that nature. But I also have invoices in here. So what if I select data out of my sales.invoices table? This might have more personal info. Doesn't really. It's got credit note, customer purchase orders, things of that nature. So what we're going to do is let's just stick with the sales.order table here. And there's a customer ID column in here. So this isn't particularly sensitive, but if this were something like a credit card number or whatever, you could see why I might want to encrypt it. And what we're going to do is we're going to encrypt this column so that the data in this column is obfuscated. And if it were breached, people wouldn't be able to read it. So to do this, I'm going to right-click Worldwide Importers. I'm going to go to Tasks, and I'm going to select Encrypt Columns. This is going to bring up kind of a lengthy looking wizard, but this allows me to encrypt data. So you'll see it gives me an intro and it's literally going to walk me through like a standard install wizard. So the first thing just sort of tells you about what we're doing. I'm going to click next and then it wants me to select my columns. So you'll see here I have access to all the tables in my database. What I'm actually going to do is use this orders copy table because I don't want to have to deal with any sort of foreign key or primary key constraints. But this orders copy table does contain the same information as the orders table. So I'll just expand the little teeny plus mark there, and I'm going to select the customer ID column. Now over here on the right, it's asking me the encryption type and the encryption key. So if I drop down the type, you'll see I can choose between deterministic and random. We'll just use deterministic here. And then for the key, it's going to create me a new auto key. You see it's CEK auto 1. So that's fine. I can go ahead and use its encryption key. Now, again, Microsoft provides little handy links up here for more information on types and keys if you want to use it. And as always, you have the help button up here to go get some more information off the web. So once I've done that, and if you've selected a bunch of these, you can actually click this little box here that says Show Affected Columns Only, and it kind of helps narrow down. So under Orders Copy, you'll see I don't see all the columns anymore. I just see the ones that have encryption. So if I'm looking at a large table, or I'm doing a lot of these, I can use that checkbox to sort of filter down and only see columns where I'm doing encryption. So that's the only one I'm going to do for now. So I'll click Next. Now it wants to know how I generate my column encryption key, and I can select a column master key, and I can auto-generate one now because I don't have one otherwise. And then I can choose to store that either in the Windows Certificate Store or in the Azure Key Vault, and my source can either be local machine or current user. So I'm going to stick this to current user, so it'll store it for me logged into Windows right now. Okay, it won't be for the whole machine. And I'll click Next. The run setting, I can either generate a PowerShell script to run this later, or I can go ahead and proceed to finish right now. So this is sort of like scripting in any of the other dialogues in SQL Server. I can choose to script it out or run it now. The only difference is this is a PowerShell script that it actually would generate. I'm going to go ahead and say proceed to finish now. Click next. And again, I get the summary of everything we're about to do. We're about to encrypt this column in orders copy. We're going to encrypt customer ID, and we're setting up new keys for everything. Okay. So I'll just hit finish, and it's going to go through and take a second. It has to generate my keys, and then it has to go through and encrypt the actual data. So it has to walk through the whole table and encrypt that particular column. And this key, again, is stored on this machine, so I should be able to use it to read this data, but I'll show you what it looks like once it's encrypted. Okay, so it's all done, and you'll see on the right over here under details, everything says pass. So it was able to create the keys, and it was able to encrypt my column. So I'll just hit close, and this should be all done. And now I'll just rerun here. I'll just get rid of this invoices line since we didn't use that one. I'll run my select all from sales.orders, and you'll see I still see customer ID. Okay, but let's use one of our other users that has access, and let's just make sure we have one of those. I'll create a security login. Go to our HR admin and make sure HR admin is a data reader. Into worldwide importers. There we go. And then we'll create a new query, and we'll be them. Change connection, and we'll use SQL authentication, and we'll go over to HR admin. And we'll type his password. There we go. And we want him to run the same select from sales orders and hit execute. Oop, I have to change the database. Always double check your context to make sure you're in the correct database. So worldwide importers, and we'll hit execute. And select permission denied. And that makes sense because we just gave him a access to the database. We didn't make him a reader. So we can fix that easily by going back to logins here. HR admin, and he's mapped into worldwide importers, and we accidentally checked deny data reader. So we'll just go ahead and check data reader. So that's just another security thing to keep in mind, is that there are two data reader groups. One gives them rights and one takes them away. So we had taken them away, which is fine. It's an easy fix. We'll make them data reader. We'll hit OK. And now we come back to HR admin and we execute our query. And you'll see I still see this information here as unencrypted. Now that that column has been encrypted, and remember I did it in this sales order copy table, so I'm going to get rid of this invoices select here, but we do want to select star from orders copy, which is the one we put the encryption on. So down here you'll see this is the result of select from sales order. So the column here unencrypted, not surprising, but we had copied this all into the orders copy table, and this one we did encrypt. So if I run a select star from orders copy, you'll see this customer ID column is now completely obfuscated. So if this data were to get lost, or maybe a backup gets stolen and someone restores this to their system, they would see this. It would be a bunch of garbage data unless they had the key on their system. Now, my system does have the key. That's how we were able to encrypt the data. But how can I then see the data in my database? Well, that's a property of the connection to the system. So what I'm going to do is hit change connection here. And I'm going to leave the login as myself. So we'll put this back to Windows. Okay. So I'll still log in with the same account that is logged in the query that shows the garbled information. And there's an option, and I just copied it to my notepad so I'd have it, that you can specify to your connection. So down here, I'll click options. Over here, I'll hit additional connection parameters. And then you'll see each string here gets sent in clear text, but these are parameters that are passed as part of your connection. And so what I'll do is I'll set this little setting, which is called column encryption setting equal enabled. So I'm enabling column encryption setting. It's a little bit weird that you're enabling encryption to see it, but it's the way it works. It's just how they name these parameters. And now I'll go ahead and click connect. And I'm back in. I went back to master because that's my default. So I'll change that back to worldwide importers. And now when I select from orders copy, you'll see I get a parameterized always encryption message. And essentially what this is telling me is that I have encryption on, and there's some query options I can enable or disable. And I'll just go ahead and hit enable here. But what you'll see now is customer ID is no longer encrypted. So because I specified that parameter, I was able to tell it it's okay to go ahead and decrypt this data because I'm a user that is authorized to see it, and the key happens to be present on this machine. So if I were to move this data to another server, that key doesn't come along with it, so this data would still be encrypted. Okay, so this was a fairly simplistic example. Obviously, you could go through and pick many columns in various tables and set up different keys and store them in Azure, and there's a lot more you can kind of do with this, but this should give you the basics of how to get started with encrypting columns in SQL Server tables. So SQL Server security can be pretty granular. And without too much effort, I can actually block people from seeing certain columns in tables. I can also block people from seeing rows in tables. So for columns, it's actually very, very simple. I can go into a particular database and into a particular table, and say this special deals table. And if I look at this table and look at permissions, I can add people. So for example, my HR admin account, I can add him to this table, and I can give him permissions to do certain things on the table, whether it's alter or select or whatever. But one of the things you'll notice when I click down at this permission, so let's say I give him select permission, I get this button that says column permissions. So I can click on that, and then I can go through and say, you know what, he only gets access to these 5 columns or whatever it is, and hit OK. And if I do that and run a select statement with my HR user, he'll see this table, but he'll only see these 5 columns. So that's semi-useful depending on if I'm trying to hide information from my users. I can also do that by creating views to limit what they can see. But what if I want to limit them to what rows they can see? And that's what this is all about. In here, you don't see a row level permission. This is done in a slightly different way. It's not necessarily a permission set. So let's click cancel out of this box. And I have this demo. Now, there's a decent amount of code here, but we're going to kind of walk through each piece. So the first thing I'm going to do is create 3 users in my database: a manager, sales 1, and sales 2. So salesperson 1, salesperson 2. You'll notice I'm creating this without logins because I don't care if they can log onto the server or not. So we're going to do this inside of our HR database. So we'll just change our context here to HR. Okay? And we'll run that piece. So that basically created 3 users. So if I go to security, expand users, and refresh this, you'll see I now have manager, sales 1, sales 2. Okay? I want to create a tiny table in here. So I'm going to create a table called sales. It's going to hold an order ID, the rep who sold it, a product, and account. So for that, I'll create the table. There we go. And we're going to insert some orders. And I didn't put order IDs, so let me just add that real quick. I'm going to add order 2, 1, 2, 3, 4, and 5. So just real simple order numbers. This obviously would not be part of a production schema, but not a problem. So now I'm going to run this insert statement to put these things into sales. And you'll see these first 3 sales were done by salesperson 1. That is the sales rep. Here's the product they sold. Here's the quantity. These second 3 were done by salesperson number 2. Okay, so we'll just run that insert statement. Done. Now, if I select all from that table, you should essentially see that that table contains the data we just inserted. No big surprise there. But right now, I can select from it. These users cannot. So I'm going to skip down to the bottom here for a second, ignore all that. Down here, I have some code that uses a special execute as statement. So I can essentially run this select statement as though I were logged in with this user. And I, as an admin, have the right to do that. So you'll see, I'll just do the first one here. I'll highlight this first guy. If I attempt to execute as sales 1, select all from sales, you'll notice I get select permission denied. Okay, so I want you to see that the select is happening as that user and not as me. So if I scroll back up, right here, I'm going to grant select on those tables. So essentially the statement for that, grant select on table name to user. So I'm going to grant select on sales to manager to sales 1 and to sales 2. Okay, and I'll hit execute. So now all 3 of those users have select to this table. So if I come back down here, and I'm going to highlight all 3 of these users and all 3 of their select statements and hit go, you'll notice I get 3 queries returned. And all the queries have all the data. Okay? I don't necessarily want that. What I want is when sales user number 1 looks at the table, they can see their sales. And when sales 2 looks at the table, they can see their sales. And when manager looks, he can see everything. That's how I would like this set up. So in order to do that, we have to set up some row level security. So the first thing I'm going to do to make this work is I'm going to create a brand new schema just called security. And I'll execute that. And you'll see that now in my HR database, if I refresh here, I have this brand new security schema. And I'm going to use this schema to store the functions I need in order to make this row level security work. So this first function I'm going to create is a security predicate. And essentially what this is going to do is it's going to take a sales rep name. So it's going to be passed in as part of the function. And it's going to return a table. And it has schema binding on. And this is all kind of some function creation stuff that you don't have to worry about too much right now. But what I'm going to do is I'm going to return the value of 1 as a column name called function security predicate underscore result. And essentially, I'm going to compare the sales rep value you passed in with the username. So username is a function that basically returns the current user. So if I were to run select username, and I can show you that real quick, I'll just come up here and put another column in, select username, and run this, you'll see it kicks back DBO because in this database, I am DBO. Okay, so that's what it comes back as. I'm database owner. So basically what this function is doing is says compare the sales rep value you gave me to username. And if you gave me sales rep 1 and I am sales rep 1, then say, yes, I'm able to do this, return a 1. Just to be a 1 in a column in a row. Or if the current username is manager, return a 1. So the 1 essentially says you have the rights to look at this data or you don't. Okay, and so if the username matches the running username, we're good to go. And if you're manager, you're good to go. Okay, so that's just the function. That's all that's doing is comparing the current user to the user we're selecting in. So now, in order to apply this function and use it to do row level security, what we need is a security policy. Okay, so let me create this real quick. Go. And now we have our function. And then we're going to come down to this portion here. We're going to create a security policy. So we're going to create a policy called sales filter. And we're going to add a filter predicate. So the filter predicate is what's letting us do row level security, filtering data. Okay, we're going to use this function and pass in sales rep. And sales rep is the column name. So remember, if I go back up to this column, it has a sales rep column. So we're passing in the sales rep column to this function. So the sales rep column contains the name of the user, remember, either sales 1 or sales 2. And then it compares that value from that column to the actual running user. So essentially that's what we've done here, and we put it on the sales table. So now when we select, it's going to pass in a value from the column for all the rows for the sales rep and compare that with my currently logged on user. Okay, so I'll just go ahead and create this security policy. I'll execute it. And now that is in place on that table. So now what happens when I go ahead and run as sales 1, as I'm selecting this, it takes the value from the sales rep column, which remember is either sales 1 or sales 2. And here, let me just run that select real quick so we can look at it as we talk about it. So here's, and see, I'm not either of these people. So now I'm blocked. So because of this filter, I'm not manager and I'm not sales 1, so I'm actually blocked out. So what I'm going to do real quick is I'm going to run this as manager just so we can see the data. So you'll see when I run as manager, I get the entire table. And remember, this column was sales 1 or sales 2, the name of the person who actually sold the product. And so with this predicate, it passes the value from sales rep in. And if that ends up matching my user, so if I'm sales 1, then return me all the values from all the rows that have sales 1 in this column. Or if I'm manager, which is how this happened, is how I got all 6. And if I'm sales 2, return me just the sales 2 rows. And if I'm anybody else, sorry, you can't see it, which is why I was unable to see it when I ran the select star up above. So I'll execute here as sales 1, and you'll see he only gets 3 rows, and it's the rows that belong to salesperson 1. And salesperson 2, same thing. He gets 3 rows, but only the things that belong to him. And manager can see it all. So I'll just run all 3 of these just so you can see them side by side. Sales rep 1 gets 1, 2 gets 2, manager sees it all. So it's a little complicated, and it's a little harder than just setting up security by using the GUI, but between a function, and this function can do anything you want, right? It's going to essentially take in a column name, and then you will then base the value of whatever it's passed in. So in this case, whatever values are in that column, you can create a function here that does whatever you want. So based on the value in the column, do I want to compare this to the currently logged on user? Do I want to look at dates and times to see if this data is usable? The sky's kind of the limit, but if you're going to do it for security purposes, you're typically comparing it to the currently running user in order to filter this data out. Okay, so that's how you can do row-level security inside SQL Server to make sure that even when people have access to the same table, they're only seeing the things they need to see. Now, alternatively, you could do this with a function that returns a table, possibly passing in the username. You could create views, but with views, you would have to create a view for user 1 and a view for user 2. But with this, I can just still use the same table, and I can filter that data out. And the beautiful thing here is because this is filtered row level at the table, if I were to create a view based on this table, this still applies. So the user coming through the view would still be row limited. So it's a good way to hide sensitive data when there's multiple users that access the same table, and they only need to see subsets of that particular data. So among all the ways you can protect data in your SQL Server, one of them is data masking. So I can block access to rows, I can block access to columns, I can encrypt data, but what if I need to see some portion of data, but not necessarily reveal all of said data? And that's what data masking is all about. And it'll make more sense here when we walk through this demo. So in the Worldwide Importers database, I'm just going to make a new query. There is a column in the people table that contains email. So if I say select all from application.people and I hit run, you'll notice over here that there's a login name that contains the email of that particular person. And while that's not necessarily super sensitive info, you can mask email addresses so that someone could see a little bit about it, but not see the whole thing. So it's sort of like when you call the bank and they say, oh, is this the credit card ending in 1234? They can see the last 4 of your credit card. They can't see the whole thing. Same thing with give me the last 4 of your social. So you can mask that data. So I have it, but it's not available for everybody. So to do that, we have to apply a data mask to this table. There's a whole article out on Microsoft MSDN called Dynamic Data Masking. And I'll just bring that up. And this is a great article to go look at if you want to understand all the different things that you can data mask. There we go. And this kind of walks you through all the different things. And here's how you define the data mask. And there's these different functions. And these different functions sort of know how to mask data. So you'll see here there's a full mask. It maps according to the type, and then it uses X's for the different kinds of characters. Here's an email mask, which is really what we want to do. So what happens with the email mask is it leaves the first letter of the email turns everything else in the email except the @ symbol to X's, and then you see the .com at the end. It even gives you a little syntax here of how to do it. So I'm actually going to take that syntax and we'll just copy it because it's exactly what we're going to use to mask this column. And then we'll write an alter table statement. So alter table, and it's going to be that same table, application. Here, let me just paste that real quick, then I can copy. Copy and paste is your friend when you're writing SQL queries. I'm going to alter table, application people, and I will alter the column. In this case, it's logon name. Okay. And I will add a mask to that column with the function email. So it treats it like email and it masks it like it's email. Now, some of these have no login, but others that do are all email addresses. So we'll see what happens when I apply this mask. So we'll just alter the table here. It said completed successfully. So now let's take a look at the data in that table. And lo and behold, nothing has changed. That is because I want you to remember when you mask data, you still have all of it. It still exists. And you can still give people permission to read the raw data and not be stuck reading just the masked data. And because I'm running all this with my system admin account, I, of course, can read right through the mask and I can see the underlying data. All right. So what we need here is a user that can't do that. So in our worldwide importers database, I'm going to create, under security, a new user. And I'm going to make a user without a login because I don't care if he can log into SQL. I just need someone I can run a query against. And I'll just call him salesperson. Okay. And what I want to do is I want to give him access. In fact, I could give him access to DB data reader. That's fine. So he can read all the tables on my database. And I'll hit OK. So now I'm going to use the handy dandy execute as command to execute as a different user. And I'll execute as salesperson. And the query that I want to execute is this same select that I was running earlier. So I'll select all from application.people, and then I'll revert back to myself. Okay, so this will run select all from application people as salesperson, which is the user we just created who has DB data reader rights. So I'll highlight that and I'll run it. There we go. And you'll see for him, because he doesn't have the rights to read through the mask, all this data gets masked out. And I can see the first letter of the email, then a bunch of X's, and then .com. Okay, and if you scroll down, you'll notice for some of these, they're all N, a bunch of X's, .com. So it's not actually showing you the real extension. It's always going to say .com if you use this particular mask function. So if they had a .edu or a .gov, you're not going to see it. And any place you see this N with all these X's, .com, that was one of the users that had a no login. So it took the first letter of the data in this column and it appended xxxxx.com. So you have to be careful which function you use because this still looks like email. So essentially this mask doesn't really know this is email and it just applies this. So it's the first letter and then xxx@xxxx.com. So really it just takes that first letter and pastes this over. So you have to be a little careful when you're using this. Because the way this was masked, I can tell by looking at this was supposed to be an email. That's the whole point of this mask, is I still know that was supposed to be an email address, even though I can't see it. So I'm just going to show you a quick example. There's another table in this database called warehouse.colors. Okay, and I'm going to paste an alter table. And before I run this, let's just look at warehouse.colors. I'll just copy that. And I'll put it up here and we'll do a select star from warehouse colors. Okay. And I'll run my search and you'll see my color name here is listed in plain text. So I'm going to alter warehouse colors and I'm going to mask that color name column with this email function. And F5. So again, I have to go execute a select as a user without permissions to read through masks. So we'll copy this down to our salesperson execute as, and I'll run that. And you'll see color name is now masked like it's an email address. So you have to be careful which mask you use. Obviously, I've successfully masked this data, but a user looking at this would be like, why are color names emails? And so that's sort of the high level of how you mask. Again, this article that I pointed you towards on MSDN here is fantastic. And if you look through, you can see all the different masks types you can do. You can do a random one. You can actually create a custom string. You can do date time masking. So you can do all these different things. And this even talks through the permissions on how you can mask and unmask and how people can read through the masks and stuff like that. So take a look at that article if you need a little bit more information on how some of these masks work. But again, this is just one other way where you can obfuscate data in your database to make sure that the people looking at your data can only see the things that they need to see in order to do their jobs. So in this lesson, we're going to take a look at using audits inside SQL Server to track when something that's sensitive to your data structure has changed. So it's a way for you to audit things that are happening inside of your system and logging those changes so that you can review them and potentially look at threats or problems that occur if something's changing that you weren't expecting. So audits are sort of configured on two different levels, the server level and the database level. So again, sort of like all security in SQL Server. We're going to start at the server level, and under the security folder, I have this audits folder, and you'll see there's nothing in my audits folder at the moment. So I'll just right click and select new audit. This pops up, and this is essentially creating the high level audit. What's the name of it? Where is it going to be stored? And some other parts of information. So for this, we're just going to call it sensitive changes audit. That's fine. And it can be stored in a couple different places, and we'll come back to some of these failures in a second. I can store it in a file in the security log or in the application log in Windows. And for this demo, we're going to store it in a file. And I'll just put it in our C inside out folder on my hard drive. And I'm able, because this is a file, to sort of control how big I can let this audit get. So you'll see here that I have an audit file limit, and I can do maximum rollover files, and I can select unlimited, meaning I can keep rolling over and having new files created as I fill one up. Or I can uncheck unlimited, and then I can say, this is the max number of files I want. The other thing, and this is a very confusing looking dialog. The other thing is, if I select maximum files here, I can specify the max, and down here I can specify the space. Okay, so maximum number of rollover files, maximum number of files, period, and the space. So you'll see if I leave this all on maximum, unlimited, and unlimited space, this could certainly grow and take up some space on my hard drive if I'm auditing a lot of things and there's lots of changes that are occurring. You can uncheck unlimited here and also set the size in gigabytes, terabytes, megabytes, whatever you want. And there's this reserve disk space button, which you can't do because maximum file size is checked. So you would actually have to uncheck a few of these things, and you can then reserve some space. It's a whole thing, and you can kind of configure this however you want. So there's my maximum file size is 2 meg, but I can still have a billion files. So really, I'm not going to configure any of this. I'm going to leave it on unlimited, but this is my way of saying, be careful when you're setting this up because you could store a lot of data and you could put a lot of things into these logs. So again, I have this sensitive changes audit. It's going in this folder. If there's a failure, so if on my failure, what do I want to do if I have an audit log failure? Do I want to continue, or do I want to fail the operation or shut down the server? So if I'm unable to audit something, do I just forget about it for now, or is auditing so important that I need to fail the operation, or is it so important that I need to shut down the server if I have an audit failure? So you can kind of pick whatever you want here. For this demo, I'm going to leave it on just continue, and it'll roll on. So I'm going to go ahead and hit OK. And that's going to create the audit, but it doesn't tell me what I want to audit. All that literally said was where I audit to and how much data I save as part of that audit. So to really audit something, I need to do that at the database level. So I'm going to go into my worldwide importers database here, And under its security folder, you're going to see another folder in there called Database Audit Specification. Sorry, it wasn't just called Audit. They've changed it a little bit. And again, I can expand this. There's nothing there. So I'll right click and I'll say I need a new audit specification. So this is going to specify the thing that I want to audit in this database. Okay. So the name here, and I'll just call it the order audit because it's what I'm going to audit. You basically specify a name for the database audit, and then you have to specify the server audit. So this is going to go to my sensitive changes audit. So one server audit could be receiving data from multiple database audit specifications. Okay. So order audit, and now we get to specify the things we're going to audit down here. My audit action type can be any of these things. I can check for batch started. I can check for application role change passwords. I can check for schema being touched. I can select insert, update, delete. I can select any of these things. And when that kind of action occurs, I'm able to audit it. So what I'm going to select is delete. Now remember, in the context of SQL Server, delete means remove rows from a table. So this wouldn't be delete a table, this would be delete data from a table. So from here, I'm actually going to click this little ellipses next to object name, and I want to look at the sales order table. So I'm just going to type in orders. It'll come up with this search because it found multiple things with that name, and I'll select sales.orders right here and hit OK. Now you'll notice when I do that, because I worked it from the object back, it filled everything else in for me. So I'm auditing deletes on an object in the sales schema, and the object's called orders. Okay. Here I could put a principal name. So I'm auditing when a person, group, or whatever does this. And I will do that. I'll just hit browse. And what I'm going to do is I'm going to audit DB owner, because DB owner is the account that I'm essentially using in this database. So that'll be the easiest way to audit. So that's the last piece of the puzzle there. I hit OK. And now anytime DB owner deletes something from this sales schema orders table, I should know about it. Okay. So I'm just going to hit OK. Now you'll notice there is a little red X. Let's zoom in on this audit here. There's also a little red X on the server audit here. That is because when you create audits, they're not active. So right now these things exist, but they're not doing anything. So we're going to start at the server level, and I'll just right click this guy and I'll say enable audit. That's successful. That audit is now usable and running. And then in the database, I'll also right click and enable the audit. So that comes up and now that's in use. So the nice thing about this is, say I had an audit in two databases, or all three of these databases, HR, Worldwide Importers, and this Inside Out DB. If I want to cease auditing for a period of time, I could just disable the server level audit by hitting disable audit. Now all three of those database audits would no longer provide information. If I just want to turn off Worldwide Importers, I could go into its audit and disable it, leave the server one alone and the ones in the other databases alone, and they'll continue to audit. So you kind of have a bit of a level as to where you can control these switches into what's auditing and what's not. Now, if I right click this, you'll see I don't have a whole lot of stuff here other than scripted policies, but I have reports, delete, so there's not much here. And if I pull up the properties, I go back to the settings I had before. If I look at the one on the server level and I right click it, you'll notice I also have view audit logs. So remember, the one on the server level is the one that says where everything's being stored. So it has access to the logs. So I'll bring this up and you'll see right now that this audit collection has the sensitive changes audit, and nothing has happened because nothing has happened. So what we're going to do is we're going to do some stuff in the database to make something happen. So I'm just going to close this out. We're going to start up a new query here. And let's do a select star from sales.orders and just take a look at what's in this table. Okay. And I want to get rid of some data. So let's delete from, it's the same table, sales.orders. And we'll delete where the order ID equals 3. And actually, this is going to be fairly angry with me because there's probably foreign keys pointing back to this order row. And then it's going to tell me that it can't because there's a foreign key on sales order line that conflicts with this particular table, and therefore I can't delete it. So what I'm going to do is add another table to my audit. So I do have this copy of this table called sales orders copy, which I've created, and it does not have any of the primary keys or foreign key relationships. So we'll add a second object into here. There we go, delete. All right, we'll select delete. And again, same thing, it's an object. It's in the sales schema, and it's called order. So we'll click the ellipses here, and we'll type sales orders copy, and there you go. And again, I will audit it for the principal DB owner. Okay, okay. So I'm going to click OK. Now you'll notice I get an execution error. This is because the audit's running. So in order to add things to an audit, the audit can't be running. So we looked at enabling it. Disabling it is just the same. You right click, you disable the database audit specification. This little window pops up, says success. And now if I go back to my save window here where I added orders copy and hit OK, it adds that other table to the audit. And now I have to restart the audit. So we'll just right click and enable it. And again, it says success and the audit's off and running. So now we'll delete from sales orders copy where that particular order ID equals 3. And off we go. Execute. And you'll see I have one row affected. If I select from my sales order copy table, you'll see order ID 3 is gone. This is actually stored differently because it doesn't have indexes. So I will put the where clause on there just to show you that there is no longer, there you go, nothing. There's no longer an order with ID of 3. Okay, so we deleted 3. Let's just delete 2 and maybe 1, and just some deletes happen in that table. And this should all be being audited, and I should be able to look at that back at the server level on the audit log. So to get to that data, I'm just going to right-click on my audit, and I'm going to select View Audit Logs. All right, and then when the audit log comes up, I'll just expand this. You can see these different messages were all logged from my inside out SQL Server, and there's different things that occurred. You can click each one of these, but the detail is sort of down below in this text section. So if you read through this, it will tell you that a particular person, in this case me, in a particular database, Worldwide Importers, sales order copy, deleted a sales order where the order ID equals 4. So you can see the statement I ran, and that's all audited right here into this log. So if I have a sensitive table, or I'm watching for some sort of malicious behavior, turning on this auditing can allow me to see exactly who got into my database and did what. So again, this was a fairly simple look at database auditing, and you saw how we only did one table and one statement type. You could turn this on for entire schemas, for a whole bunch of tables. You can audit specific users. There's not just deletes, there's inserts and select and permission changes and logins and logouts, and you can audit all this kind of stuff to really keep tabs of what's happening on your server. And then if you do fall victim to either someone trying to hack your data or some sort of a malicious attack, even by an internal person, hopefully these logs and this audit can help you figure out exactly what went on and possibly even help you recover your information.